Testing, testing, testing. 1, 2, 3. Yes, it's quite audible. Yes, thank you. I see we've already started with the opening remarks. The opening remarks are testing, testing, 1, 2, 3. Stage. On with it in a minute. With the theatrics right away. One last time, testing. Yes, good. Okay. Hi, everyone. Good morning. Welcome to Cloud Native Rejekts, NA 2024 here in Salt Lake City. I hope you enjoyed the views of the mountains on your way here or whenever you got here. I think that was the highlight of my trip, honestly, so far. Besides being here at Rejekts, of course. But yeah, I hope that turns into a great experience for all of you. I'd like to start with thanking all of you for coming. I know that in our planning efforts in the last few months or so, it just seemed like we don't really know what capacity we need to account for, if people will actually turn up for Salt Lake City or not. So it's actually quite heartwarming to see the enthusiasm around last-minute tickets and registrations and people actually making it. So thank you so much, and a huge round of applause to all of you for making it. Thank you so much. Yes. So for all things registration and code of conduct related, I do request that everyone check in at the registration desk. Do encourage folks to come, but at this point of time, we do have limited capacity in terms of how many folks we can actually accommodate that are not confirmed registrants. So yeah, just keep that in mind. But we'll try our best to accommodate everyone. And yes, I'd like to start with thanking our volunteers. And there's lots of notes of appreciation and gratitude that will follow. So bear with me. It's a lot of people that actually come together and kind of help make a community event like this possible. So I do feel like the best way to go forward with this in terms of opening remarks is to start with the thanks right at the beginning. So I'd like to start with thanking all of these volunteers who were here yesterday, a lot more of you that are here today, assigned to various duties and tasks, and to ensure that everything runs smoothly. I can't possibly do it all alone. So thank you so much for collaborating so well, for being on time, for taking the reins and for owning things and for running with it. I appreciate it more than you know, so thank you so much. I'd also like to give a strong word of thanks to the org team, to Lexi. Lexi's here, Andy, Chris, who should be around at some point. We're all the org team, and you'll see that on our badges. So if you'd like to chat about anything rejects, feel free to chat with all of us and tell us what you think. Thoughts, notes, feedback, anything, we're happy and open to listen to. And yeah, and with that, I'd like to start with thanking the venue, actually. Thanks to Meredith. Thank you so much and your team for accommodating us so well. When I found this venue, and I've heard so many great things about the venue so far, I'm sure you came in through the doors and at some point looking around also felt what I felt, that this is perfect for rejects. And the best part is you don't really have to explain why you feel it. So, so I hope that you're able to work from here, that you're able to get the best coffee. We do try and ensure that. And yeah, that you have enough time before your talks to prepare your slides and whatnot. And yeah, give yourself a pep talk every now and then. Even the toilets are amazing, I swear. So that's already an indication of how great the venue really is. I will say that we're talking about the venue, so I'd just like to talk about some of the spaces. This, of course, is the theater space. This is where plenary sessions are held, and we'll have a few talks now in the morning, and we'll eventually fan out to the other space, which is the flex space. And if you go down this hall to the left and keep following the signage, one floor down, you will be able to get to the flex space where we will have more talks and talks happening simultaneously between the two. Yeah, and speaking of talks, speaking of sessions, you all will have your badges, and there's a QR code right behind it. That's what you can scan to access the schedule. It's the most up-to-date schedule, so I do recommend bookmarking that link just for the days of the conference at least, so you know what's on, if there are any last-minute cancellations, and to plan your time better. And yeah, important people that I'd love to also thank are the program committee. It's very critical to have a lot of reviews done for rejects on time, and more often than not, we write after rejects CFP, essentially, the reviews for that and everything happened right after KubeCon, notifications have gone out, and so on and so forth. So there's this very narrow timeline in between which the program committee needs to review everything and get everything in place, and I can't possibly put on a good schedule on my own without the help of these experts. I couldn't have done that on my own too, so big thanks to them, to Bridget, to James, Joseph, Laura, Natalie, and Victor. I'm sure they're around. I'm sure they're around. Natalie's not here, but a big word of appreciation to her too. She was quite invested in the idea of what our ground rules should be, and we've tried to keep it in a way that is more open, and we can kind of try and interpret it and adapt it to the kind of proposals that we do receive for rejects time and again. So yes, special thanks to her. Also special thanks to Joseph, because I know that he did review KubeCon proposals right before, so when I did reach out to him and I asked him, is it possible? Could you possibly manage this too? And he was more than happy to accommodate that. So yes, big thanks to him as well. Yeah. And big thanks to our sponsors. Believe it or not, every community event, needs money. So if some of you are here and really enjoy what you see and could potentially invest, do reach out to me, do reach out to the org team, and we can have a chat about it. We'd love to have you on board. You can see it's a rather fun, informal vibe, so yeah, you do have certain presence, but the best value that you get out of it is the conversations that you have here. And yes, as Lucky said to me in the morning, we possibly get the best out of all our attendees. So yes, so this is really the best time to also kind of convene a little bit and also chat about possible collaborations in the future with me and the rest of the team at Microsoft. So speaking of Microsoft, big thank you to Microsoft for making our registrations free. It may seem like a simple thing for us to do, but believe me, when you have to justify business need and you have to justify things like why we're doing what we're doing, this is an important, one of the important things that we do also think of is a giving philosophy that we have within the company. So yeah, I'm very proud of the fact that we're able to make registration free for all our attendees, also for the foreseeable future. So yes, big thanks to Microsoft for that. Yes. And yes, some of you, actually, would someone like to venture a guess which edition of Rejekts is this? Is this the 8th? Is this the 9th? Is this the 10th? What have you? Yes? No. But thanks for trying. Any other guesses? I would have given you free drinks coupons for like the happy hour later today, but it's a given everyone's welcome to the happy hour. So yeah. Anyone else? Oh, 11 is so close. 10. Yes. There you go. It's the 10th Rejekts, and another word of appreciation to the folks who started Rejekts. I can't take complete credit for it. So to Chris School for the original concept, to Lexi for driving the initial editions, and yeah, to Andy for all his help for like strategic support and to really, really think about how we do things in a methodical way. I inherited this project from them, and I'm really proud and honored to kind of continue to run it. Yeah, so big round of thanks to them. And yeah, I think I seem to be at the end of my slides. I don't have anything else prepared, but I do want to also talk about thanking the AV team. This basically shows that you also do need an AV team in control at all times, who are able to come in and help out and do things as required. So it may seem like a seamless thing, a seamless experience, but the more seamless it is, the more work there is behind it. So to all our speakers today, and tomorrow, if some of you are speaking tomorrow, I do request that you proactively introduce yourselves to the AV team at least 15 minutes or a half hour before your talk. You can even sit here and watch the previous talk, but I do recommend doing that because that helps them get prepared with any special requirements and make sure that testing 1, 2, 3 is smooth as ever. So yes, thank you so much. Do enjoy the conference. For any questions, please do come to us at the registration, and some of us will be around. Find me, chat with me, and the rest of the org team. And yes, let's start off with Duffy and Kyle's talk. Yes, okay, I was actually going to look for you. Thank you.
Good morning.
Good morning.
Good to see you all. Be amongst such amazing people.
Duffy will do the talk, and I'll just stand here.
All right.
Take the credit.
So this is a talk called Malicious Compliance Automated, and we're going to be talking about, we're kind of revisiting some things that we've talked about before. So as a way, by means of introduction, I'm Duffy Cooley. I'm Maui Lion everywhere. I'm the field CTO for Isovalent at Cisco. My job hasn't really changed in that time, so I still am doing all the things for Isovalent that I was doing before, still going to market the same way, still interested in moving forward with Cilium, and now with new funding from Cisco, we're actually pushing further into what's possible with Tetragon, so I'm super excited about that.
And I'm a founder of Autonomous Layer, which was called Autonomous Plane, and naming is hard, and sometimes you can't get the .com that you want, so you go with plan B, right? So that was plan B. And it actually works pretty well with containers that have layers, etc. So I'm pretty happy with that. I'm also the DockerSlim guy. I created the DockerSlim project, and we'll use that in this talk.
So this talk is heavily influenced by a talk that I and the rest of SIGCONC did in Amsterdam, and this talk will focus on what can be done to automate some of the things that we did that enabled us to fool or change what scanners can see, either intentionally or by happy accident.
Exactly, and then there's a lot more that can be done there, and that's why we're doing this talk, because I spent a few cycles to find additional ways to break vulnerability scanners, and it's always fun to break stuff.
Next slide. No, doesn't really want to go. There we go. So,
okay, so a little bit of context. We framed this talk as a journey for a developer. I'm this developer. I just finished an application with 24 hours to go. And you know this feeling, this rush, racing against the clock to meet the deadline, and then you feel like you're done, finally it works, and you're happy.
Yeah, ready to ship it.
That's where I am. And this is a node application, a server management application with a couple of endpoints. And this is the beginning of the journey we're going through.
But there's going to be trouble. Kyle has pushed his image to Quay, and this is our first scan from Claire, which is a built-in image scanner. Claire sees 3,232 vulnerabilities or issues that are fixable.
I go from high to low.
Yeah. And 158 of those are critical level vulnerabilities. Side note, not all of these are exploitable, obviously. I mean, this is one of the things about vulnerabilities, but like a ton of these things might be in there just because they came with the actual base image rather than having anything to do with the application that's being shipped. But security probably doesn't care too much about that. So what are we going to do? What are we going to do? So the security folks are also using Docker Scout to look at images amongst other tools. Docker Scout shows a very different result. Scout sees 26 criticals, 138 highs, versus 158 criticals and 1,271 highs. We can see that scanners across the board actually see a variety of different results, which is in itself kind of a weird problem, right? Like, if we're looking at the same CVE databases and those sorts of things, why don't we see some correlation between these things? Which scanner is the one that I should trust? Should I go for the one that has the most matches? Should I go for the one that has the least? I'm just trying to, like, he's just trying to get this thing shipped.
And we're getting back to where we are. It's only 24 hours, thousands of vulnerabilities. Yeah. The traditional way to fix vulnerabilities isn't going to work because it's about 3 hours to triage a single vulnerability on average, 8 hours to fix them. Multiply thousands by 8 hours. The math is naive and primitive, but the problem is there. So we need a different way.
And this talk is entitled Malicious Compliance. So what is the way we're going to do it?
What if we could remove things we don't need as a way to get started? And this is actually how I created the project, the DockerSlim project. I wanted to have production-ready containers, wanted to reduce the attack surface. I knew that it wasn't going to remove everything, but one of the main gotchas with this, even though this is the concept that many people talk about, don't put stuff you don't need in containers. In practice, you don't know what you need. You don't know what you don't need. Yeah. And yeah, it sounds good in theory. Some people do, And some people are better at finding out. But I'm lazy. I wanted to have an easy way to do it. That's why the project was created, and now it can do a lot more. It can work with more than just Docker. It can tell you a lot of interesting stuff about containers. It supports many different runtimes, building images, including remote builders like Depot, shrinking images, and then also debugging them. This is the only tool that supports all major runtimes to debug minimal container images. And you need a way to debug them because you don't have a shell. But we're not talking about debugging.
And it is an open source project. You can find it on, GitHub and explore what's happening there.
We're going to shrink the application container first. So here, this is an example, a little bit of animation where we run the slim command and we pass a few flags. And if you've used the tool, you might know some of those flags, but some of those flags you probably don't know. And this is the case with one of the flags, HTTP probe full. That was a question you had. So what the heck is that flag? And honestly, I don't even know all flags. And I built the tool. So, and this is a universal problem with many tools, DevOps tools. You don't necessarily know everything about them. And that's actually the reason why I thought, why not leverage some of the new tech that's out there and build an assistant? And on the next slide, we're going to use that assistant to ask about the flag Duffy was curious about. So what is this HTTP probe full flag? Yeah, and if we look at the output, it gives you a short overview, and it gives you a few parameters there. If I don't know if you can catch it, but there's a hallucination there. It's okay if you don't spot it, but it's not perfect, and it has the usual gotchas that you normally get. Sometimes you don't get the exact answers you want, and the answer there is the type. The type, it says it's a string, but it should be a Boolean. But it got the default type right.
So what do we get from vulnerability scanners at this point? So after this run, I run the report that security gave me, and I can see that now there are only 5 vulns, and none of them are critical. Watch me fumble through the typing here for a moment. So this is just using Docker Scout. And I've already made a huge improvement just by slimming the image, right? I've made a huge improvement.
How many does Claire find?
Say again?
How many does Claire find?
Claire, at the moment, I believe still finds, Claire might be cached, but we're going to talk about it here in a second. As a reminder, here's what the old stats look like across all of the different scanners, and this is what it looks like after the change, right? So we can see OSV scan doesn't find anything. Claire will also not find anything, but we'll talk about why that is here in just a minute. But Docker Scout's down, Snick's down, Gripes down, and Trivri is way more tame than it was previously. So let's see what happened. So Docker Scout has a compare tool, which is actually super useful. If you have 2 different images and you want to compare, like get an idea of what the CVEs are and the 2 sides of things, this is a pretty good way of doing it. And what I'm doing here is I'm looking at the original image and the slimmed image, and I could still see 6 highs, but you can really see the difference between these 2 things, like size-wise, package-wise, and vulnerability-wise is greatly reduced.
Yeah, we did it, right?
I mean, if it's only 6, I probably could get like exceptions for that, but I'm not going to get exceptions for 138, 26. That's not a thing that will be happening.
It's a better place to be.
Yeah, 433 vulnerabilities removed. So in our example, the minification wipes out all the files that aren't needed to run the app and pass the test. And as a result, tools that focus primarily on the OS, to your question about Claire,
right there,
right,
unsupported,
are now blind because they don't find that metadata that says this was the operating system that this was based on is not there anymore.
So it just gave up, didn't even try.
Yeah. So what happened to that OS metadata, right? Like these are the things.
That's a good question. So one of the things Claire and OSV Scanner cares about is etc. OS release. This is where you get the distro metadata, and that's what many vulnerability scanners use as a starting point for their journey. to determine what kind of vulnerabilities they need to look for. And if you look at the output, you'll have references for the tools that we used. If you look at the output of the etc. Directory and also other top-level directories, you won't find some of those files and directories, including the var directory, where Debian has a lot of the metadata about the system packages and the logs about installing stuff. So right there, we removed the basic OS information, and Claire and OSV scanner were out, but we still have vulnerabilities. We still have vulnerabilities that we need to take care of, and we need to do more. And that's a good question. What can we do?
Yep.
And we can ask the assistant again. And here, if we switch to the next slide, here, a little bit of animation asking the assistant, how can we hide the rest of the vulnerabilities? And the assistant is set up as a rack system. If you want to know about the design, I have 3 different designs there. I've done talks about different assistant designs that tell you, that use different tools and techniques. So it's a rack system that knows everything about Docker Slim and the container image. That's why it's able to answer that question. So in addition to the flags that we've seen already, there's an additional flag that tells us we can use to hide the vulnerabilities. And if we go to the next slide, it'll zoom into the important section. It'll tell you more about this extra flag, and it'll describe what it'll use, what it'll do. So it's intentionally hiding stuff from the vulnerability scanners and not even, pretending that.
Because at this point, we want to be really compliant. We want to get all the way to
really
0.
Really compliant. So
trying to figure out how we can actually do that.
Exactly. So let's see what happens.
So let's use the commands that the Mint AI recommended for us, and we'll actually do the obfuscation, and we'll see what this looks like after. So we're able to get through that process. And what do we get from the vulnerability scanners now? A lot of them are like, we're good. There's nothing to find here. Like, we haven't actually changed too much in the image at this point. I mean, this latest change with like the obfuscation piece, it actually does change some things in the underlying image, but fundamentally what we've done so far is we've removed a bunch of things. And this is one key difference, I should say, between this presentation and the presentation we gave in Amsterdam. In Amsterdam, we didn't change the base image at all. We just manipulated what was inside of it. But all of the vulnerable stuff was still inside of that image. In this image, when we did that Docker Slim image, we knocked out like 400 meg of stuff that was actually matching on those vulnerability scanners. So we made a significant change. Sorry, I was mixing my scripts up. So we removed a bunch of stuff from that image in this one. And in the second step, we also modified what's in there to clean up or to further obfuscate some of the things that the vulnerability scanners were able to find. So now, what do we see? We're completely compliant. We're ready to ship.
Perfect.
So this is another difference, right, between the minified image and the obfuscated image, right? We can see, actually what's interesting is that we grew in size a little bit. We have the same number of packages, right? We see no more vulnerabilities, and we see that right here in the bottom line is kind of an interesting state right here, because it says 102 packages changed and 11 vulnerability changes.
Right there.
Right. So what is 102 package changes? What changed about those 102?
Yeah, so that's a good question. So when I watched the original talk in Amsterdam, Malicious Compliance, I wanted to apply the techniques they talked about. And what I discovered is that with the applications I had, they didn't hide everything in my application. So I went on a mission to find additional ways to break vulnerability scanners. And this is an example where we're changing the binaries. As you can see, the sizes are different, the hashes are different, and the content is also different. At the very end of the node executable, there's a little bit of data with my initials in there. I signed them. There's more going on with Node.js and other runtimes. For example, We're also obfuscating the signatures, version signatures, so the vulnerability scanners can detect the Node.js version, so they can find the vulnerabilities associated with it. So.
Yeah, and it really highlights the two, kind of the two categories of scanners. Like some scanners actually, again, like really just go after the OS. They want to be able to find that metadata that says this was based on an Ubuntu image. They're going to go hit the CVE lists that are known about Ubuntu-based packages. They're going to find matches and they're going to tell you about them. But if you remove anything that says, oh, this is an Ubuntu image, all of those vulnerabilities are still there. They just can't find them anymore, right? And then this one, what this does is it actually takes the obfuscation another layer deeper, right? You're saying some scanners, Gripe, Sift, things like this, they will actually evaluate the binaries themselves. Look at the metadata for the binaries themselves. They'll go in there and see if you have any node npm packages and those things installed and evaluate those. Not looking at the Ubuntu repository, but at the npm repository, right? A different set of data. And this defeats that because it basically makes it so that they don't match anymore. Go ahead. Actually, before you ask your question, I gotta go to Mike because we're recording. Yeah.
Hold on like this.
And some scanners do hash-based
Is it working?
lookups.
Yeah. Does it also kind of output that these are now I found 5,000 files that I didn't know about, or doesn't it does it ignore that? Doesn't kind of output to the developer that well? I didn't understand this.
Sometimes they'll just tell you that they find a bunch of files, but they can't correlate them to anything until they'll say they find a bunch of files. But
it's kind of a known unknown.
Yeah.
Okay, that's good at least.
But frequently, like, as you saw in the output on the previous slide, it just will say, will throw its hands up and say, there's nothing to find here because there's no correlation.
So maybe you're about to get to this, but what I'd really want is to obfuscate the container image for attackers, but still be able to scan it myself.
Yes.
Is there
Yeah, so if
is
you
there a way
pulled
to do
this
that?
image, are you saying, can you scan them?
Yes.
Yeah, if you pulled the images that you see by name from Quay, you'd be able to scan them yourself, and you would see the same results that we're showing on the screen.
Right. What I'm saying is I want to be able to scan it non-obfuscated.
That's the very last slide.
Okay.
All right. Well, let's keep going then.
Okay.
So, second, the Node.js package, go ahead.
Yeah, so the second kind of change that we got is the application package metadata change. That's where those 102 changes came from. And what we did, we rewrote the node package metadata. And if you look at the output from Sift, you'll see that, for example, for the accepts package, we went from version 1.3.8 to version 11.3.8. And the way the vulnerability scanners work, they take the metadata from the image they scan, and they take the name and the version, they do a lookup. And obviously for this version, they're not gonna find anything. Pretty naive, pretty basic and easy to break, and that's an example of doing that just by changing the metadata. But there's more we can change.
Even more, yes.
So here, it's a little busy, but it's a journey from the original image that shows what we have, 600 packages, a whole bunch of 10,000 files, a bunch of executables, to the slim image where we have only 50 packages, 60 executables, to the version where we mutate the package metadata version, and then we can also mutate the package names. So this is one example of name mutation. You can choose a random name. The app will still work, but the scanners will fail because they won't be able to do a lookup. And you can also remove the names completely, which is the case right there. We see 0 packages. And that's because the names were removed, the packages are still there.
So in refreshing this talk from our previous from our previous presentation of this at SecurityCon in Seattle a while ago, we noticed that actually some of these scanners are doing more work than they were previously. So the state of the art has changed a bit, and it's exciting to see. But like one of the big takeaways from this particular talk is that we need to drive more change in this, right? And because this is now automated, you can take this tool and apply it to images and show them to your, show them to the people who are like writing software for actually scanning for vulnerabilities and those sorts of things, and say, you got to do better. Like if I remove just the OS metadata, it makes a huge impact on my ability to understand that there are vulnerabilities in this image, right? And I want you to do better than just look at OS metadata.
Exactly. And if you don't ask, things will not change.
Yeah.
The status quo will be there. So that's what we're asking. We're asking for change, and we want you to ask for change.
Yeah, but having this automation makes it super easy for you to prove this out.
But
Take
to
it.
answer that question,
Yeah.
is it possible to scan and get the results from those images?
Yeah.
Yes, it's possible. It's just you don't get that with the scanners that exist, and this is something that I'm actually working on to detect the vulnerabilities, the packages, even when the traditional metadata isn't there.
Be the change you want to see, I guess. Yeah, that's awesome. What other questions do we have?
I'm a little concerned at the idea that a package can exist without a name. That seems like something that the package system itself shouldn't even allow. Like, is there a valid reason to ever do that?
Great question. I mean, like, what if you wrote the package, though? That package isn't in a repository anywhere. It's still just a local package.
You should still give it a name just for your own reference and nothing else.
Right? Go ahead.
So let me make sure I got this right. You're saying until somebody updates these tools or writes a new tool, we're basically all screwed if we pull a image from Docker Hub or Quay that we don't know the author and fully 100% trust the author. There's
mean,
no way
I-
for us
that is
to know
something I
for
would-
sure that is a safe container.
I think one of the first times I ever saw somebody say something like that was Adrian saying, know what's happening inside of your cluster. Actually, I remember that talk. That was a good one. But I do often say that, and I would qualify that with, in this scenario, right? Like even your scanners may be lying to you if they've been minified, if they've been modified from the build image that they originally kept. I mean, even if you're just doing even if you're doing a multi-stage Docker build, like what's left in the image after that second stage? Like, how are you scanning that? How do you know that the scan results are viable? How do you it's a tricky question.
But it's a great attack vector. You build an image with a whole bunch of vulnerabilities that you exploit later on as a way to get in.
Yeah. Go ahead.
How receptive have the vendors been to fix this problem? Like, why is Ubuntu this way out of the box? It's been over a decade.
I mean, I don't have any direct information on that. Do you have anything?
I think it's about how it's perceived. It's perceived as a compliance problem where you're a developer, you're building an app, you just want to ship your app. Then you have InfoSec. They scan your application, you get a Christmas tree report. You don't necessarily like the InfoSec people, you just want things to go away. And the InfoSec people, they scan it so they can check the compliance box. But there's more to it. And it's been it's based on the status quo. That's where it's been, a compliance checkbox. People haven't been thinking about other potentials, so it's just stayed that way for decades. That's why we're asking for change, because there's more to it.
And as we said before, when we were refreshing this talk, we did notice that some of the tools like Sift are doing, Sift and Gripe are doing more work. I mean, it's kind of a little strange because they're directly looking for particular binaries by name as opposed to just trying to look for metadata in packages and those sorts of things. So there's they're starting to get better and better at it, but they would catch that thing where you did the multi-stage build and copied curl in, right? But that's a recent change. So they're starting to kind of get it. I think enough people have been telling them that this is probably not good enough.
And the antivirus tools went through a similar journey.
Oh yeah.
They're just ahead. And initially they weren't that great, very primitive, very naive, and then they had to evolve because they had to.
Probably our last question. Go ahead.
I know that we're looking at containers that are built from different operating systems and whatnot, but before I got into cloud native stuff, I was all into security. And we would also, to isolate things, just have a single binary in the container so that the one program you wanted to run or the various limiting specific files. Is that what Mint is doing in some respect, but still leaving around operating system level?
Are you asking what Mint is doing?
Yeah, I guess that's two things. I would encourage us to go and really, really small
So
containers.
what Mint is
But
doing
what
is it's
Mint
trying
doing?
to do the thing where it determines, like when you run your application, you give it some way of actually validating that the application is doing its purpose, right? You have it scan the HTTP endpoints of that image. And then it's going to evaluate, based on that state, like what packages, what's on the file system that was used or loaded into memory while that was all happening. Now this means that there are some sharp edges, right? If you're not validating everything, you could run into trouble, et cetera. But
So yeah, it's going through a few rounds of static and dynamic analysis.
Yeah.
One of the requirements that we've shown there is the flags, for example, to have extra interactions for the application endpoints. We had in the demo app for the ping and services endpoint. The gotcha there is that you need to know about the application something to add those interactions, and there it's a dependency. You need to know a bare minimum about the application, and you need to customize the flags and all of that in order to get full coverage.
yeah. All right, well, thank you very much.
All right, next up. Next up, we have Lachlan Evanson taking us through 10 years of Kubernetes.
All right, let's see if we can get this going. Can everybody hear me okay? Yeah. Hello, I'm Lachlan Evanson from Microsoft Azure. How's everyone doing? Isn't this the best way to start your week? Hey, Joe, how you doing? I just want to say 10 years of rejects. You know, I've been to many rejects. It's the best way to start your KubeCon week. Full of energy. I love being here, and you know why I love it? For two reasons. This is a community full of doers and thinkers, and I'm always challenged by you all, so if you see me around today, come up, challenge me, have good conversations. But let's go ahead and get into it. Somebody gave me, an Australian, 10 minutes to do 10 years of Kubernetes. Now, what I want you to think about as I go through this is my perspective and my journey, but I know many of you have been along for this ride as well. So think about your journey in Kubernetes, and if this is your first day, welcome, right? Your journey starts here. But we've all been here for 10 years, or even today. So let's go ahead and get in it. We buckle up for the ride, we good? All right. I'm gonna give you my best energy, so let's go ahead and get into this. But, you know, like all journeys, it starts with a magic moment. So think back. When was the first time you did Docker run? Was that moment transformative for you? For me, my boss at the time, Joe, who's sitting here in third row, said, hey, I've heard about this Docker thing. Come over and check it out. And I was a young, cynical engineer. Ever been one of those? Where you're like, oh, this thing's going to be garbage. How's this going to change my life? Right? And I just remember typing into my terminal, Docker run Redis. Anybody done that? And what happened? Redis ran, right? It was like, whoa, you know. And little did I know that that little moment was going to change the trajectory in my life and my career. Anyone else? Yeah, right? But it starts at that moment of magic. Think about that magic moment. But in order for that moment to be magic, right, where were we in 2012, 2013? Wandering around in the desert full of dead trees, right? So let me paint the picture, right? Chef, Ansible, Puppet, remember these things? Remember when I was responsible for a cloud platform and we were trying to provision VMs and you'd have tools like Chef, Ansible, Puppet, remember them? Right? What were they? Ways to run your artisanal shell scripts en masse, right? We could get these things done, but you know what? Could you ever debug a recipe, a playbook? They were hard to debug and stuff was a mess. On top of this, anybody remember DevOps? DevOps was becoming a thing. Developers wanted their machines right now. They wanted them quick. So this was the scene, right? This is the founding place of where this all happened. And why that moment was so magic is because we were looking for something else, right? We were looking, there's got to be a better way. If we're all going to the cloud, we cannot be going to the cloud with those tools. So Joe said to me, well, you've done Docker run Redis. Go ahead and see if you can model this in production. And back in the day, we were in San Francisco. There was a little meetup by a little company called Google. You may have heard of them. And they were talking about this thing called Kubernetes. And that was the first Greek word I knew. I still don't know how to say it right. But we went to this meetup, and all the founders of Kubernetes were there showing Kubernetes off. Joe said to me, hey, you got 1 week. I want you to get one workload up and running on Kubernetes, and let's see if we can get it to prod. I think it took me a day to get one workload up and running. And by the end of that week, we had several workloads on a Kubernetes cluster, and we had a plan to roll it out to prod. So this was Kubernetes 0.7 back in the day, very early. So it was there. We could do what we needed to do, even with it bare bones back in the day. Now, I want to think about the staying power of Kubernetes and really what it's made it strong, and this community very strong. And it's kind of this concept of community. So I think the creators of Kubernetes had several really great ideas. The first one was to create the CNCF and put Kubernetes in it. What that did was allowed multiple companies and communities to start rallying around Kubernetes to build it. I think the other thing was Kubernetes wasn't finished when it was open sourced. It was very, very bare bones. So the community had to come along and build it together. Finally, and I think this is one of the big things, is community. Kubernetes focused on community. Back in the day, if you wanted to get into Kubernetes, they had weekly, was it weekly or monthly community meetings? Weekly. And if you were lucky enough to go to one of these meetings, you would have been greeted by a friendly face. That friendly face was Sarah Novotny, saying, welcome, you are here, we're going to build this together. And I went back in those days to see that kind of energy and people rallying around this idea of Kubernetes. So those were the things I think really got Kubernetes to take. It's the community and going together and building it together. Now I want to revisit, we got to prod, and I think, this is an apt kind of photo. People talk about cattle and pets, I talk about plants and forests. So potted plants here. Was Kubernetes really ready for production? No. So in July of 2015, I got on stage at Kubernetes 1.0 launch and said, we're in prod with Kubernetes. I was happy at 1.0 to get crash loop back off. That didn't exist before 1.0. We didn't even have stateful workload support in Kubernetes. We didn't even have persistent volumes. We didn't have CNI. We didn't remember those days? And we got to production with 1.0. But look at what we built. Look at what we built together, right? It's amazing how far we've come, and everybody in this room and around the world have done that together. I think that is really the power of Kubernetes. But it's not all been roses, and holding the line is a big thing. I think what Kubernetes did great was it said, this is core, and that's everything else. And we built extension points very early into Kubernetes through things like custom resources or third-party resources, as they were called in the early days, if you remember them, TPRs. But it was, this is core. We keep the code base really slim and light in the core, and then there's an ecosystem of tools around Kubernetes that support it. And I think that was a really crucial point. But that is still something that's in the making. So anybody remember the container wars? Where were you in the container wars, right? Yes, Rocket, we had different runtimes. We had different container orchestrators, right? They were all out there. You may have heard of our friends like Mesos and Docker Swarm. So Kubernetes and the power of Kubernetes, the community was able to go and make it so strong and so compelling to use Kubernetes that those other orchestrators all but disappeared. But it wasn't without some learnings. I see Lucas in the audience here. I remember when Solomon got up on stage and said, Docker Swarm, one command, I have a cluster. And Kubernetes went, oh my goodness, it's like 50,000 commands and I still don't have a cluster. And I think Lucas was probably in 5th grade, and he wrote kubeadm as a response to Solomon. So that, again, we have kubeadm as a response to Solomon being on stage, go, I'm going to beat you, Kubernetes. And who got the last laugh? Don't tell Solomon. Now we have one platform to rule them all, right? Kubernetes is a lingua franca of all the major cloud providers. You can go get a managed Kubernetes offering from anyone. Probably somebody on the street will sell you one too, right? So we are there. Kubernetes has reached the promised land. We are there, but it's not over. It's not over. So when we think about the last few years in this journey, Kubernetes 2.0. If you go and Google Kubernetes 2.0, you'll find threads. Every 2 years it kicks up. I think we're about due, right? Somebody launched another one. There is always the constant opinions and always the constant ideation to go and rebuild the thing that we've already built. But I want to encourage you that Kubernetes 1.0 is still alive and well, and we've actually integrated a lot of ideas from 2.0. But this will, be fraught, and the future will always be, hey, how about we rewrite this whole thing? Now, a couple of other things were happening. In 2017, a little company called OpenAI had the opportunity to work on their clusters. They had 1,000-node clusters on AWS, and they were moving to things called GPUs, and they were going to go and build this AI thing. You may have heard of it, ChatGPT. They were building that on Kubernetes without GPU support. Kubernetes was not built for AI workloads, yet Kubernetes was able to be modified, and it's a platform for building platforms. And OpenAI went on stage saying they had 2,000 node clusters. They now have 100,000 node clusters. They were 7,500 node clusters back then. But AI and the AI revolution is powered by the cloud native revolution and Kubernetes under the hood. I want to encourage you all that you've all had part in this as well, building this AI renaissance. And finally, it is said that Kubernetes is boring. I like to say that Kubernetes is everywhere, like DNS and IP addresses, right? We love them, not really, but they're everywhere for a reason, right? They get the job done. The internet and the world relies on the backbone of DNS and IP and Kubernetes. I don't know what the percentage is now, but a large percentage of the internet is served off Kubernetes clusters, which is absolutely fantastic. So it is out there, and it is fueling the next wave of innovation. So every time you see Perplexity, every time you see all these AI companies, they are using tools like Kubernetes to actually build and deliver that AI. So that's what I think the future is how do we go build and solve the challenges yet to come. But what I do know is with the community, we can build anything. Kubernetes wasn't built for half of these workloads, yet we've modified it in a way that it can power the next generation of workloads. And when I think about Kubernetes, what is Kubernetes? Is it a set of binaries? Is it a set of APIs? To me, it might sound cliche, but it's actually everybody in this room and around the world. Kubernetes is the people, and it's the people powering the revolution more than the binaries and the things that you pick up and the endpoints that you... So those values that were founded at the start of the Kubernetes journey with the founders of the project, community over company, have seen to stand the test of times. So I think whatever the problem is in the future, I'm not going to crystal ball and give you an answer, but I know that we can meet it. And with that, I'll wrap up. I'm around all day and for the rest of the week. If you want to learn more from me or my journey or share your journey with me, I'd encourage you. And you can stop by the Microsoft booth, and I'll be giving away some books later this week. So really appreciate you all. Thanks for having me on stage. Adios.
All right, now we're going to hear from Adrian Moat. Images Bite Back, dealing with day 2 build issues.
Bear with me while I get set up. Maybe I shouldn't have pulled that out. That looks good. I am slightly distracted as I keep getting message to rugby scores, but anyway. Yeah, I'm Adrian Moat. I'm going to talk to you today about day 2 issues with images. So I'm kind of actually starting from the same point of view as Duffy and Kyle. We'll see that in a minute. Basically, everything that happens after you've built your image and you think you're ready to deploy it. Oh. Now, believe it or not, this is a lot like being Frodo in The Lord of the Rings. By the way, people always say I look like Frodo. I'm not really... I used to have longer hair, and I did... anyway. So, you're Frodo. It's your uncle's birthday, or your uncle's birthday, and you get this cool new ring, and you're looking forward to showing it off. But then some old hairy dude, like Duffy, throws it... Sorry, it was just the grey beard maybe. Throws your ring in the fire, finds out all these secret letters that he didn't know about, and starts going on about great evil and dark lords. So this will make more sense in a minute when I get to the next bit.
You're on point.
No, it makes I said it too early. And you just know it's going to get worse from there. So before you know it, rather than having a chill party, you're hiding from creepy guys dressed in black that you know are going to reappear reappear later. And you have to explain yourself to a full council who keep going on about some volcano in Mordor you've never heard of. Then you run away from giant burning things in an underground mine, being sucked into swamps, captured by giant spiders, and all the time this creepy disembodied eye is looking for you. But at the end, you're saved by a giant eagle. And you're a bit like, well, this is great, but couldn't you have like saved us the walk in the first place? Yeah. And it's basically the same with a container image. So you've created a shiny new image for your application, and you're ready to get it into production. This is where you meet Duffy, sorry. You meet Duffy, he starts talking about manifest lists and annotations, and you start getting that sinking feeling. Somebody mumbles something about CVEs, which you successfully avoided and ignored so far, but you just know it's going to come back and bite you later. Then you have to explain your plan to the platform team, who start talking about maintenance and supply chain security. Somebody utters these words. Then suddenly you're battling with multi-platform builds, drowning in reproducibility issues, getting your head around supply chain security, and having to consider proper observability. I'm not going to talk... Unfortunately, I'm not going to talk about observability, but I thought that was too good of an opportunity. And yeah, you get it all working in the end, but it's definitely a battle. And if you watched my presentation in the first place, you could have saved yourself a lot of time, which does make me a giant eagle in this metaphor. Okay, so I'm going to talk through some of these issues, and I'm going to use an example application to try and keep this sort of a fairly practical and grounded talk. All the code for this is in the repo, so you can grab it there at any point. I'll try to add some notes as well after this talk. I have sort of used a sort of simple and common tool in this I could. It is a Go application. The reason I chose Go was just for simplicity, and it has support for cross-compilation, which I'm going to talk about in a minute. But most of the tips are hopefully pretty transferable between stacks. So this is what our basic Docker file looks like. We've got a multi-stage build. It just builds a Go binary. It builds the Go binary as a static binary, which then gets copied into a distroless image. I'm not going to talk too much about distroless and multi-stage builds. You can check out other presentations and so on if you want to know more about that. So I've called this simple build action, but all the actions are fairly similar. Hopefully, what was that? Wasn't expecting that. Yeah, it's this one. So all we're going to do in our build action is set up Docker buildx, log into the Docker Hub. So I'm using the Docker Hub here. You could, of course, use GitHub package registry or wherever, container registry. And this step is kind of important. But all it's doing is setting up your images and tags. So just the naming. And this is the bit that actually does the work. We're saying build this Docker file. We're only going to build it for this platform. We're going to push it to the registry. So once it's built, it gets pushed to the registry immediately. We'll mention SBOMs and provenance later. And this is just using the tags and labels from the previous step. And there's a little bit of other stuff around sign-in that, again, we'll talk about later. But, oh, of course, this is my fault. I'm not going back to the slides. There we go. The first thing I want to talk about, though, is multi-arc builds. This is kind of a surprisingly deep topic. And I could have done the whole talk on this, to be honest, and maybe I should have. Because I do think there's kind of a lack of good resources around how to do multi-arc container builds. When we talk about multi-arc, though, we really just mean ARM and x86 99% of the time. There are other architectures, I know, but frankly, they're a little bit of a footnote. In the future, I guess you might get RISC-V. This statistic is from last year's Datadog report. I guess the new Datadog report probably comes out next week or so, does it? Is there anybody from Datadog? Yeah. Anyway, so I'm kind of curious to see like how this stat has changed again this year. But between 2022 and 2023, they saw like a tripling in the use of ARM. I did read somewhere else that now data centers are buying more ARM chips than they are buying x86 chips. So even if you're not using ARM at the minute, it probably is in your future, because it offers like I guess mainly a cost saving for relatively little work. So the question is, how do you build images for multiple architectures? There's sort of 3 different techniques, and they all have different trade-offs. So there's emulation, cross-compilation, and dedicated runners, or that's what I'm going to talk about. Emulation is definitely the easiest. It probably will just work. If we look at the, is this going to work? Oh, it did. So if we look at this file, maybe a bit small. Basically, all I'm doing differently is just running this setup QEMU step. So with emulation, you do need to make sure you've got handlers to run the different architectures, but that's pretty much all you do. Then the build is exactly the same, except I've specified multiple platforms. So that's the only difference, and suddenly I'm building for more than one platform. But there's actually a bit of a large problem with this technique. If I go here, oh good, this is all working, actions. And you can see it even in this, remember, this is a really trivial example. If you go and look at the Go code, there's, maybe 20 lines of code. And if you look at the times, here is a QEMU build, takes 3 minutes, 9 seconds. All the other ones are like a minute. So even in a trivial build, it takes much, much longer to run an emulated build. Okay, back to the slides. I've made this complicated for myself. So the issue is, it's slow. And I don't mean it's slightly slow, it's really slow. As in, I don't think people should ever really run this in like a CI task that runs the whole time. I think that's a really bad idea. And I kind of don't really like that in some of the docs and so on, and the examples it's showing as like a default. So like if you're using QEMU at all in CI and running that the whole time, please consider doing something else. Just, it's not the slowness that bothers me, it's the fact that we're just burning all the CPU cycles that we don't need to be burning. And if you're not doing QEMU, the choices are cross-compilation or dedicated runners, really. Cross-compilation is a little bit trickier to implement, especially if you have to take care of dependencies. But it's much, much faster. Compilers don't really care which architecture they're targeting. And this is basically what it looks like. So I've got, in this repo, there's a file called cross.dockerfile. And if you look at it, here it is. The magic bit is this $build platform. So BuildX will populate that with the architecture that you're running on. And that's regardless if you're using QEMU or whatever, it always ties to the host architecture. And then down here, when you run the Go build, we have the target architecture. So that will correctly take care of building for the target image. And then we have the final step for the multi-stage build, and we don't give the -- platform, so that will use the correct platform for the target architecture. But there is no emulation going on, because in these steps, there's no run. So you only need the emulation if you've got a run step in your Docker file. So that should work. The thing is, that example was pretty simple. And in particular, I didn't have to install package manager dependencies. So imagine you had to install zlib or something. You would need to install that in your build stage for the target architecture, not the build architecture, which is a little bit complicated. It turns out it is possible to do, and the developer behind BuildX, or the main developer, also wrote this really useful tool called XX. Basically, you can copy that into your build stage, and then you can run commands like xx-apk, and it will take care of getting the dependencies for the target architecture. And I did put an example in the cross-xx.docker file. But still, it definitely starts getting a lot more complicated if you have a more complex build. So you want to think about using dedicated runners if you get into that stage. So that's where you simply run your build on the machine of the appropriate architecture. And then your Docker file gets really simple again. You don't have to do all this cross-compilation. But sometimes CI can get more complicated. If you are using something like Docker Build Cloud or something like that, it'll be really simple because BuildX will take care of all this for you. But if you're using GitHub Actions, as I am in this example, you're going to have to take care of running separate builds and then creating a final stage where you have a multi-platform build that pulls it all together. So what does that look like? I have an example here. So here we have 2 jobs. We've got like this, well, 3 jobs in total. But we've got an ARM build step that is going to use our ARM nodes. The actual bit here is just the same as before. But we also have another step here. Oh, I do have to say thanks to Carlos for helping me set this all up. And this step here runs on the x86 nodes. And then the tricky bit, we have to like stick it all back together. So we have this, where is it? Oh yeah, here we go. We have this manifest step, which depends on the 2 previous jobs, our ARM build and our x86 build. And what we have to do is get the digest of those images. I'm using Crane to find the digest along with the digest that comes out of there. And then we run this docker manifest create command. And this is going to create a single multi-platform image that points to the appropriate platform images. So you can do Docker pool of this one image and you get the appropriate platform image. And of course, we have to push that to a registry. And finally, we've got a final sign-in step that we'll talk about a little bit later. OK. Oh, I'm sorry, I've not gone back to here. Sign-in images. So sign-in images is basically the cornerstone of supply chain security. Signing lets you prove who built something and that it hasn't been tampered with. And I've talked about signing for years, but sometimes it feels like we still have a long way to go in terms of uptake. The good news is it has got a lot simpler. There are a whole bunch of projects in this space. So you probably also heard of Notary, which I think is now Notation, and also OpenPubKey from Docker. I'm going to talk about SigStore, which I think is pretty widely used at this point. So with SigStore and Cosign, you can sign images by creating, and one of the nice things you can do is you can sign images by creating a temporary certificate associated with an OIDC identity, which is basically a fancy way of saying you can sign images without having to create a private key that you have to keep secure. Because that was always been one of the big problems with signing, is that you have to create these credentials, which you have to protect and make sure nobody gets a hold of. But with OIDC identities, you can sidestep some of that. And we have an example here. So this is just going back to the basic example again. I'm on the runners one. This is the wrong. Let's use the simple one. There we go. So, oh yeah, the first thing we have to do is add a few permissions for the sign-in. So we have to be able to access the GitHub credential. It does need write access, which seems weird. It doesn't actually write anything, but I don't know, that's the way it works. Then we have to install Cosign, and that's almost it. The final step here is the Cosign sign, which we do down here. This whole bit is just getting the name. I copied this from the docs. All it's doing is getting the names of the images that we want to sign. Do note it does use the digest, so you're absolutely sure you're getting the correct image. But Cosign sign will actually sign the image using the OIDC credential. Well, it creates a temporary certificate using the identity from that credential, signs it, and then actually also uploads it to the registry. So the signatures end up in the registry alongside the images. Now that you're signing images, you also really need to check the signatures at some point. You can do this with cosign verify, which you can put into scripts, etc. But more likely, you'll probably want to set something up on your Kubernetes cluster, like Kyverno or OPA, which will let you verify that images are correctly signed before they're deployed into your cluster. Reproducibility. This is another big topic and could be a whole talk again. I think basically a lot of the points I'm going through could be a whole talk. Ideally, I would love to see bit-for-bit reproducibility. So that would be, I create an image, Docker build or whatever, then like a week later, somebody else runs Docker build, and they get out an image that is bit-for-bit identical to the one that I built. But that's really not so easy. You can do it, actually, if you use certain tools and so on, but it tends to be a lot of work. It is still... Oh, why is that doing that? I just want to see. It is still worth aiming for sort of in-between point. An in-between point being, I guess, one thing that I find quite often, you run Docker build, or you run somebody else's Docker build, and it's only like a month or two old, and it doesn't work. And half the time it's because the dependencies have changed, right? You know, a different version of curl or whatever gets installed. And it just doesn't all work together anymore. Sometimes like a whole download will disappear, which is a whole other problem. But what you can do is use pinning. So you appreciate my joke picture. With images and actions, you can pin to digests. So a digest is basically a cryptographic hash of an artifact. So it always points to an exact version. But it's actually a little bit better than that. Because it's a hash of the content, you're guaranteed that if you use a hash, you will get the same thing, and nobody kind of tampered with it or made malicious changes. For dependencies installed via package managers or language tool chains, you may find you can't use hashes, but you can probably still be specific with regard to versions. So rather than install version 2.3, you can install 2.3.1 R5 or whatever. This is basically what pinning looks like. This is how you do it in a Docker file. You're going to have this big long SHA line at the end. Now I've cropped this. The annoying thing about digests is it's like, I can't remember how many characters it is, but it's like 60 characters of just letters and numbers. And it's not really human readable. So that's the really annoying bit with digests. You can do exactly the same thing with GitHub Actions. Again, it's the same sort of format. You have this and then the digest at the end of it. In both these cases, note that there's a little bit of metadata added here. So in this case, we've got a comment that's telling me that this hash should point to version 3.7 of this action. And up here, we've used this tag to say what this digest points to. And that's useful because it makes it easier to update things. And there's a bunch of tooling you can use around pinning. So the first question, I guess, is how do you find the digest of an image or of an action? And one way you can do it is with Crane. So there's a really nice tool called Crane. I should probably put a link in. But you can run Crane digest and then name your image, and that will return the SHA hash. You can also pass -- platform if you want a platform-specific hash. There's also Frisbee from Stacklock, which I quite like. And you can do the same thing as here and like get a digest of an image, but you can also pass it like a Docker file or a YAML file. And what it will try to do is update any image references in there to point to use digests. Oh yeah, and there's also Digestibot, which Carlos wrote, and we use in ChainGuard, and that's a GitHub action that will try and keep your digests up to date. So it works a lot like Dependabot. It will check, like in this case, it will check this image and check that latest matches this digest. If it doesn't, I'll open a PR to say, hey, update to this digest. And Frisbee actually has an action that does something very similar as well. Okay, so on to the Nazgul of the talk, CVEs. I feel we've probably done a lot of this already. But I kind of think, as was mentioned earlier, there is a bit of a problem in that, say, you do your Docker build, and you run your scan on it, and the CVEs. But the CVEs are in like the images you're using, which are up to date, or they're in packages that you've installed, but you've installed the latest version of the package. So you're kind of like a bit stuck as to what to do. So what can you do? I generally talk about 3 different things. One, use minimal images, and it's also fair to say, min toolkit there as well. But using minimal images, so we're talking things about using distroless images and multi-stage builds. Alpine also tends to have a lot less smaller images and typically less CVEs. I mean, I do work for ChainGuard, so I do have to mention ChainGuard images, and that, we really do strive to get to 0 CVEs in our images. Beyond that, just try to reduce dependencies. So, what I mean here is, in your builds as well, try to just pull less libraries in. Like if you don't need that library for production, don't have it in there. Maybe you can have like a separate build for like testing or development. And also the killer point, keeping everything up to date. That's where this all gets difficult. And brings us to the next point, which is how to keep things up to date and why it's important. So I think it's absolutely essential to keep your dependencies and your images up to date. It's when things when you're running like, months old versions of things, that you typically get vulnerabilities that become pretty serious and can potentially, get you hacked. But updating stuff is in tension with like keeping stuff stable and keeping things working. When if you do an update, it's a chance that something breaks. So unsurprisingly, ops teams are maybe not the hugest fan of updating as much as you may like. And I don't really have a good answer to this other than engineering is hard. Yeah, and I guess most people try and look into testing and rollout strategies to try and sort of mitigate and help here. But there are also lots of tools for updating images. So a lot of you will be using GitOps. Flux has some great support for keeping images and so on up to date. There's also Dependabot and Renovate. I guess a lot of people here use Dependabot, especially if you use GitHub and so on. Renovate is very similar. They will open a PR to tell you to update any dependencies they find which are out of date. And again, if you're using pinning images, you've got the Digestibot and Frisbee tools. I did write a full article on that, so people can grab that if they like. I'll have these slides on social later. I did want to have a section in this talk about Salsa and attestations, but frankly, at this point, there's already too much in this talk. Supply chain security is a very deep hole. Salsa is a standard which describes sort of multiple levels of assurance for builds. And it talks about things like provenance, sign-in, and tamper-proofing. So I would totally go and look at the Salsa thing and try and work out where you are in the levels. It used to be a 4-level system, it's now a 3-level system. But yeah, it does go very deep. I did start adding some stuff into those GitHub actions regarding sort of how you add provenance and SBOMs and also build attestations. So if you go and look at those files, you'll find like in the builds, I turn on like max mode for Docker build, which adds some build provenance, and I also added in the GitHub artifact stuff. Now, I've not really investigated that fully. That's just a starting point. So if you want to look into that, do go and look at it, but I'm not guaranteeing like how much that guarantees of provenance. Okay, to wrap up so we can get to the break. Yeah, please don't use QEMU or use it like on your laptop and so on. It's a fantastic project. I don't mean to knock QEMU. It's pretty amazing what they've achieved, but don't run it in CI/CD the whole time. It really is just burning resources. Sign your images if you can. It's really simple now with the tooling. Please look at pinning everything. I don't think we do enough of that actually, and I think probably will help a lot of teams in terms of keeping things reproducible and help you with debugging potentially. And also automate updates, but that's really a large engineering problem that I think most teams are probably on top of. Okay, thank you very much.
All right. Well, that was a good start to the morning. We have about a 20-minute break, so we can meet back here at 10 after the hour. And then the flex space is opening up, and there will be presentations in there, so we'll see you in about 20 minutes.
Caption test. Caption test. Hello, this is a test of the captions. Testing 1, 2, 3. Appears the captions are working. Testing 1, 2, 3. Caption test 1, 2, 3. Caption test 1, 2, 3. Test 1, 2, 3. Caption test 1, 2, 3.
We're gonna start here in about 10 minutes. 5 minutes, 3 minutes, 2 minutes, no minutes. All right, everybody, we're back from break. Are you gonna bring more people in? Okay. Okay. All right, we're going to get started with a day in the life of Kubernetes release with tools, challenges, and operations with Mihia Valodia. One second, please.
Hello everyone, good morning. A good start to the first day of the events. So yeah, welcome you all. So I would like to talk about how the daily jobs look like in when Kubernetes release happens, with the challenges we face, the tools we use, and the operations we do. So yeah, it's not just the simple Kubernetes release, but I would also like to focus on how we make it sustainable release, right? So yes, because these days sustainability is an important thing. So yes, anyone working with Kubernetes knows how hard it is to put over the Kubernetes release. So yes, focusing on the insights into the daily life, tools and the methodologies, the release engineers have a strong identity of ecological considerations at every step. So we will explore one by one. So a little about me before I start. I am working as a software quality engineer at Red Hat with the OpenShift container platform team. So yeah, and apart from my full-time job, I also like to contribute to the upstream. So yes, I was the part of Kubernetes release for the 8 cycles with the different teams. Lastly, I worked as a branch manager and previously as an associate. And also I was a lead in the CI signal team for 128. So yeah, that's me. So what we are going to explore today is, I will give you a brief overview, a quick one for the newbies, that how release lifecycle looks like. And then we will see what challenges we are facing and how everybody involved in the release try to overcome that. And then what is the importance of efficient and sustainable release processes with the help of the automation tools. So yeah, that's a little about the session. So yes, let's start with taking a little bit of overview of release cycle. So it's a collaborative process that brings together a global community to deliver new features, bug fixes, and the security updates multiple times a year. So each Kubernetes release goes through different stages like planning, development, alpha, beta, stabilization, and the final release. So release team comprises of experts in the release engineering, documentation, and the community management, which coordinates to ensure each version meets the Kubernetes high standards, right? So initially the planning phase identifies the key features and the objectives for an upcoming release. Then the maintainers set a roadmap and the timelines. During the development phase, works on the contributors who have been assigned to the features, work on it, and with the help of the extensive CI/CD streamlined pipelines, we validate it. So yes, that's how we reach to the development phase. Then Kubernetes employs Prow tool, which is an automated testing system, which we will talk about in later slides. And yes, the main role is for branch managers, so which is responsible for doing the release cuts according to the timelines. So yes, let's go to the next step. So yes, I don't have right now access to the live demo, because I am not right now a release manager. I was in the previous cycle. So I thought to attach a thread which happened in the previous cycle. So yes, you can see what are the different stages, how I can perform the command. If you want to know more, you can join the release management channel on the Kubernetes Slack, and also feel free to ask questions. So yes, now after getting a little bit of overview about the release lifecycle, let's see what are the challenges the managers or everyone involved in the team face. So there are multiple challenges, but we will discuss few. So one is complexity of the ecosystem. Now everybody knows that Kubernetes is not a monolithic application, but a highly distributed system composed of various components like nodes, ports, controllers, and APIs, which interacts across the network layers and infrastructure. So each layer has its own configuration, dependencies, and stability requirements, which makes the Kubernetes ecosystem both flexible and complex. Now let's take a little bit scenario. When creating a new release, the branch manager must ensure the compatibility between core Kubernetes components such as API server, kubelet, and kubeproxy. Now, a change in one component can disrupt another and potentially leading to failure or some unexpected behavior, right? Now, let's see what can be another challenge. Coordination among the teams. As I said, release team comprises of multiple sub-teams like enhancement team, release signal team, communications team, branch manager, release notes. So yes, we need to coordinate all those who are involved. So yes, it is a multi-team effort, which is another challenge. We need to keep everyone on the same page. So depending on the specific roles to ensure the successful release. So yeah, and let's see another one, rapid changes and updates. So it is an open source project with rapid development cycles, typically releasing 3 versions every year. So each release includes new feature, performance improvements, bug fixes, security fixes, and this fast pace can create challenges. So as teams must continuously learn, make an effort, adapt and balance the demands of the new features with the need to maintain stability. So, and the major one is, as said, security and the compliance concerns. Now, security is the paramount for the Kubernetes, which especially gives its widespread use in the production environments, right? So, every day there are multiple vulnerabilities to ensure, to address and to maintain the compatibility with the container runtimes, security standards. Now, release engineers and the branch manager must also be consider the security implications when deprecating or modifying components. After looking at the challenges, let's see what are the efficient solutions for the sustainable release process. So yes, why efficiency matters? Someone might be wondering. So yes, it reduces overhead. Streamlining the release process minimizes the intervention, reducing the resource consumption. Secondly, it improves the speed and the quality. So efficient processes means faster, more reliable release timelines, reducing operational load and ensuring the predictable upgrades. Secondly, sustainability in cloud native development. So by optimizing tools and pipelines, the Kubernetes release team can limit the resource usage, conserve the energy and minimizing the carbon footprints. So ecological consideration in Kubernetes release are not only about the cutting cost, but are essential for the sustainable infrastructure management. Now, by focusing on the resource optimization, efficient CI/CD practices, node scaling and image management, Kubernetes practitioners can contribute to greener cloud technology. So these strategies ensure that Kubernetes clusters are not only performant and reliable, but also have a reduced environmental impact. So these practices help Kubernetes becoming a model for the sustainable cloud native deployments. So let's see quickly the strategies. So firstly, optimizing resource allocation through port scaling and resource requests. So yes, in Kubernetes, effective resource management means reducing the unnecessary workload and avoiding the resource wastage. Now, the efficient allocation of resources such as CPU, memory and storage ensures that the workload consume only what they are needed, right? Minimizing the ideal resource usage. Now, this strategy is central to ecological consideration in Kubernetes, but as it is directly impacts the energy consumption across the whole cloud infrastructure. Now, let's take a real world example. For example, let's say there is a large e-commerce platform runs on the Kubernetes, serving the millions of users. But during the off-peak hours, user traffic drops significantly. leaving many pods underutilized. Now, in response, the team implements auto-scaling based on the traffic demands and automatically scaling down the services when not needed. So yes, this could be a good example. Secondly, what we can do is container image optimization and image promotion. So the size of the container images directly affects the deployment efficiency and network transfer load. So smaller images requires less bandwidth and lead to the faster deployment times, translating to lower energy consumption. And Kubernetes release often involves promoting image across different environments, and optimized image make this process more sustainable. So also we can consider that, let's take an example of some financial service company which relies on the Kubernetes for its real-time analytics platform. Now each update involves disrupting new container images across a distributed environment. Now to make this process more efficient, the team focuses on the minimizing image size by removing the unnecessary dependencies and files. Thirdly, leveraging node efficiencies and sustainable node scaling. So what we can consider is Kubernetes cluster often run on the Kubernetes to manage its fleet tracking system. So to improve sustainability, they converge their cluster to prioritize node scaling. Now based on the real-time demand, as said earlier, but this is a kind of different thing you can do, cluster autoscaler. So as per the need, you can assign the values. This approach ensures that the only required number of nodes are active at any time, reducing the power consumption by almost, you can say 40% during the non-peak hours, which significantly lowers the environmental footprint of the Kubernetes cluster. Now, this one mostly would be known by many. So policy-driven resource limits for pods and namespaces. So this is kind of a resource quota. Setting resource limit ensures that pods and namespaces use only the resource they require, and by setting the CPU limits and memory constraints, administrators can prevent resource wastage, optimize cluster utilization, and indirectly reduces the power consumption of underlying infrastructure. So yes, example can be considered as an healthcare provider which uses the Kubernetes for handling patient data and running the predictive models. So given that the sensitive nature of the healthcare data, that Kubernetes administrators enforce that resource quota would be avoid to run away the resources and ensure fair usage across the applications. And the last one can be image promotion strategies to reduce the redundant pulls. This is mostly common use where people don't want to do the repetitive image pull. So yes. Now, let's move to the automation tools, like how we are resolving all these challenges and make the release sustainable. So yes, Kubernetes project have established one of the most robust and the automated process in the open source community, which supports the rapid development through testing and reliability delivery. So due to the Kubernetes complexity and the rapid iteration, automation and tooling are the most crucial part, right? So yes, in the real world context, Kubernetes releases impact a range of industries, from finance to healthcare to entertainment. Now, since they are driven the cloud native infrastructure that these sectors rely on, the journey of the Kubernetes release involves hundreds of contributors, multiple iterations of testing, and the variety of automation tools that together make it possible to make the efficient release. Now, process is highly modular, but with the specialized tools of managing the specific aspects, we can address a sustainable release. So let's take an example. what tools we are using. So one is release branch management with Grail. This is highly used in performing. You might have also seen in the thread I attached. So yes, this is one of the example I have put in here. So yeah, it is a command line tool which simplifies and automates the Kubernetes release process. And it also handles the branch management, version tagging and release guards. Now tasks that are essential for the maintaining that structured progression of the release. The main benefit of using Grail is to the release managers, which can reduce the manual efforts and directly prevent the errors and can address the release guards as per the timeline. Second is continuous integration and testing with Prow. So yes, as said, Kubernetes is having the strong CI/CD system. So yes, with Kubernetes receiving the constant contributions from developers around the globe, automated testing is critical to ensure, which doesn't introduce bugs and reduce the not needed which degrades the performance. Now, Prow triggers thousands of tests at a particular time, but on every pull request, running E2E test suites across various Kubernetes components to catch the potential issues only. Real world example can be considered as like when a developer submits a pull request, you might have seen, to update some functionality, but that change must be validated across different configuration to confirm that no single component can be disrupted. So yes, it is useful in that way. The third one is image building promotion with the K8s container image promoter. So this happens every time in the release cycle when we are when the image promotion happens. So yes, the K8s container image promoter, also known as CIP tool, which automates the management, validation and promotion of the container images through different stages of the release pipeline. Now, by handling image promotion, this tool ensures that only validated and signed images are deployed, which what it does is it minimizes the risk by associated with the release untested and the potentially vulnerable code. So yes, during the release process, this you can implement. After a particular version is released, you can import it as an image and can use it in the production ahead. So yes, this is the one thing. Thirdly, which is documentation and release note automation with the release notes command. So yeah, this is the one of the CLI tool, which syntax is here mentioned. Grail release notes, and there are several flags. You can read more in the documentation. So what it does it generates the comprehensive release documentation after once the cut is happened, and which includes the features list, feature list, bug fixes, and also the breaking changes. So whatever it is deprecated or something new, or it will appear over there, and which automates the extraction of the PR titles and summaries, which creates the structured release note. You might have also seen in the emails released by the managers. So yes, this is the one tool. Lastly, real-time monitoring and coordination with GitHub boards. So yeah, K8 CI robot is one of the famous tool which is used in this project. So yes, what it does from labeling issues and pull requests to notify the reviewers and managing test requests, it does everything. So this board also plays a crucial role in managing the CI pipeline, notifying maintainers about build or test failures that could impact a release timeline. If someone is not aware of some failures happening, so it will helpful to address it quickly. So yes, delay will not happen. So yes, it is also useful when merge conflict happens. So yeah, I would like to end this presentation here. If anybody have questions, yes.
Thank you. Earlier, you were talking on an earlier slide about leveraging the node efficiencies and sustainable node scaling. That was under the process with ecological considerations. You remember that? The one part you said, I was really curious. You said multi-stage builds enable reduced image sizes up to 60%, lowering bandwidth and storage consumption, reducing overall energy use. I was just curious. Did you have any idea what any numbers around the energy use reduced by the reduced image sizes and lower bandwidth and storage?
So are you talking about when I said that it reduces the...
It was on like a much earlier slide. Maybe go back like 10 slides. I'll tell you. Keep going. Keep going. Let's see. Wait, I think that might have been. Go back to the next one. The one. We'll go forward one, please. What back? There you go. I think that was it. Yeah. No.
So yeah, what the concern is?
No, this isn't the one, but maybe this is it. Yeah, this is 60%. So it reduces image sizes. Okay, yeah. So I was just trying to figure out if you knew what the reduction in energy use was.
So yeah, it ultimately it's kind of, as I said, that container, it is a kind of container image optimization, right? If we are building it multiple stages, this is kind of multi-stage Docker file, right? So the thing is, you don't have to repeat it again and again, and it will use the resources in the less amount. So you can say it is, we are utilizing the less amount of resources. So yes, this is a way by building a multi-stage Docker file. I hope I have helped. Yeah.
And I actually have a related question for the same slide.
Okay.
What a coincidence, right? In the second stage there, it says from Alpine 316.
Yeah.
I wonder, I have a related question there. With Alpine, one of the gotchas historically has been networking and DNS specifically. And I wonder if Alpine there is mentioned intentionally, and with your use of Alpine, have you come across those networking and DNS related problems in Kubernetes?
No.
Okay.
Yeah. Yeah, I've just put it for reference. So yeah. Yeah, feel free to connect with me if I would appreciate any feedbacks. So yeah, connect with me on LinkedIn or Twitter. Yeah, thank you so much.
All right, we're going to have a short break, like 5 minutes, and then we'll get our next presentation underway up here.
Thank you.
All right. Authenticating. Hey, we got bandwidth. And we are back for our last session before lunch. We're going to hear from Josh Lee about building open source observability stacks from raw telemetry. Take it away, Josh.
As soon as the slides load. Okay. All right, let's turn it off and back on again, right? That always works.
Side note before we get started, if you have a question, raise your hand and I'll bring the mic over to you so that everybody can hear it. And with that, take it away.
I'm not connected. Hey, there's slides. All right, let's go. Okay, so fair warning for everybody who's here because my abstract mentioned purses. We didn't get that far, so if you're hoping to learn about purses, I'm sorry. But I'm going to talk about all the other stuff. And yeah, and what's your name? Eric. Come to Eric's talk, and he's going to talk about purses. So yeah, let's talk about observability from scratch. Just real quick, an introduction. My name is Josh Lee. I currently work at Altinity. We do managed hosting and expert services for ClickHouse. Before that, I was a product manager at an observability vendor. So observability is very near and dear to my heart. So let's talk about the status quo in observability, because I talk to a lot of people about how they do observability, how they think about it, what they're doing currently. And while there are a lot of different ways to do this, invariably the answer I hear the most often from anybody who's not using a fancy vendor is Prometheus. We saw this, right? This is the Eye of Sauron in the talk this morning. It defines observability for many people. And Prometheus is great, right? I love Prometheus, but it's not the end-all and be-all, right? It's not the destination that we need to be at. And oh yeah, everybody's got some logs too, right? Like they're using Prometheus for their big picture monitoring, and then something goes wrong, and you have to like go in the river and like fish up that one specific log that you were looking for, roll it over, see if it was the right one. No, it wasn't. All right, let's go kubectl, pull some other logs, right? But maybe this isn't so bad. Maybe this isn't the worst starting point. If you listen to Charity Majors talking about Observability 2.0, right? Their whole thing, and I agree with it, is that there are only two signals. There's metrics, it's a number with some tags, and there's logs, hopefully structured, but not always. And that's it, right? Everything else can be boiled down to one of those two things. So I want to keep this in mind while we're talking about how we tackled observability for our database platform. So you should always start with a plan. So a quick agenda for what we're going to talk about today. We're going to talk about what our goals were setting out in our observability journey. We didn't achieve all of them, so I'm going to talk to you about how far we've gotten. And ClickHouse is a really big part of it for us because we're a vendor that offers ClickHouse services. So I'm going to talk about what it is, how it's useful for observability because it's a very useful observability data store, and then how we do observability for it because that's a completely different problem. All right, so if this is interesting, let's dive in. So our goals. Pretty straightforward. We want to know that it's broken before our customers do. I think we can all agree with that. We don't want our customers complaining. Goal number one. For us, in particular, we're not managing applications. We're not managing a platform. So one of the most important things is to diagnose thorny infrastructure interactions. We run our platform in a lot of diverse environments, and so there can be networking things or different interactions between the various ways of running Kubernetes, the various Kubernetes distributions and managed platforms and things like that. And that's really what our observability is focused on, is this infrastructure layer, which is fun for me because my background's in distributed tracing, which is basically useless for this problem. And we want to validate changes and migrations, right? We're improving our platform. We're not actively developing it as much as, say, like an application with like a 2-week release cadence, but we are making changes, trying to optimize our architecture, and we want to validate that we haven't broken things when we do that. And then finally, we want to analyze our performance issues. For us, a big cost is just moving data around on a network, and so that's something that we want to get as much visibility into as we can, and I'm going to talk about how we do that. We had some secondary goals in sort of redoing our observability for version 2 of our platform. One of them was that we wanted to do a lot more dogfooding. We want to use more of our own in-house tools as part of our observability stack, and we wanted to learn how to use these tools for observability so that we could educate our customers and the broader community in how to use these tools for observability. Like I mentioned, we wanted to bring our costs under control. We move around a lot of data. It gets expensive, right? Egress is expensive, so we want to manage that. And of course, ideally, if you can achieve the same goals with fewer tools, that's always worthwhile. So this abstract was written a few months ago. We had a plan at the time. As Eisenhower reminds us, plans are not as useful as the process of making the plan. So we didn't get through all of the things that we planned. Some of the reasons, or some of the roadmaps we will overcome, and in some cases we had to adjust our plan, and we're doing something different than what we originally intended. So here's our original plan. This is kind of what we set out to do. There's a little bit missing in that first line, right, where the data goes from our tenants' clusters to our object storage, because we hadn't quite figured out what we wanted to put in there. Probably we thought it was going to involve some open telemetry collectors, or vector, maybe another instance of ClickHouse server, right, for the ingest. So that's a part that we're still working on, and we're working on proof of concepts to see what's going to be the most cost-effective solution there. But the idea is that we're going to take the data, get it directly out of our tenants' clusters, put it all into S3 object storage as Parquet files, so that our platform has access to it, and our customers have access to it, and it never has to be moved around, and it's as cheap as possible. And then to visualize the data, right, we would have this pipeline from ClickHouse to a tool called Queryon, which uses ClickHouse under the hood, but translates and exposes a Prometheus-compatible API. And then we could use that Prometheus-compatible API to power embedded dashboards inside our platform using purses. Okay, so let's dive into how far we've gotten with this and sort of what we're doing. First, I want to talk about ClickHouse really quick, because this is going to be relevant to like how we're doing all of this, right? So if you haven't heard of ClickHouse, raise your hand, by the way, if you have heard of ClickHouse already. Okay, so for those who haven't, it's SQL compatible. It is not transactional, right? So like don't replace your transactional database with this, but it is SQL compatible. It's massively scalable horizontally in a way that Prometheus simply isn't. And it's really, really fast at both ingestion and querying. We're talking sub-second query times and ingestion rates that you just cannot achieve with other OLTP databases. Why does that matter? Well, for telemetry especially, we're ingesting a lot of data, a lot, right? I can tell you some volumes from the platform that I used to work for. It almost never changes, right? We very rarely want to update this data. We want to write it at the time of creation. We want to be able to query it as fast as possible. And then we're gonna delete it at the end of some kind of retention period or time to live, right? So it gets written once, read a bunch, and then eventually dropped off of the end of our logs. So traditionally, if we think about like, oh, we need to be able to read this data really, really fast, we would all think about B trees probably, is like the first thing we would think of. And B trees are awesome for reading data really fast because all of the data is already organized, right? In the format, it's all ordered by the indexes, so you can really quickly walk the tree and find the specific index for the data that you're looking for. But the problem is that the inserts are really, really costly. Inserting and updating data into a B tree requires you to move around all of the existing data and get your data into exactly the right place, right? So it slows down and it can't keep up with the type of ingestion that we need to do in observability. ClickHouse, as a kind of an OLAP database, uses a variation on B tree called a merge tree. And so basically what this means is that we're writing these very, very small partitions or parts in as the data flows in. So we have these small ordered parts, and then as that data sits on your disk, right, in the background, ClickHouse is optimizing it and compacting it into larger and larger parts, and this speeds up your queries. You can query the data the whole time, it's always available. But as we get farther to the right side of this graph, to the fully merged part, the queries all of a sudden, if the ordering here, if the order that we chose for our schema matches the common order by that we're using in our queries, which usually it does because it's going to be something like time and tenant, right? Then we get really, really fast queries because we're just doing sequential reads on the disk. Awesome. And we don't have to think about this, right? It just gets faster and more efficient. We just throw data at it and it handles the rest. So that's really cool. But let's talk about how this helps specifically for observability, right? So we get those fast writes. It's time friendly because, like I mentioned, if we're ordering that data by time, then at the end of our retention period, we just delete an entire partition. And that's really easy for ClickHouse to do, right? You just, whoop, gone. So cleanup is really easy, and it's really, really cost effective because each one of those partitions it's actually columnar, and so we have very compressible data inside each one of those partitions. It also comes with a bunch of great integrations. So this is kind of our starting point that we went on in our journey of like, how do we build an observability stack around ClickHouse? One of those primary integrations is the Grafana data source plugin. There are actually two. There's one that's maintained by Grafana and one that's maintained by us. It's called the Virtualization plugin for legacy reasons. Both are great. Both can do some of the same things. The Grafana one kind of looks a little bit better, as you would expect. Ours has some nice helper functions for generating more complex queries using macros. Then we have Jaeger, which is a great tool for visualizing traces. Jaeger actually supports a ClickHouse backend out of the box, so if you don't want to use its built-in database, just say, hey, I've got a ClickHouse database for you. We've got querying. Querying is a really cool tool, and this is actually going to be central to the new observability platform that we will be delivering. Under the hood, it uses a ClickHouse database, but on the surface, it exposes all of these really familiar APIs, also OpenTelemetry. I didn't list that there. But it exposes all of these really familiar APIs that let us get the data in from various sources and then pull it back out to all the various visualization tools, right? Loki's awesome. We don't want to ditch Loki for visualizing our logs, but we do want to replace the database so that we can control the costs of the storage. Oh, and then, sorry, I skipped a few. Kafka Table Engine, you can pump your data directly from Kafka straight into ClickHouse. And then the OpenTelemetry exporter for ClickHouse means that all of the 90+ receivers that are available in the OpenTelemetry contrib collector, you can pump all of those metrics, traces, and logs from those receivers straight into ClickHouse using the exporter. Okay, so that's really cool, right? We were talking about this middle box, storage. ClickHouse for telemetry storage. I have a whole other talk that's online that you can go check out if you want to dive into that even more. But you can kind of see, I think, at this point, why we're starting to think about wanting to dog food this for our own observability stack because of all of these capabilities. And we want to explore this and make this available to the community. But we need the rest of this, right? We don't have the rest of these things under our umbrella at Altinity. So we need to bring in other open source tools to cover all of these things. For traditional application developers, right, you would have your application SDKs. That would probably be OpenTelemetry SDKs. You're going to have your hosted node agents. That's probably Prometheus exporters, right? You're going to have your collection, sampling, and processing. That's going to be something like Fluent or an OpenTelemetry collector. You're going to have your analysis UI. So for us right now, that's Grafana. But of course, as I mentioned, we're kind of exploring Purses as an embedded alternative. And then you have alerting. For us right now, that's Alert Manager, which I'm sure you're all familiar with. So this is kind of the basis for us. The application SDK things, I'm going to put like a big asterisk because we're a database company, so we do that differently, and we're going to talk about that. So before I can talk about like how we do observability for our platform, just really quickly like what our platform does so you can kind of understand it in context. We're providing full lifecycle support for the databases, upgrades, backups, all that type of stuff, both in our own managed cloud, but also in our customer's cloud, right? We have a sort of like in your cloud product, which means that we need to give the customers all of the guarantees, all of the monitoring, all of the stability and reliability, but we don't have control over the environment. We just basically give them a Terraform provider, and it does its best to get things working, right? So in version 1, a big part of sort of how this all works is that the telemetry is stored alongside the compute, and in many cases actually inside the tenant's cluster itself. And I'll show that in a little bit, like how we're kind of pulling the data directly out of the cluster to visualize it, which is really powerful. It's really great that like we have all of this data available and it's just right there. But the fact that it's stored alongside the workloads creates problems when you're trying to investigate something that happened in the past, and maybe that cluster that you're trying to diagnose doesn't exist anymore, or you don't have access to it, or right? So there's some problems with the telemetry being stored alongside the compute when it comes to disaster recovery. And then there's also just the cost associated with that, right? We have a lot of EBS volumes, and those are really expensive. So for version 2, our goal, our platform, we have achieved these first two goals, right? It's now much more lightweight and distributed. We just have very simple Go platform that you can pretty much install anywhere and run it and use it to manage ClickHouse clusters and the underlying K8s infrastructure. And the telemetry stored externally, that's the part where we're like, we ran into some road bumps there, and we're working through it. We're working through cost control and usability to kind of make this something that we could put into production, move beyond a proof of concept. So just to kind of visualize what I was talking about with our platform, right? So we have this connector component that goes in the tenant's cloud, and then it's reaching out and talking to our control plane. Not that revolutionary, right? And then here's kind of a more detailed view of what's happening inside the tenants cluster. And now we're starting to get back to some of that observability stuff, right? We see over here we have this system namespace, and that's where we've got that co-located observability with Grafana, Loki, and Prometheus. And our goal, of course, is to keep this. We want to continue to provide this experience for our customers and for our own SREs so that they can use these tools, but we want to change the underlying storage mechanism so that it's more cost effective and so that we have better disaster recovery. So let's talk about how we do observability for ClickHouse itself, right? This is where I said there was going to be kind of an asterisk on the application SDKs. So just to level set, everyone's familiar with this definition, I'm sure. This is like the mechanical engineering definition of observability. It's our ability to understand what a system is doing purely from the outputs. We shouldn't have to like go in and change anything or do any extra work to understand what the system is doing. It should just give us enough data that we can figure it out. So it's visibility and understanding is my definition of observability. For an application, I like to talk about how like this is our basic unit of visibility into an application. And this is a request log, right? I've spent a lot of my career building REST APIs. So this is like how I think of interactions. Is you've got a request log, and from this, you can actually build up all of the things that you need in order to understand the health of your application and the underlying services, right? So this is really powerful if we're talking about an application. As a starting point, you add a trace, a parent ID, right? And all of a sudden this becomes a distributed trace. You can derive metrics from this. That's a whole other talk that I also give that you can go look up. But for today, we're talking about ClickHouse, and ClickHouse is not a REST API. Well, it does have a REST API, but right, that REST request, that HTTP request is not the fundamental unit that we're thinking about anymore when we're dealing with a database. It's a query. So here's an example, just looking at a query log from ClickHouse. I want to point out the table there, right? This is a ClickHouse query, and so I'm getting the log right out of the database itself. And you can see I have just a couple of example columns there. There's a lot more information there, right? These logs include the information about the client, information about the user, information about the parts and the way that that almost megabyte of data was written, right? So there's a lot more that we can dig into, but to kind of give you a comparison to that REST request that we were looking at 2 slides ago. So this is our fundamental unit that we're dealing with now. And it comes from these system tables that are inside ClickHouse, which include our built-in metrics. We have actually built-in OpenTelemetry compatible tracing for all of the queries, just out of the box, right in ClickHouse. And then built-in logs for all of the queries, and then for also all of the background operations that are happening, those partition merges and things like that. Then we have the Altinity operator. So this is an open source project that we maintain. This is the best way to run ClickHouse in Kubernetes, in my opinion. And it also provides some additional metrics exporters so that we can look at that layer right in between ClickHouse and the Kubernetes entities that it's running on, things like the PVCs that are managed by the operator. And all of this gets delivered by way of Grafana dashboards and alert manager configs. So these are the system tables, right? So we've got, like I mentioned, we've got metrics, we've got some logs on how the merging and partitioning is happening, we've got logs on queries, and we've got our OpenTelemetry compatible trace spans, which we actually use internally when we're trying to diagnose like thorny issues. You can just write SQL queries and piece together traces from this. Here's a look at some of the exporters, right? I mentioned like the Altinity operators adding some additional exporters for metrics at the Kubernetes layer. So this is just a diagram of some of the exporters that we're using inside our cloud manager. And then these are the ones that go inside our tenants' environments. Co-root is an interesting thing that I'm going to mention briefly towards the end. And this then, right, of course, leads to dashboards. We've got a lot of dashboards. If you take a look at the operator repo, you can see all of them. Here's an example of one of my favorites, right? So here's a dashboard that we provide to our customers inside the ACM. And the reason this is great is because they don't care, right? Like they don't care about the underlying infrastructure in the Kubernetes. They care about their queries. This is the thing that they actually have control over. And so this is where we want to surface to them where there might be things that they could optimize. Because ClickHouse, as awesome as it is and as efficient as it is, there is a bit of a learning curve, and it's very, very, users very quickly sort of hit the middle of this bell curve where their queries get really, really expensive in terms of compute, right? And so you kind of need a way to manage that and see like, okay, which users, which consumers are taking up resources, and maybe we need to optimize those. So we provide a whole bunch of dashboards pulling from that information from inside ClickHouse to show our end users how their queries are performing and where their resources are going. Then we have to alert on all of that. So some of our favorite alerts, and this is a really short list, right? You might have a much, much longer list of alerts in your platform. I know we do, right? I think we have scores. But at the end of the day, these 5 are the ones that our SREs told me are the most important. If they see one of these 5, they know that they probably need to do something. If it's any of the other ones, they can probably ignore it. So the first one and the last one, crash loop backoff and Prometheus is down, it's like, okay, everything else failed. The thing is really broken. Crash loop backoff is obvious. For us, Prometheus is down is a heuristic for showing that the pod looks healthy, but the ClickHouse server inside the pod is not healthy. Right? So either one of those happens, we know that something somewhere else went wrong and we need to dig deeper. Kube job failed. That one's really important for us because we're running backup jobs all the time. And so kube job failed usually means that a backup job failed, which usually means that there's some kind of connectivity problem. Same thing for kube daemon set rollout stuck. That usually means that a customer changed their configuration and the rollout got stuck because of a connectivity problem. And kube persistent volume usage, this is just us being proactive, right? We're providing databases for our customers. We don't want the persistent volumes to fill up. So we're proactive there, and we make sure that we take care of that before it becomes an issue. And then network monitoring. Okay, so I mentioned that application tracing is not that interesting for us. And that's because we already have all of that information, right? Like the requests coming into our application are queries, and we already have all of the visibility into those that we need. I already showed you how we do that. So we don't need to add additional context about those requests. Really, all we need to know is what's happening at the network level, because again, those egress costs get expensive. And so this is where we're actually leveraging, rather than OpenTelemetry, we wound up going with eBPF because it gave us everything that we needed with minimal effort. So one of the things that eBPF can do, it can do a lot of things. By the way, I just learned this week that it's not an acronym anymore. It's just eBPF. So anyways, it provides, you can watch any kind of syscalls that a process makes, so that would include network requests, which means that an eBPF-based observability tool can map all of your network requests and tell you what services are talking to what other services. It can't tell you that much about, right, like the application context inside those requests, but we're a database company, we don't care. So here's an example of CoRoot. This is a tool that we're currently using heavily for network monitoring and for cost optimization, both in our cloud and in our customers' clouds. This screen that you're looking at is just, it's running on my laptop in Docker with the OpenTelemetry demo project. And I didn't like hook up the OpenTelemetry collector to CoRoot here, right? Like I just installed CoRoot, ran the OpenTelemetry demo project, and using eBPF, it traced all of the relationships. It can receive the OpenTelemetry, I just haven't provided it in this screenshot. So that's pretty cool. That's really, really powerful. This is basically something that I recommend everybody install whenever you're setting up observability, because that eBPF tracing is gonna tell you where there's a breakdown in the pipeline for your telemetry. And then querying is the other open source tool that you might not have heard of that we're using really heavily. So this is what's providing that translation layer for us between these various APIs for all of the awesome, right? Loki, Grafana, these are awesome tools. We want to keep using them. So querying is providing us with an API translation layer for that. Okay, lastly, I have some community resources for you. That's a QR code for our Slack. And if you go into the Slack I promise I will provide you links for these and other resources. We have a ClickHouse function reference. So this is a really cool thing made by one of our community members that shows you what functions you can, like what SQL functions are supported by which versions of ClickHouse. The OpenTelemetry exporter client. This is great. This is built by Justin Mason from MongoDB. And basically what this does is it allows you to really easily build SQL queries, because SQL is not PromQL, right? If you want to write SQL queries on the time series data that comes out of the ClickHouse exporter, this client, which is in Go, is going to basically provide you like a query builder interface so that you can really easily build queries in something that feels more like PromQL, and you don't have to deal with writing window functions and things like that yourself. And then the alternative DB Slack, right? If you're working on any of this stuff, if any of this talk has resonated with you, please join, please talk to me, tell me what you're up to. I really want to hear from you. Okay, so before we get to questions, just some quick conclusions. In our journey, right, we're still working on it, we're still learning, but start with what you have, right? I came in being a huge fan of distributed tracing. I was like, we need to put OpenTelemetry SDKs everywhere. We tried that, and it didn't actually help us that much. So, like, start with what you have, start with where you're at. Don't proactively guard against things that haven't broken yet, right? Just focus on the things that you know break often. Guard against axes of change. For us, the main axis of change is our customers changing their configurations, right? So that's the main thing that we need to guard against, is that they would cause some change that we need to fix. And then finally, never stop adapting, right? That list of 5 most important alerts came out of us having a weekly call with our support team and our SRE team, where we just go through all the alerts that we received that week, and it's like, hey, what did we actually do in response to this alert, and do we actually want to keep getting it? So never stop adapting. Thank you. And if you like this talk, please scan this QR code to connect with me on LinkedIn. Even if you don't want to connect with me on LinkedIn, just scan it to let my boss know that you like this talk. Thank you.
We have a couple minutes left. Are there any questions?
Thank you. That's a great talk. I did have a question about just earlier on. Probably a slide somewhere between 5 and 10. You had a question. You showed how with a worm, I guess with a merge tree, that you guys have this process of taking the raw data coming in and then refining it until it's like at this fully optimized for queries part.
Yep.
And I guess I was just curious, how long does that process take from the time it comes in until it's fully all merged together? Is that like a minute? Is that like a day? Is that like a few weeks? I'm just curious.
It's on the order of minutes, right? Okay. So it's going to depend on the volume of data, but on the order of minutes.
I have 2 questions. Loki, that's integrated. I mean, but I'm assuming that's an open source project.
Yep.
That you're contributing to heavily or not, or what?
We're not contributing too heavily to Loki. We do, like, we maintain
that's Grafana,
the Grafana plugin. That's where a lot of our work goes, and that's one of the reasons why we haven't moved so quickly to Perses, is because we want to keep dogfooding that plugin that we maintain.
Okay, I see. And the eBBF functionality, that's, you showed it on the screen.
Yep.
That's, I think it's the second to last slide.
Yeah, co-root.
Yeah, so that's, co-root. Yeah, so you recommend that as far as a simple, quick and dirty way to integrate eBBF?
Yeah.
Looks pretty cool. I hadn't heard of it. Okay.
Yeah, so co-root has an agent. If you install the agent and the backend, it's pretty lightweight. And yeah, like, it's great.
That goes through OpenTelemetry, or where do you integrate?
It supports OpenTelemetry, but out of the box, it's just using eBPF. And so it's using eBPF to create this graph, and then you can enrich, it basically has an OTLP endpoint that you can send OpenTelemetry to, and it'll combine.
Cool, okay, thank you.
We got time for one more if anybody wants to ask a question.
So I've seen that you have used ClickHouse. So what if, why not Elasticsearch?
Why not Elasticsearch? Well, because we're a ClickHouse services company. So for us, it's that ability to store things, right? Like Elasticsearch is great, but it's a very, the vector database format, right? To me, I think vector databases really should be more for an index, and you want your raw data to be like, if you're dealing with data at the scale that observability vendors or like massive observability operations are, I think ClickHouse is just easier to work with and more efficient and cost effective. And then you can, from that raw data, right, calculate your vectors if you need really efficient search. But ClickHouse, right, one reason I would have used Elasticsearch in the past would have been for the efficient full text search. ClickHouse has that, right? It has token filter indexes and Bloom filter indexes. So you can do all of that, and you can still have all of the relational stuff that you like with SQL. Yeah.
Perfect.
All right, thanks. Let me just take a picture real quick. Thanks.
All right, thank you, Josh. Well, I hope you enjoyed the morning. There were some good sessions. We are now breaking for the afternoon break, or for the lunch break. We'll be back at 1400 in here with another round of presentations, but we will see you then. Thanks.
Testing 1 2 3. Testing 1 2 3.
say the right things.
I gotta know what people are gonna ask me questions about when I do my talk.
Yeah. Okay. Let's start, everybody. So. Okay. Should give a couple of seconds,
Okay.
otherwise I will keep taking care that you stay a little bit longer on stage, so that's fine.
Sometimes.
Okay, everybody, welcome for our next session. Debug like a pro, ephemeral container with Wolfie Linux image. I hope I did it right.
I'll step over here.
Our speakers are Chet and Laura. And yeah.
Natalie.
Huh?
Natalie.
Natalie.
No worries, yeah.
Oh, that's my fault. Okay, Natalie and Chet. And yeah, welcome.
Hey, thank you all for being here. I'm Natalie.
I'm Chad.
And this is our talk. It's called Debug Like a Pro, Ephemeral Containers and Wolfie Linux in Action. And we're going to be discussing today a lot about image security, supply chain security, and how you can have fast, lightweight builds with distroless, zero CVE, and or minimal container images. So let's get started. So we wanted to look into a few of the biggest pain points that people see when they're debugging Kubernetes environments. And first and foremost, complex dependency chains. These can be a huge pain because you have dependencies, and your dependencies might have dependencies, which might have dependencies. And a vulnerability in a dependency further up the supply chain can have major implications for your whole application. We also see bloated images. Like, for example, maybe you're choosing a base image that has a lot of unnecessary files that you don't need, and that makes it bigger, slower to build, slower to deploy, as well as trickier to debug just because you have a lot more going on. We see tracking updates because we know that one of the best solutions to having secure software is keeping things up to date. And that can be a pain when you have hundreds upon hundreds of packages, as well as just making sure that you have the same configurations, which leads us into our next point, inconsistent dependencies. Because perhaps you have staging, you have dev environments, you have QA, you have UAT, and you start to see something like environment configuration drift, and that can be really difficult when it comes to seeing if your software will perform the same way across different environments, but it's also a pain dealing with keeping everything there up to date. So in our talk, we distilled it into 6 main things, because we are talking about debugging, how you can debug like a pro, but we also wanted to talk about other things you can do to kind of get ahead of the problem, because we're not just talking about debugging, we want to make debugging easier, so we're going to take these steps, such as reducing noise, which is just making sure that anything in your images is necessary. It should be there. Going distroless, which is the great answer to a multi-stage build, having the very last stage of your image be distroless, having as few moving parts as possible, just your necessary files and your executable. Vulnerability scanners, just making sure that you are staying up to date, you're doing repeated regular scans on your application, your packages, and understanding what's changing, what's being uncovered, what's getting introduced day by day, as well as image building, just making sure that you have multi-stage builds, making sure that the last stage of your image is secure to reduce the number and the potential for attack vectors. Supply chain security as a whole, because you don't want to have complex dependency chains that can be very overwhelming to remediate once something inevitably does get introduced. And then just talking about debugging as a whole, like how you can use distroless images to get into that. And well, first and foremost, one of the easiest ways you can get ahead of your debugging can be reducing noise. And by noise, we mean packages, dependencies, anything in your images that aren't serving a very specific or necessary purpose. They're just there. And maybe that's coming with your bloated base image. So where possible, reduce unnecessary dependencies. And that's not just to make your image more secure, but it's also just to give you less administrative fatigue going through, sifting through all the things you have going on, because yeah, the more dependencies, the harder it is to get through the noise.
Yeah, I think we're all guilty of using either a Ubuntu base image or Alpine. Just a show of hands, how many people are using those for their debugging containers? So yeah. So yeah, that's some of the things that we're talking about in terms of reducing the dependencies and all the unnecessary binaries and libraries that we don't need for our application to run.
Right, exactly. And like something like Ubuntu or Debian might seem kind of, you know, small when you look at it from a size perspective, but what really matters is the packages themselves and the quality of the packages. Also, of course, time to build. This might not matter so much on the smaller scale, like image by image, container by container, but this starts to add up. It's very not the greatest answer to cloud costs. So when you have stuff that shouldn't be there, you're paying for it, and you're multiplying that every single time you build, deploy, run your image. And also, it takes longer, which can matter when you have a complex, complicated microservice application. And then, of course, scanning results, because if you're running frequent scans, as you should be, you want to make that as painless as possible. But if you have dozens upon dozens of false positives, false negatives that show up on a day-to-day basis, it's probably going to, I don't know, make you a little numb to the results. And when the results do matter, it's going to be harder to sift through and find out what is actually critical.
Becomes white noise after a while, for sure. Yeah. So I just wanted to point out why we use distro-less images. It may be obvious, but the biggest thing, in my opinion, is that over 60 to 100 new vulnerabilities get introduced on a daily basis. So this is kind of a chart of that throughout 2024. And yeah, we're trying to catch our vulnerabilities as close to 0 day as possible. But at the end of the day, it makes it a lot harder to do so when you have so many coming out on a daily basis. So it's a matter of not only updating your vulnerability database, but it's just staying on top of this becomes really hard. So distro-less becomes more of a selling point because you're using distro-less, which ideally contains less vulnerabilities. I created this nice little demo here that perhaps you'd want to perform on your own later today. But this kind of proves my point in that we take two images, one minimal, such as this minimal Docker file here, starting with Alpine 3.18 and adding curl to it, versus the large Docker file, which I am definitely guilty of this, using Ubuntu 20.04 as our base image, and then adding all the necessary tools that I need to debug my environment, to test my environment, to make sure that the networking, storage, etc. is accurate and running as expected. So this is very common to see, and as a result, we see a difference when we run our Trivy scan reports, right? So here's the minimal scan report on that Alpine image, which contains two vulnerabilities and one vulnerability, one CVE, as you can see, versus the large, which contains a lot more. So you have 1,016. And so this is kind of an example of a bloated image and why we're trying to move towards distro-less to not have to take action on all these vulnerabilities, but also something that we have to keep in mind as we try to minimize our footprint and minimize the potential for security risk.
Yeah, and you might recognize that those packages themselves that Chad used in the bloated images, they themselves aren't necessarily notoriously harmful. They're probably things that we're all using in our applications day to day. It's nothing terrible, but when they add up like that, there is another answer. I guess we'll talk about this a little bit later, but how you can bake them into an earlier stage.
Yeah, and those vulnerabilities don't do nothing but increase, right? So it's not going to go down as more and more vulnerabilities get detected each day. Another case for distro-less is making it easier to deploy distro-less to your environments. I have a little demo for you here as well in video form. So we'll look at a Docker image that utilizes, I think, what's best utilizes distro-less, in that we're using the same Docker file to deploy to two different environments. So if this is a multi-stage build. So in the first stage, we're building our Go application. Second stage, we're using this to deploy to our production environment. as you notice, the as production at the end of the from line. And then in stage 3, we're building a different version of our image that we're going to use to debug. So as we go through this building process, we can, and obviously this would be built into your CI/CD pipeline, but for the sake of the argument here and for demonstration purposes, we run the Docker build command with the target and then targeting that production, which is that step 2 that I showed you in the Docker file. Once we go through that, we can push that to our registry, which happens to be, for this demo, in a local registry. And then we are building our debug version, so kind of in the middle of the screen. Sorry for all the scrolling text, but we're running our debug version. Again, using that target to target that 3rd step in our multi-stage build, or the 3rd stage. And then we see we have 2 different versions, 2 different images that we're going to deploy to production now, or deploy to our environments. So one for our production and one for our development environment. And at the end of the day, what this means is that we can get a shell to our debug version of our app and be able to debug our production, being that we are running this in the same namespace and being able to run our at least networking test in this case, as far as using curl. And then this allows us to use the curl or whatever it is, wget or netcat or whatever the debugging tool of your choice for our debugging environments, and then we can deploy a different version to our production environments, minimizing our footprint in our most vulnerable spaces. Moving on, this is another example of a multi-stage build. So we can, build our binary, and I understand, by the way, that not all applications can be built to a single binary. So this is just for demonstration purposes here, but when we can, we should be using multi-stage builds, in that when we utilize our first stage of our build, it's building our application using the Golang 1.20 Alpine, but in the second stage, we can not have to use the entire Golang library and build from scratch, only using the essential binaries and libraries to deploy to our production environment.
So on that note, we wanted to talk a little bit about Wolfie Linux, and Wolfie is one of ChainGuard's images. It's actually what they use as the base image for all the ChainGuard images, which is great. So if you've used a ChainGuard image, you by default have used Wolfie Linux. And it's designed first and foremost to be run in containers. It's an undistro, and it has the base version of it. It has no built-in kernel. The dev version does, but the base version only has any necessary packages, dependencies, for its runtime itself. And it's designed on a zero trust model. It's security first. It has very few, 0 CVEs, and it's often, like as we saw before, it would be a great option to use as a secure base image for the last stage of your multi-stage build. It has the capability to generate an SBOM, and a nice thing about it is all the packages are completely granular. They're all compiled at source, and that means you can remove them as needed, and removing one won't impact the supply chain because they're all on the same level. They're even with each other. So that will not impact your application.
And just a disclaimer, we don't work for ChainGuard. We're just a fan of their work. And hopefully ChainGuard folks here in the audience are not, judging us too hard.
Absolutely. Yeah, so we can see here that we have 4 common base images, 2 of which are ChainGuard images, and 2 of which might be common ones that you're using in your containers. Like, for example, Ubuntu, like as we saw earlier, so many of us are using that as our go-to base image. And at first glance, it's not terrible. Like, in the grand scheme of things, it's pretty minimal at just under 80 megabytes, and it builds quickly enough. 4.6 seconds. But as you do see, it does have 97 packages, which the package number itself isn't necessarily as important as the number of CVEs, because you can have very secure packages, particularly granular packages. But when we compare it to something like Wolfie, we see that Wolfie, of course, is like bring your own dependencies, bring your own packages and tools. And it also clocks in at just like a fraction of the size, takes half the build time, and has not only fewer packages, of course, because it only has the necessary packages. And by the way, this is the base Wolfie. If the Wolfie dev has many more packages, but once you bring that to production, you just cut off the dev image tag. But it also, oh yes, totally. And yeah, zero CVEs. But you see, like, if we want more of an apples to apples comparison, we might look at something like Nginx and ChainGuard's Nginx image. When we see ChainGuard's, it's functionally equivalent, but it's a tenth the size. It's much faster to spin up, and it not only has fewer packages, but it has 0 dependencies. Where Nginx, out of everything on our list, has the most at 87. And as Chad said earlier, that number is only going to go up as more dependencies get discovered, come out day by day.
Yeah, so as Natalie mentioned, we can use our ChainGuard images as the base for our applications that we're running in production, but also we can use Wolfie images for our debug images. And the thing that I want to point out here is all ChainGuard images come with the kind of latest, or the kind of the default tag for the images, and also we have the latest -dev. The latest -dev usually contains, as the slide alludes to, some additional software packages, comes with a shell, and stuff that you use to do more of your debugging. So just wanted to point out there that not only are these Wolfie images 0 CVEs and minimal, but also can be used in multiple use cases. So I could see us using Wolfie across the board and deploying, like I showed you in that demo, deploying to our dev environment, deploying to our production, using our multi-stage builds. So that way we're using Wolfie and using our ChainGuard images across the board. We're not having to utilize different versions of either the base images or the debug containers that we're using in our environments. We can use the most secure option as possible just by default.
Yeah, absolutely. So I saw this comic initially during the XCD vulnerability, which, if I remember correctly, that happened on a Sunday, and it was something that we were talking about at work. And how many of you were in some way impacted by that vulnerability itself? That's probably almost half the room. Yeah, so that was a big one. And we can see, like, in this comic here, we have when something gets introduced further up the dependency chain, further up the supply chain, it has major consequences for your application as a whole, and can be such a pain to remediate. And this is why we care so much about software supply chain security. And what you can do here is, the best way to stay ahead of your security is just keeping track of your SBOMs, your dependencies, your packages. And this is something that you can pretty easily generate with either a vulnerability scanner, or Wolfie itself can provide you with this. And it's not just for being aware of current and upcoming vulnerabilities, but it's also just making sure that you can kind of audit what you're actually using. Chad brought up a good point about being able to explain every single thing in your SBOM
Yeah, so when you're going through a security audit, or maybe you work for government or a government contractor, you're going through either RMF or the MITRE framework. The idea is that you're trying to slim everything down to make sure that you can have the authority to operate, or be able to deploy your environments to whatever impact level. So that's always a concern when you're talking about having to kind of prove the things that you're using in your environments. So
Yeah, absolutely. So just making sure that everything there does have a purpose. Maybe you don't have dependencies that are redundant with other dependencies, and you can cut down, slim out wherever possible, and reduce the chances of something going wrong, and the terrible inevitability of something going wrong that you don't even need. Well, I guess it's worse when you do actually need it. You can't just get rid of it. But also just staying current with vulnerabilities. And this is something that we talked a little bit about earlier, but it's kind of difficult to do on a human level because we have like average of 100 being introduced every single day. So setting up like automated checks, cross-referencing your SBOM with a vulnerability database like CVE.org, and then for absolutely making sure that you're keeping them as updated as possible. And then here, just controlling the number of dependencies, just understanding them, and wherever possible, finding good, secure packages that don't have complex supply chains, because those are going to be a lot easier to debug. And that might be something like, for example, like Wolfie does a great job of doing that, is everything is very easily removable and doesn't have a complex chain.
I like this. I was just going to say, I like this graphic, by the way, because I've normally seen it in the context of like that one, it says, yeah, one random person in Nebraska, like being in the context of open source, where there's always this one person who's like, maintaining the entire project from their basement in Nebraska. But yeah, this has multiple use cases, right? Because we're saying here that that one thing at the bottom that the arrow is pointing to is that one vulnerability that you least expected and least wanted in your environment, and now you have to get rid of it. So,
yes, absolutely. And then just, of course, vulnerability scanners, always a great practice to have. Like we've used Aquatrivi for this presentation, but there are other great ones. And we learned a little bit earlier today just about cross-referencing, because they might not always give the same results. They might not give consistent CVEs, and you want to test that, and you want to make sure that you're confident in what they actually are telling you. And then, of course, just setting up checks with a vulnerability database, because that is a lot to work through if you're doing that day to day. But then once you're incorporating something like vulnerability scanning like into your frequent workflows, you're able to better audit and see what doesn't serve a purpose. So your reports, ideally over time, they get shorter because you're weeding out what doesn't make sense, and which can cause a lot of administrative fatigue if you're looking at 1,000 alerts, none of which matter necessarily. And we also were thinking about other great ways to incorporate different levels of vulnerability scanning. So for example, false positives can be a pain. So if you have context-aware code scanning, you're looking at perhaps a part of a package that might not impact your app. So maybe you ignore that. And you had a specific example of that.
Yeah, so I always use the example of backporting SSH. So the security scanner will almost always detect that as a vulnerability. That's an example of a false positive. It doesn't actually represent a true vulnerability. And then the other way around, right? It's like, who wants to have this big long report that is contains things that you don't really need to take action on? So it's just a matter of, and also just not detecting the vulnerability at all, right? Like if you don't keep your scanners up to date, you could miss a lot of vulnerabilities and put your environments at risk.
Yeah, absolutely. And then also just making sure that you're, with reports this long and this dense, it can be really helpful to set a threshold, because vulnerabilities have severity levels. So maybe filtering out low vulnerabilities or things that you don't necessarily plan on fixing and are just going to be in there. And the shorter your reports are, probably the more likely you are to actually sift through and take things as seriously as they merit.
Right. Yeah. You want to have a container scanner that's configurable for sure. So yeah, just to zoom out, and Eric is going to talk to this in the next presentation. So I don't want to steal his thunder too much, but debugging tools. It would be remiss if we didn't mention, how to debug like a pro. So some pro tips for debugging using kubectl debug is kind of the obvious choice, I suppose. So kubectl debug inserts a container in the same context as your main container. within the same pod. And the benefit to that is that you're sharing the same network namespace and the same storage context. So you can get at the same level as your main application and do proper debugging. And then when you exit out of that debug session, your container is terminated. So that's also a way to not have these kind of long-standing debug containers just running constantly in the background in your environment. And then using cdebug, and I watched a really good video by from our folks at ChainGuard again, showing the differences there between using kubectl and cdebug, being that you can insert certain permission levels so that you can act as root when you're trying to view the file system of your main application, et cetera. So running that in the correct security context is also a good one. Adrian has a good video on that, so check that out on YouTube on the ChainGuard channel.
Absolutely. So at the end of the day, I guess we talked a lot, not just about debugging, but staying ahead of your security. And we figured out that one of the biggest takeaways here is just reducing noise wherever possible. It makes for better images, faster images, more secure images, and just easier images to manage. When you have fewer packages, fewer things that don't need to be there, your life is a lot easier. And then as well as using Wolfie. This was one of our biggest takeaways. It's great for not only debugging, but also using as a great base image for multi-stage builds for that final stage. And it can, just by nature of being a 0 CVE minimal image, it can limit your vulnerabilities and will give you a good secure base that you bring your packages as you go, bring what you need, start small, and go from there.
Yeah, I guess it kind of seemed like we're ChainGuard salesmen up here, but definitely didn't want to make it seem that way. I think the biggest takeaway is there's more than just using particular debugging tools to debug your environment, right? And so looking at it from 40,000-foot view or the entire landscape as a whole, minimizing the footprint and using the right tools, using the right security parameters, minimizing all the noise, all these things are taken into account, not just the debugging tools. So.
Yeah. And on that note, we're here to answer questions for the next, how many minutes? For the next 3 minutes. So yeah, but you can also find us online at the links provided.
Thank you very much. Questions? Who has questions? Okay, I fly.
Hi, thank you for the talk. My question is more like, is there something beyond using minimal images? Is there some maybe tools or practices, maybe even on organizational or management level, which can help people deal with this whole problem of developers just want to ship their software, right? Yeah, I don't want to deal with vulnerabilities. I want my change to be in production, right? And then there's security people who say, well, we need compliance, we need to not have vulnerabilities and so on. Is there some maybe other tools or tricks to do maybe on the human level or something like that?
Yeah, I would say the most common is things that will kind of simulate the production environment but bring it local. So we've seen tools like MirrorD or telepresence to provide that ability for the developer to do their job and to properly debug locally, but simulates that production environment. So in addition to using minimal images and trying to slim down your images, not only for the footprint and also for the vulnerabilities, but it's I think a best of both worlds, because you're taking everything down from your cloud environment, wherever your app exists, and you're kind of simulating that for your developers to do, like you said, just what they want to do is they want to work on the application. But you have anything to add to that? Or?
It's a great question. Yeah, I'm thinking other tools that could be beneficial to developers. Maybe Dive for getting high-level insights into what's in your image and what matters without going through the fatigue and overhead of
so Dive is a good inspection tool for images. as you alluded to, developers don't really care. They just want to use the tools that they're familiar with or the tools that'll get the job done to build their application. But I guess it's always good to be aware of, and just from the administrator side, I guess, always, allowing your developers or giving your developers the proper tools that they need, but also, I feel like there's a balance that you have to strike there between, using whatever tools you want to use versus, or whatever environments you want to use, and also keeping the environment secure.
What were the first two tools that you mentioned besides Dive?
So mirror and telepresence.
Just repeat for the recording.
What were the first two tools that you mentioned besides Dive?
Yeah, so mirror and telepresence. Take your environment, kind of simulate that environment to your local workstation, so you can simulate, properly debug, simulate some of the things that you would see in production.
Any more questions? Then I would say thank you for joining and thank you for speaking.
Thank you.
Thank you all.
So we start with the next session. Integrating eBPF's superpowers into your observability tooling. And presented will be this talk from Mauricio and Chris, and I say a warm welcome for both of you.
Second. The thing's on. Hi, I'll start with introductions. My name is Chris. I work at Microsoft. I'm a technical PM at Microsoft. This is my colleague Mauricio. He is a software engineer at Microsoft. Yeah, and this talk is about integrating eBPF superpowers into your observability tooling, and we'll get started now. So this was the introduction. The little part at the bottom, we joined Microsoft both in 2021 as a part of the acquisition of Kinfolk, where we both worked, and we worked on this type of technology since then and have continued that in Microsoft. The agenda for this talk is to look at eBPF a little bit and the scope of observability. We're going to go then into an intro to Inspector Gadget, which is basically something that makes eBPF observability super simple, and we'll show you demos for that. And this, I'm going to be running through the slide portions of this because this talk should really focus on the demos. So we have one demo is going to be about triggering alerts, showing you how to use eBPF programs and the Inspector Gadget tooling to basically do alert generation. We're going to then look at how you can get these basically off-the-shelf BPF tools. We call them gadgets inside of the Inspector Gadget project, and we're going to talk about those a little bit. Then we're going to look at network latency and show how you can basically feed the data that you're collecting from these gadgets or eBPF programs into Grafana. And then we're going to look at a little bit at Inspector Gadget as a framework for observability. And then the last demo is going to be debugging a crashing app. How many people have used strace? Probably some of you. How many have used it across the cluster? Probably not. We'll show you how you can do that on an on-demand way. Unfortunately, we didn't finish the integration with Headlamp because we're working on various things there. But tomorrow there's a talk on Headlamp, and you can kind of get the idea about what that is if you go to that talk. And then we'll do a conclusion. So eBPF and its superpowers. Why use eBPF for observability? Who has used eBPF here? Have you used it directly, or have you used it through a tool? Almost everybody has used it through a tool, but a couple people have used it directly. But what we think you should do should be able to do is basically take something, an eBPF program off the shelf, and just say, somebody wrote that, similar to a container, and I want to use that in the way I want to use it inside of my system. And that's what we'll show you with Inspector Gadget. But eBPF, it basically runs in the context of Linux, the Linux kernel context, right? Usually. There's also some user space stuff you can do. But the idea is that there's some things that are much easier to do in the Linux kernel, some things that you can only do in the Linux kernel. And basically you tap into the kernel without modifying the kernel. And this is very different from something like Linux kernel modules, which basically you're creating a kernel module, you're basically sharing the kernel space, and eBPF programs, though, are safe. That means they cannot crash the kernel because they don't have that shared memory. It runs in a sandbox. This is very different from Linux kernel modules. They're very high performance and very efficient. They're basically event-driven. When you load an eBPF program into the kernel, you are basically, it's sitting there waiting. When the event happens, it executes, and then it puts some data into the map, and then that can be pulled out from the user space side. And very important is eBPF is general purpose. You might know it for networking. You might know it for some security stuff, but it can use for a lot of things. And one of the things that's happening inside the kernel is figuring out more places to use it. And so challenges to using eBPF. If you're not a kernel developer, it's probably going to be hard to create BPF, and that's why I was asking you, do you use it directly? Because there's a very high bar to doing that, and we want to lower that. The data collected is only in the context of the kernel. This means you're getting information about maybe a mount point, the mount namespace, sorry, a C group, things like this. You're not getting information about your pod or your container. So you want to have some kind of mapping there. And then managing and loading the eBPF programs across your cluster, that's a challenge. So if you're using eBPF directly, there's a lot of steps you need to do. Write the eBPF program if you don't have one, compile it to ELF, make sure it works across kernels and architectures, so it needs to be portable. Deploy across all your nodes and manage that. Load into the kernel. You can basically do a syscall or you can use a library. Gather the data from eBPF maps from user space. You can do that directly or you can do it with a library. For example, if you're doing Go, if you're doing it in Go, you can use the Cilium library for that. You need to associate that data with high-level resources like Kubernetes containers. You need to then perform any possible post-processing because there's some things, because it's safe, you can't do inside of eBPF. For example, string processing, because it's sometimes unbounded, is difficult. And then you need to format, sort, prepare that data for export to your observability service, and then you need to send it. And so Inspector Gadget kind of takes care of all of these, and that's the whole point of it. The description we have on the GitHub page is Inspector Gadget is a set of tools and framework for data collection and system inspection on Kubernetes clusters and Linux hosts using eBPF. And so we're going to cover some of the tools. We're going to look at a little bit of the framework, and then we're going to focus mainly on data collection here. Interesting is that Inspector Gadget can not only be used for observability tooling, like feeding it into something, doing metrics gathering and things like that. It can also be used on the command line directly. You can actually even interface with the same BPF program in both ways. You can be sending it to the metric server and log in and see what it's actually doing on the command line. And we're going to be focusing on Kubernetes clusters, but it also it also supports running it straight on your Linux host. So this means that sometimes if you really want to, the Kubernetes cluster support relies on the Kubernetes API. If you actually want to get below that, you can actually just install it directly on the host. So before we get to our first demo, I want to run through these key features so you're kind of understanding what's going on, what's the point of this. So Inspector Gadget builds and packages eBPF programs into OCI images called gadgets. It distributes and manages the eBPF programs across your cluster. Now, if you look at these first 2 points, people have said that basically it looks like a package manager and an orchestrator for BPF programs. And it does do that. It also does other things. It collects and exports the data to observability tools with a simple command. So you can use a command line, or you can use a declarative configuration, which I think we added in the last release. This means you can check that into GitHub and just have that run again the same way. It has security mechanisms. Because these are OCI images, you can pull them down from different places. You want to be able to restrict or lock that down in some cases, in a lot of cases actually. It does automatic enrichment. Now, enrichment is that term for mapping that low-level stuff to the high-level resources like Kubernetes and containers. It also supports WebAssembly modules for doing post-processing when you can't do everything inside of the BPF program. And then you can use it in any Wasm supported language. It supports many modes of operation. You can use it from the CLI. You can have a client-server relationship. You can actually start in daemon mode and then talk to it with a client. You can control it by the API, a gRPC API. And then it's also embeddable via Golang library. So you can actually take Inspector Gadget, have that, use the library, and you have all the functionality, but it's just a library in your application, as long as you're using Go. So the first one will be about alerting when, for example, a shell is opened. So Mauricio.
Thank you, Chris. So the first demo I'm going to show you is how we can get alerts when a specific process is executed on the system. In this case, when a shell is executed on the cluster. And yeah, in order to do that, the first thing that I need to do is to deploy Inspector Gadget to the cluster. What I'm saying here is enable Inspector Gadget to export metrics to OpenTelemetry. We are using the OpenTelemetry library to export metrics to Prometheus as well. And then this is the address that we want to use for those metrics. So this is deploying Inspector Gadget on the cluster. And before this, I already have Prometheus deploy on the cluster. I'm not going through all the details of this Prometheus deployment that I have here. The only thing I want to mention is that we are using the service discovery feature of Prometheus. What it means is that we have configured, we have annotations in the inspector gadget pods with some label that say, hey, Prometheus, please scrap the metrics from these pods. So there we have annotations with the name of the metrics, the path, the port, and so on. Okay, so I'm going to deploy this gadget here. So this is how we can deploy a gadget to a Kubernetes cluster. This is very similar to how you deploy a pod in Kubernetes. So we have a YAML manifest. In this case, it's an instant spec manifest. We have the image that we want to run. In this case, we are using the trace-exec gadget. So this is a gadget that provides information of what are the processes that are being executed in the cluster. We give a name of that gadget instance. And then in this part of the configuration, we put all the parameters that we want for this specific gadget. So for instance, here we are enabling this gadget to work on all namespaces. So we want to monitor all namespaces on the cluster. We could be providing a list of specific namespaces that we want to provide, that we want to monitor if we want to do that. In this line, we are configuring the filtering. So we are only interested on shell. So we are filtering only events which process is named bash. For sure, if we want to monitor other shells, we should be including the names of other shells there as well, but this just, for this demonstration, we only care about bash. Then we configure everything that is related to the metrics. So we give a name of the metrics that we want to expose. And by using this annotation approach, we configure those metrics. So here we say to the gadget, hey, expose the metrics. Here we say, let's count those metrics on user space. So for this specific gadget, we don't do the counting in BPF, but we do the aggregation and the counting in user space. So this is a way to enable metrics for gadgets that don't have that support directly implemented on BPF. Finally, we also configure what is the cardinality of the metrics that we want to collect. So in this case, we will have labels for the Kubernetes namespace, for the pod name, and for the container name. So this is how I can deploy that to the cluster, very similar to how you deploy something in Kubernetes. So I pass this file here, and I'm using this detach flag to say run that on the background. And yeah. For sure, this is a demonstration. I'm forgetting about the right command. There we go. So if we do a kubectl gadget list, we can see that our gadget is there on the cluster running. And the nice thing, as Chris was mentioning before, is that we can attach to those gadgets to see what they are doing. So yeah, let me get the name of this right, process. So this is a way how we can debug what the gadget is doing. So in case this is not exporting the right metrics, we can attach to that and understand what is going on. So I will run a pod on my, oh, it's already there. Great. OK, I can change the name. That will be faster. So I'm running a pod on this. And as you can see there, we got an event saying, hey, this process was executed on the pod. So we are only monitoring this process. And what is happening here is that this gadget is providing that information on the terminal, but at the same time, this is exporting that to Prometheus. So if I go to the Prometheus instance that I have running on this cluster, I can look for the metrics. So the metrics is shell execution total. If I look at that, you can see that for my pod Ubuntu 3, there had been 3 executions of the bash command. And once we have the metrics available on Prometheus, we can configure alerts on top of that. So I have this alert that will say, that will fire once that counter is more than 0. So it means when a process was executed. It will take a little bit of time for that metric to fire. I will be back to that in a second.
Yeah, so while we're waiting on that, let's take a look at actually what these tools are, or these gadgets are. Basically, these are eBPF programs, and they're packaged in OCI container or images, right? And you can, this makes it so we can use very similar tools to what the container infrastructure stuff uses. So we build and maintain many gadgets. We have almost 30 now, so you're bound to find something useful. But if you don't find something, then you can reach out to us, and we'll, we can either offer our help, or we can help you do it yourself. We're happy to take PRs for things like that. But the cool thing is, because this is OCI image, you don't have to actually interface with us. You can have your own in your own repository, and you can just make use of the framework. But gadgets are more than eBPF programs. So you have one or more programs in a gadget. You also have a Wasm module, which allows to do this post-processing. And then we have the metadata YAML. You saw in the last demo, there was a field where we could say, oh yeah, only fire this on bash. So this actually is doing on the bash executable. This is something that the metadata will define. So the metadata basically defines the capabilities of that gadget. There are some gadgets that have a stream of events, like the trace gadgets. This one that we looked at was trace exec. There are others that do an interval, kind of a top thing. There are others that just give a snapshot. And then we have a few other types. So that's defined in the metadata, along with some parameters that you can pass, for example, the bash one. And then lastly, we have this BTFGen. This is for portability, so this will run on many architectures and many different kind of kernels. So if you're looking for those gadgets I was talking about, you can go to Artifact Hub. We have a bunch of them. Here I have it filtered for the official ones. There are some unofficial ones, and if you create one, you can share it there, and then other people can make use of it. So that's the idea, and it's very similar to how the container world works. So we're going to take a look at the result of that last one, and then do the network latency demo using Grafana.
Yeah, sure. Thank you, Chris. So this second demonstration is about how to get network latency by using some of the gadgets. But before that, you can see the previous alert is now firing, and we got the message here that says truth shells have been secured. Okay, so yeah, in order to provide or to collect the network latency on the cluster, we can use this gadget. This is something that we call profile TCP runtime time. So it gives you the latency of the TCP connections on the cluster. So I'm going to deploy this in a different way this time. So I have a script here. And instead of using a manifest file, I will just run that from the CLI. This is just to show you another way to run a gadget. So the syntax is very similar to the previous one that we have on the manifest. So in this case, we say, what is the image that we want to run? We also give a name to that one. The dash is the same meaning, not to remain the terminal attached to that process. And the annotation is very similar. So we are enabling the collation of metrics there, and we are giving a name to the metrics that we want to export. So yeah, the gadget has been deployed. Again, if I do list, you can see that we have that gadget already running on the system. And as before, we can also attach to that one. So yeah, in this specific case, this gadget is able to output a histogram to the terminal. It could be useful in a case you don't have Prometheus or Grafana available on your cluster. So by only using the terminal output, you could also be able to debug some of the issues that you have on your cluster. Right. So in this time, I have configured Grafana to talk to Prometheus, Prometheus to talk to Grafana. So yeah, let me show you the dashboard that I created for this one. So this is a heat map. It's telling us what the latency for the connections is. And yeah, actually this is an empty cluster, so I don't have a lot of connections there, but you can see that there are some packets and the latency that they have. So I'm going to deploy a small application on my cluster that is going to create some TCP traffic. So this is just a client and a server. The client will try to download some files from the server. So hopefully we'll be able to see some more traffic on our dashboard. So let's see if that's running. Yeah, that's running. So if I go to this one, you can see that here we have a lot of packets there, and almost, the latency for almost all the connections in my cluster is about 8 microseconds. So yeah, this is because we are running on the same machine or whatever. But what about if I introduce some latency to those connections? So I'm going to use TC with a QDisk in order to introduce a 10 milliseconds latency for all the connections coming from the client pod, and hopefully we'll be able to see a difference in the heat map that I was showing before. So I'm going to refresh this as much as possible. So as you can see, we are starting to get some numbers on this one. So as you can see, we are getting more and more packets on this one. So it means that the latency of the connections on our cluster is changing, and we are having a higher latency. So yeah, actually, I don't have the time to wait until all of this is done, but in the end, we will see that most of the latency is around the 1 millisecond there. But yeah, what about if we want to debug why this latency is happening? So what is the reason why our network packets are taking too long to arrive? So in order to do that, we could use another gadget. So we have this straight TCP drop gadget that is going to tell you when TCP packets are being dropped by the kernel and why those packets are being dropped. So let's run the gadget there. And as you can see, we have a lot of packets that are being dropped for the core client pod. And this is the reason. So this is why the kernel is dropping those packets. And this reason corresponds to the TC QDisk that we configure on that pod. OK, Chris?
All right, so we just demonstrated 2 more tools, the round trip timing and of network packages, and then also the drop packages. So, but those, so basically these gadgets, they're can be used in many different ways, and we just saw that. We just saw some of it going to metrics, some of it you can use it on the command line, and you can interface with these by API or even by consuming it as a library, right? So the idea is that when you create a gadget, it can be used in many different ways. And so this adds not only value to the framework, but also if somebody's going to create a BPF program, if you do it as a gadget, you can use that in a lot of different ways, and you don't have to do all the boilerplate stuff for the specific use case. You can just do a couple configuration or parameters. So the metadata, as I've expressed before, defines to the framework the capabilities of the gadgets. So if you try to, for example, send metrics to a from a gadget that doesn't support that, then it'll error out, right? So it allows really the developer to deal with the business logic. I put business logic because I never knew what that was. But you know, it's the stuff that you don't want to have to deal with. It's the stuff that adds value to what you're doing. You don't want to have to do this boilerplate. And for here, you can get rid of the boilerplate if you find an off-the-shelf gadget. But you can also get rid of the boilerplate by just, you know, if you create your own gadget, then using the framework and not having to do all of that. And the framework is designed to be extended. For example, we support now Kubernetes and container runtimes for getting that information. We want to extend that to, for example, VMs or systemd, so to understand what units it belongs to. But we don't necessarily want to have to bake that in. So we want to have this idea of extending the enrichment or other parts of the framework. So the next one is about debugging a crash app, and a crashing app. And what I will say about this one, this is the one that we didn't quite finish, but we'll talk through basically the use case at the end if we have time. Right.
Yeah, sure. So the idea here is there are times when you have an application that is crashing on the cluster and you have no idea what is going on. So the application is not providing any login, and you cannot use any other tools, maybe because you are using a distroless image, so you don't have any other tools available on the container to debug what is going on. So we have a gadget that is called traceloop. We can think about that gadget as a flight recorder that records all the activity performed by the different pods or containers on the system. And when there is a crash, we can see what happened to that container. So it's quite similar to the idea of a flight recorder on an airplane. So when there is a crash, we are able to understand what happened, what was the data of the different sensors, and so on. So the first thing that I'm going to do is to start traceloop on my system. And then I'm going to deploy my application is a very simple. It's a very simple pod in Kubernetes, so this is using a special image that I created for this demonstration. Okay, so if I check, you see there is an error. So this is not on ready state, and this is being restarted. So we could get the logs from that. This is called my app, but as you can see, there is no any information there. So maybe we can use trace loop for that. So I can do the list command. So this is going to print the traces for all containers running on the system. So as you can see here, I have 3 different traces for my app container. So it means that it has already been restarted 3 times by Kubernetes. So I have different traces there. So I can use the show command, trace loop show, and let's pick the last one of that. So by doing this, we are checking all the syscall activity of the container. Let's remember that this container is already gone. So this is like looking into the past of the container. So we see what is the command that we're executing those system calls. We have the name of the system calls, and then we have all the information about the parameters and the return value of those system calls. So maybe we can just jump right away to the last syscall that was executed by this container. So we can see that it was trying to open a file. This is the name of non-existing file, and there was a -1, a return call. So this gives us some information. This container is trying to open a file, and after that it's crashing. So probably we could investigate why this file is not present on the system, or why the container is crashing for that. So I can show you very quickly the implementation of this program. As you can see, I'm opening a file there and not performing any checks on the return value of that. So my application is crashing around here. Okay, Chris.
Yeah, so the idea there, and what we actually wanted which we actually had a POC like a few years ago actually, that we wanted to actually implement for this and actually get as a plugin for Headlamp. By the way, there's a talk tomorrow about Headlamp, which you can get a better understanding of that. But the idea is that if you have an app crashing in your system, you can push a button, activate this, and then the next time it crashes, you can get a notification and says, oh, you can take a look at this, because this is going to run across your cluster. It can, it might be only certain instances of that app that crashes, and this will be able to find that. So across the cluster. And this is very low overhead, nothing like strace. So to wrap it up, if you want to use eBPF for observability, you should really take a look at Inspector Gadget. And we're also very open to conversations and trying to expand use cases if we haven't covered something that you might be interested in. The status, all major planned features are now merged. We've been working on this for like 2 years to get it this way. So we're very happy about that. We're working on 1.0, likely mid next year. We are eager for feedback to attain that. You might want to take a photo of this, but I can also show it to you later. This is all the things that we're doing here at over the next week. So I'll leave that on a second. Okay. And then, yeah, we have GitHub, we have a web, and then I put these links in the README in a PR for the project README, so you can find them there. And that's the end of this talk, but we hope we can talk to you about using Inspector Gadget, and look forward to your feedback. We have only a little bit of time for questions, I think, though.
I think we have time for questions, so. Any questions? I saw there. Okay, 2 questions there. Okay, let's.
Yeah, you said, yeah, thanks for the talk. You said at the end that this has a low overhead. Any ballpark number on how low is it?
The last time we did testing on it, it was so low that we were like, that's like, it was like less, it was compared to strace, it was hardly noticeable. So what this does, it basically puts this into these traces into a ring buffer, and they're just sitting there. When it crashes, you saw this list, right? They hang around, and so you can retrieve those later. And so that overhead of basically the BPF program putting stuff into that ring buffer is very, very little. But yes, there is some overhead. We do need to remeasure that. But yeah, sorry, I can't answer that.
A bit of a follow-up. So you were constantly running the tracing and
only when you activate it. The idea is that you we could have an automated system that says something is repeatedly crashing, identify it. And so the idea with this is that you don't run it all the time, right? You say, okay, this thing is crashing. I need to figure it out. And you basically activate it. And for that time, until you get a notification, you can just keep it running. That's the idea.
Could you please explain a little bit about the Wasm integration? I didn't understand exactly how that works. And why did you do that?
Yeah, because
and when?
For example, we have
you give me the second to the last slide as well. I didn't get where you're going to be given the workshop.
I'll give you a
yeah, that thing. Yeah, no, not
which one?
Okay. The second to the last. Yeah,
okay,
that one.
So the Wasm is there because you can't do everything inside a BPF because there are security. It's a safe environment. Yeah. You can't just do unbounded looping. And when you're doing stream processing, you might want to. You might not be able to do what you need to do inside a BPF. And so, for example, for our DNS trace tool, because that uses a lot of stream processing, what we do, we then send all that information to user space. We use the Wasm module to do the processing, so we can get the full, URL and the name resolution for that.
So it remains in the browser then with Wasm.
What?
It's for the browser. It remains in the browser with Wasm then, or what is? I didn't really understand.
Well, I mean, it's just a runtime, right? It doesn't. I mean, right. WebAssembly has a stupid name now because it's identified with the web, but it can run in the server. It's just a process environment, sandbox.
Okay. Yeah. Okay. And when did you do that? When did you add that?
What is that?
When did you add that capability?
Probably about 3 months ago.
Okay. Good. Great.
Last question, okay? Quick one.
Yeah, thanks for the talk. So did I understand it correctly that all the information about the traces and crashes are stored in the node itself? So when the node is gone away, we lose all the data?
Yeah, so it's all in these ring buffers, right? And until you pull them out, like if you set up, for example, if Prometheus is fetching those, or I think it's like pull, right? And they'll just be there, and they'll be written over if it goes too much. So you need to have an interval that's like, that doesn't allow for that overriding. Generally, that's not a big of a problem because it can hold quite a bit of information. But yeah, it stays on the node. We don't have any like storage or anything. There's no storage. It's just in the kernel, and we try to get rid of it as soon as we can.
Gotcha. So the CLI just fetches all the ring buffers of all the nodes and prints out what's there at the moment.
Yeah.
Okay, gotcha.
Yeah, it's very, very efficient. And if you want to build on something on top of that, that's the whole point. This is a general purpose tool. Make it yours.
Okay, then thanks a lot for the talk. If you have any questions,
everybody.
I think you will be around and answer the questions. And yeah, stay tuned for the next talk from Eric about new kit in the sandbox.
Oh, yeah. Is it off? The guy's next door. He's right around the corner. You can give it to him. It's not mine. Whew.
Okay, everyone. Let's continue with our next session. Are you ready, Eric?
Let's see if it works. Yep.
Okay. This auto subtitles are wild. I don't know if you keep attention of this, but wow, they are really wild. Okay, next talk is Meet the New Kid in the Sandbox, integrating visualization with Prometheus from Eric.
Quick question, is it being recorded?
That's a good quick question. Is it being recorded? I think yes, yeah.
So we could test the AI with some dirty words, but not if we're being recorded.
Okay, then yeah, welcome.
Okay, here we go. Meeting the new kid in the sandbox. Did anybody attend the observability talk by Joshua earlier? He mentioned in his abstract he was going to talk about Percy's, right? But like he bailed on us. I don't understand how he got away with that, but he's right there. Hold him to it later. That's really bad news. Why are we even talking about this? That's the first question I'd like to answer. People are like, why Percy's? Why do we need something else? There is something really well known in the observability space right now. Big company, but they changed, some of their licensing, and the open source community stepped up and said, hey, we're missing something in the CNCF landscape, right? There's no observability, visualization, or dashboarding project in there. There really isn't. All these different projects have embedded some stuff in there to like visualize what they do, come up with semi-solutions, really specific tools for this. So this was a big thing that they didn't have. The team that's involved with initially doing this Percy's project also was pretty heavily involved in Prometheus. So they decided, let's focus on metrics, provide visualization for that, and integrate into all that tooling together with Prometheus, providing the complete ecosystem that we need to do something with observability, right? And then, of course, full open source, you have choice, you can do whatever you want with it, you can walk away, fork it, all that kind of stuff, right? Any questions about this? This is usually where people get a little bit shaky at the beginning about why we're even doing this stuff. So the initial commit is listed there. One of the things that we're very much focused on is something called dashboard as a code, and we're not looking to create a new acronym or anything like that, but when you do dashboards at scale and have thousands and thousands of these across your organization, you're going to find that it's really handy to have a specification for these things so you can work in your CI/CD pipelines and automate the deployment of your dashboards along with your workloads, right? So your developers are doing something out there. If I can just push out code chunks and it turns into a visualization dashboard for them, that's pretty nice, right? That was a big aspect of this. So looking at the GitOps and ability to do that. You'll see a little bit later some of the heavy hitters inside this that are running it right now are from Amadeus. Amadeus pushes a lot of this stuff around. So it's a really good test set that they've used to make sure that this stuff works. Providing embedded visualization. So anything you want to do with this stuff, you can embed somewhere remotely in your organization. So think about in our Kubernetes infrastructures, and we're pushing this stuff out together with each node, maybe, out with our workloads out there, right? Also very much focusing on the Kubernetes environment, so I want to be Kubernetes native. So you're going to find operators, you're going to find container images, you're going to find CRDs all work, all these kind of things that we're used to working with as developers in this space, right? Also the static validation is a big one. Because it's a standard, it's awful nice if you can validate your code and make sure that it's actually going to produce a dashboard and not puke out there when you try to run it, right? Big deal there. They also have a plugin infrastructure where you can do whatever you want inside the plugins to expand on the stuff that's being done. So they're kind of setting up all this infrastructure. All this happened before they came into the CNCF sandbox. And I thought it's always kind of fun early in an organization that goes these kind of steps inside of an open source project to kind of stop and catch the history of what happened. And I happened to get involved in observability at Chronosphere where I work around the time that this stuff was starting to pick up. And you'll see quite a few commits from Chronosphere developers in the beginning. And so I said, okay, well, this is something I'm going to go look at and help out with if I can. So I started messing around in there. And I started a discussion back in September 2023 at not this year's PromCon, but the PromCon, so the Prometheus conference, with the guy that was leading it, Augustin. We sort of had a side chat about it. I said, you guys should go into the sandbox, right? I'm an ambassador for CNCF. We should get this stuff rolling in that direction, right? They were initially working out of the Linux Foundation, which is not a bad thing. But the whole goal, the whole thing in their mandate was they wanted to be a CNCF observability project. And so in March, I think they put it together. Second week of August, they actually submitted, and it took 2 weeks. 2 weeks, and it got approved. That was crazy. I don't know if you've seen previous teams, how they've done that, but that's super quick, right? I think they got 110 little thumbs up on the Git issue from non-voting people. So apparently people have been watching this a little bit, right? A lot of people jumped on the bandwagon, so that was really nice to see. Sandbox is the first step, right? First step along the way. You will not see them if you're going to the KubeCon thing with a little teeny booth over there where all the little sandbox things are at. They were too late to apply for that stuff. The target is to do that next year in London. So that should be the first time you'll see everybody there. And most of us are in Europe that are working on it anyway, so that's kind of the team you're going to expect to see. So we talked about how you have a dashboard standard and a way of working with it. They produce an API, as you can see, and I'm stealing a lot of stuff out of a hands-on workshop I'm going to give you when we're done here, so you can see what we put together. You can use your browser just to test it, that it actually works when it's up and running. It's really a simple HTTP thing there. Provides all the different things you need to do, and you notice that all the answers come back in some kind of standard JSON format, right? There's our standardization. You can cut and paste that stuff and move that around your organization. They actually have a command line tool that's provided when you use the actual project code. It's called I don't know exactly if you want to say like kubectl and all that kind of stuff, but it's Percy CLI, PER-CLI. You see here how it works, like you can get things, you can delete things, create things, and when you're creating them from an actual standardized piece of JSON. Yeah? Everybody's used to working with that stuff. You can look at the data sources. We can describe them, cut and paste that code out, and you got a copy of it. Really nice little tool. Also used for the validation, and something that I didn't really highlight too much in here, but this is also a tool you can use to validate existing dashboards, and you can also use it to import Grafana dashboards. The coverage of that import is not complete, of course, because people do all kinds of crazy unorthodox stuff inside of Grafana. That doesn't really have like a standard code back into that. But a lot of the stuff has been done, like the thousands of dashboards that they've imported and translated across at Amadeus. So they like to say in the project, most standard things work. So if you're not doing any crazy stuff, it probably works. So when I did this at PromCon, that's where this update came from. They know the project, so I didn't go super deep and hands-on. We can do that at the end if we have some time. I can show you what it looks like, and we can do a little demo and stuff. But this is what you got. When I first made the workshop that I'm going to give you guys later, that's from zero to whether you use the source base and compile the code like in the old days and use it running on your laptop or running it with a container. You could do either one. They did not have, the very first version, they did not have a UI. That's how young this is. So the version they just released this last week is 0.49.0. So it's super young. You know, realize what you're dealing with. They didn't have any of this. So I was teaching you what the standardization was, what the JSON looked like, and how to modify it and what to do with it. Right? So that's still in the workshop. I keep that in there so then you have an idea. I walk you through what the standard is. Right? So how this is formed, you can look at it any time because they always have a tab down in here that's got JSON on it. So you can go look at what the JSON is and what the standardized form is. When you come in here, it's a pretty big screen. I couldn't get it all on there, but the add panel is at the top. So you're deciding what kind of panel you want. There's a whole list you'll see later in a few minutes. And then you have a preview and the query. And if you recognize the query, it's PromQL, right? Prometheus query language. Very standard, very well known within the metrics landscape. It automatically pops up with whatever you're doing, and then you can switch over to the settings. And the settings gives you more actions based on what you're doing. From changing color, putting thresholds, depends upon what you're working with. There's a whole list, for example, if you go in here and you say, oh, what kind of unit do I want? That's what all these are. So there's all kinds of stuff depending upon the thing you're pulling in. And you can pretty this up, and once you submit it and save it, you end up with your final panel element that's on your dashboard, right? So I'm going to walk you through all the things that we can actually do, which is kind of nice to know. So here's a gauge chart. So a gauge has to do with counting how much of something there is. And one of the things you really like to be able to do is to change the colors on your thresholds, right? You don't want 3 shades of yellow that are hard to understand. Red, yellow, green. You also notice there's the ability to do some stuff around variables. So that means in my data sources, I have multiple instances, multiple jobs, multiple things going on. That's the complexity of a real environment. You can also do these things by putting actual instance names in there if you want. It's also in the process of integrating the PromLens code base, if anybody's aware of that. That is sort of a teaching tool that got put together by Julian Folks. Sorry, was there a question? Oh, that's somebody's computer. What that does is when you type the thing out, it's auto-detecting, and it's also splitting out the query and showing you what the returns are, so you get multiple sections of the query, what the amount that is a return and what it's doing. It kind of teaches you how to do PromQL. Anybody here good at PromQL? Anybody really bad at it? Yeah, it's hard, right? It's a lot of playing around, it's a lot of tweaking. I have a hard time with it too. It's not easy. We have an internal channel called Prom Queens. So please help me with my query, right? So it's a lot of fun play. This right now does auto-completion, but they also have an Explorer on the front end of the UI with the newer versions that lets you start seeing they're integrating that stuff right now. So you're going to start seeing more and more of that. Time series, one of the more interesting ones, like 3 different instances with jobs. They're all variabilized, so you're getting basically everything. It's a lot more than this. Thresholds. I didn't check in the last one. It's an issue. We can't rename the thresholds yet. You might be able to now, but you see that that's one of the things. But this is I'll get out of the way so you can take the picture. Slides are all online right now, by the way. Save you the trouble. So a lot of little things like that. If you like it, raise an issue. We'll fix it. You know, they'll get to it eventually. It's all these kind of things with Rolling Thunder. You see here also that it's a little bit different story here of things you can do. You can show or not show or fill in, spark lines and all that kind of stuff. It's getting better and better. A documentation panel, basically with what do you call it? Markdown. You can do Markdown and do your documentation. Because who here has carried a beeper? Been on call? So you're quite happy when you show up and you're responsible for a service and all the links to all the troubleshooting playbooks and all that kind of stuff is right up front. This is something you definitely want to have. Shows you immediately what's going on with the code you're making, which is kind of nice. You don't have to go test it somewhere else. It does multi-gauges, so you can get complicated, fancy stuff going on. Here we're doing an app. Anybody that knows PromQL that's getting a little bit more funky here. It's a little bit more interesting, and multiple results come back, so you can put them in multiple gauges. Change the colors again and stuff like that. We got tables. This is one of the newer ones. You can select stuff and show it up in a table format. Maybe when you're doing cost reports and stuff like that, that gets a little bit more interesting to have a table. And a bar chart's a brand new one too. So getting there slowly but surely, a little bit of everything. Tracing, didn't hear anybody ask about tracing, but tracing has been integrated by our good friends at Red Hat. So they're also contributing to this project. Kind of a funny story because when you think of tracing, what do you think of when you think of CNCF? OTEL, right? So if it's OTEL, it's OLTP. OTEL, that, yeah. Tongue-tied. But here, this is based on something else. This is based on Grafana's Tempo trace query. Because it's the very first commit, it's the very first contribution, and they tailored it to their OpenShift container platform, which uses that in the back end right now. And they were kind enough to share what they turned it into. So this is an example of Percy's embedded in an actual, I think you guys know what OpenShift container platform is. Container management. Kind of like Kubernetes with the layer. Yeah, there you go. So you see here that they're doing tracing, scatter plots, and all the stuff you would normally expect. But they're just using kind of their own specific thing, and that's all that's in there right now. As any good open source project does, it takes what they can get and implements it, right? Like puts it in the project. Here you see the drill downs into the waterfalls and all that stuff. This is an example inside of my organization where they have put together some dashboards and stuff that are a little bit more complicated for bigger, large-scale organizational stuff. So this is a SaaS platform where a lot of people are digging into a lot of data. Here's an example of what traces look like at ours. To be fair, this is not using Grafana trace query stuff directly. This is using regular OTel stuff. So, all right. Anybody wants to go play with it can do it right now. You might even be able to do this on your phone. I'm not sure. When you go to log into this right now, last time I checked, it's sign in with Google or sign in with GitHub. So you sign in, you'll do some Google stuff with your apps and stuff to approve yourself, and then you're in. You get in there and you're going to see a bunch of stuff. We can look at that in a second. You can see a lot of people have been playing with this because they host one instance, and there's no guarantee your stuff will be there when you get back. This option is integrated into my workshop because I think it's pretty cool. And the chances are not really great that you're going to be in the middle of whatever you're doing and they happen to do a new release and restart this thing and wipe all users, wipe all projects. So just be aware that's what happens. The rest of my workshop, if you do it with the source build or you do it with the containers, you can stop it and spin it down and go away and come back later, spin it back up and continue on all the time, right? That's the idea behind that. So one of the things about this is how do I get stuff in here without doing it, clicking and doing it all by hand? You saw I showed you the command line interface, right? The tooling. There's the ability to connect the tooling on the back end of this with the login command. And it's going to ask you some, if you, for example, do it with Google, it'll ask you for some Google verification. It basically asks you to go open your Google app and it'll give you a number and you type it in on the console and then you're in. And then you can do your gets, your pulls, your applies, all this other stuff, right? I'll show you that in a second too. Just like you would do with the local instance. I think it's always kind of fun to, and this was more meant for the PromCon where all the actual Prometheus developers were there because there's quite a few involved. But here you see the top committers from about 3-4 weeks ago, maybe a month. And you see that Amadeus and Chronosphere were the heavy ones in the beginning. That's changing quite a bit. We're seeing a lot of people come in from other places that are doing specifically things that are interest to them, which is how it should be, right? That's kind of how it works. You even see I did a few. I won't lie, I just did docs. Their docs were really horrible, I thought, in the beginning. So what do they always tell you to do? This isn't my first open source project. So I said, hey, I got a workshop. How about I do some user docs, how to get started with this thing? Because what they had at the time were super engineering docs, which is fine. How do I do auth? How do I do API interactions and stuff like that? But those are not a lot of fun when you first spin the thing up and you have no idea what you're looking at, right? You see Red Hat starting to get involved. These will just become more and more. I talked to this guy quite a bit, Andreas. I think it's interesting what they're doing inside OpenShift. So some of the stuff you can build with this, it's quite comprehensive. There's not a lot you're really missing, I think, at this point in time. And it's fairly lightweight, right? We're not talking about some big heavy tool or something that's hard to do something with. It's containerized, so you can spin it up anywhere and everywhere you want to. You can do it in Docker, you can do it in Podman, I don't care. It's a specification, right? A little bit of everything. If you do the workshop, this is exactly what you're going to build from scratch, from nothing all the way up to this. That's pretty cool, huh? I think you guys can do it. So if you want to scan that, this is where the workshop is at. This workshop is Reveal.js, HTML stuff, so you can do this on your phone, can't do the actual code. Though I did one time do a Prometheus workshop where the guy was doing it on a remote instance, logging in through his phone. Couldn't believe it. Instead of walking away, didn't bring his laptop, he tried to do it that way. It's pretty neat. You can do it in a container, you can do it in a source install. Everything inside this, I'm an ex-Red Hatter, so I like the Podman idea more so than the Docker path. But if you do Docker, you'll be able to understand what's going on. It's not that exciting. There's only a slight difference in commands. In a couple places, I give you the hints around what it is. Okay, we can go play with this a little bit. We have a little bit of time. I wanted to show you the project, the repository. So all this is online. If you go to chabelle.org, I posted it a couple hours ago. It gives you all the different links to it. They are now on, of course, the Percy's dev channel on the Cloud Native Computing Foundation stuff because they're in Sandbox. They moved over there. They're on social media on LinkedIn and X, I believe, as Percy's dev. So that's a little bit different than you're normally used to, .io. The workshops listed there is also in the thing there. There's the Prometheus workshop because maybe you're interested in actually putting a backend you can query your own data to. I put the link to the issue where they actually became a sandbox. That's kind of funny to go look at. Don't see a lot of that. And there's a recording of the talk we did in 2023. See if we can do some stuff. If you want to scan that, if you're going to KubeCon, that's our booth. You can come by and get some cool swag and stuff. Let's see what they'll let us do here. So first off, this is logged into the, see how good you guys can see this. Is that big enough? Yeah. So this is a demo, the demo one, demo.perseus.dev. You see over here they have a recently viewed. I actually imported my dashboard a while ago. They seem to have left it in there, but I'm no longer authorized to do anything with this. So if I go to edit it and try to add some panel, say we're going to do a bar chart, and stat. See what that does. See if we get anything out of that. Oh, there you go. So you see how it automatically fills it out. You can see what you got. You can put some names in it. Rejects. Bar chart. We can edit. So this gives you a chance to go play around with whatever you want. So if you look way down in the thing, you'll find the workshop thing in there. If you grab this, you can move it around. You can resize stuff. And also, for example, this is kind of ugly, right? So let's go over here and look at the settings and say, I don't like a spark line. Let's do a percentage. And my company colors are a little bit more that color. There you go. You can add a description. You get little hovering effects. Problem is when I try to save it, it's going to say, you're not authorized to do anything to this dashboard there in the corner, because I didn't create this dashboard. You'll see the exploring. There's a little bit of, and this is just delayed right now. See, this a little bit slow because of the, I think I see a question back there. Who's got the microphone?
Cheers, thank you. Can you show or describe how Perseus does dashboards as code compared to Grafana?
I don't have anything to show you up front. So basically you need a Grafana dashboard, and then you use a CLI. That is well documented, by the way, how to use it and to try it. You can run it through and see what comes out the other side. And to import this here, you would use a CLI to apply that file you get out of it, which gives you, if we go back to the, here, when you push it into whatever dashboard you create, what you will be pushing in looks like this. So once it comes through, so if you had a dashboard with just that one thing, you create a project, you push that to that project, it'll come out showing you just that one item with that code in it. So that's a good one for me to put into the, maybe I should take a couple of those dashboards and put them in the workshop, make a lab out of it, how to convert a couple of Grafana ones.
Thanks. Yeah, I think one of the big frustrations I have personally with Grafana is you end up with these just massive JSON files. Trying to like GitOps those, it's just painful, right? So maybe can you just describe, like from a Perseus perspective, what would be the benefits of the as code approach that Perseus is implementing? Because if you're using JSON as well, is it like heaps smaller, or how does it actually compare?
I have never looked at that, to be really honest. That's a good question. So you just give me two ideas to put into a new lab for the workshop. So I'm not only going to do the conversion, I'm going to look at the size when I get done. That's really good. Thank you. Don't run away. I want to talk to you afterwards, please, because I will forget it. I need to make a bookmark about that. Sorry, I can't answer it. I don't know. If you put that question in the dev channel, The Amadeus guys could probably give you real feedback on what it's like with huge sets of these things.
The table widget looks cool. Is it possible to add links in?
Sorry?
In that new table widget, is it possible to add links to like other dashboards the way you can with the Grafana table widget?
I don't know if in that specific widget, or in that specific type, but I have seen that.
Okay, so you can like create dashboard hierarchies and navigation.
Right here. See this here?
And then a follow-up question is: are there any features that have been heavily requested that, like, is there somewhere that someone who wants to contribute could get started? Are there any feature requests that need a developer, things like that?
There definitely is. I didn't go too much into the roadmap because it's pretty fluid, to be honest. And the roadmap is heavily driven by what people want to work on. I mean, it's truly at that phase where people are working on what they like. I know they want the documentation help. I try when I can, but I get sucked away a lot with my day job. So you can always do some stuff in there. It's hard to keep that stuff up to date. It's easy to find mistakes in there and fix that. What else are they working on right now? They just put up, because that's part of the CNCF process, is putting structure into this kind of thing. You have to have a roadmap. You have to have a contributing guide. You have to have this and that. They just put up a roadmap, so I'm not sure exactly what's on it to be fair.
Cool. Thanks.
But it is there, definitely.
Any more questions?
I got exactly 3 of these, so you can have one. Yours you get later. There's one more question. See how fast the questions come when you give shit away?
Yes, I was just curious about kind of the point of the project. Is it meant to be sort of a CNCF replacement for Grafana, or is it meant to be more of a base toolkit that you embed in your own things like you just show with OpenShift?
Okay, because this is a recorded talk, I'm going to be as diplomatic as possible. You don't want to rag on any one technology. I really don't. That's not how it works in open source. But they made some changes to the license, which resulted in people looking elsewhere because they have to. So look what happened with other technologies like the container initiative, standardizing so we can make container tooling and not be stuck with one. Kind of got to dance around it, but you get the idea, right?
Yep.
So that's exactly what's going on with this. Not the sole reason it happens. The standardization and noticing that there's no CNCF observability dashboard and visualization project kind of made it an idea to start splitting this stuff out.
Okay.
Anybody here watch Whitney's or see Whitney's YouTube/Lightboard talks and stuff where she does the stuff around? So we've been on that, and they've also done those choose your own technology, and they let several of them compete. This is an example of one of the things. You saw quite a few observability things go by. I think they had to do 3 separate episodes. And I'm like, everybody's talking about dashboard and visualizations on very specific levels of project or specific levels within that architecture we talk about in Cloud Native. But there's no big one front end thing. And that's kind of what this is trying to harness.
Okay, so the embedding stuff in OpenShift was just them leveraging that, but that's not necessarily like the point of the project.
No, for them it was.
Okay. Yeah.
I mean, that was the first tracing example we had, right? That's officially in the open. And Red Hat's very good about pushing it back upstream. Smaller companies like where I work is a little bit harder to do that all the time. You don't have the manpower to always. We usually do it I do it on my own time. You know, I like it. It's a hobby. So.
Yeah. Thank you.
You're welcome.
Okay, any more questions? We still have 2 minutes, so you can continue if you want.
Okay, so I can show you a little bit on the, so this one's all fun and games, but what's more fun is over here. Is it too small? It's kind of small, huh? There we go. So when you do the workshop, it looks like this. You have a dashboard, just like you just saw. It starts with this and you build from there, right? But what's more interesting is to create your own thing, and it's empty, and we go over here and see if this is visible. Whoops, this way. How's that? All right, so here's the example of, I built it from source, I'm running it from source locally. Could be a container, doesn't really matter. You have to have the command line tool of the same version of the instance you're running, which I have, and I'm logging in, right? Successfully logged in. And now what we want to do is I have here, let's push standardized chunk that's the complete workshop, finished, right? So I went through there when I updated last time and I was building my own thing to make sure all this stuff works. Pretty quick, pretty fast, pretty easy. And there you go. It all shows up in there. So one of the things about the workshop looks like this. I'll give you a little heads up on this. There's an init.sh file. I tried to do init.bat, by the way, for the Windows people out there. Any Windows people out there? Good. Because it's the best effort with no testing, so good luck with that, right? So always somebody comes along that wants to use it, so I always try. I always use it in here, but I'm like, hey, I try to help you, but you need to give me feedback, right? If it doesn't work, fix it, tell me what's wrong, and I'll fix it. The init.sh works. You do it with init.sh space source or space podman. Which path you want to go. Build it from source and install it and run it, or you want to do it in a container thing. So you can do it completely wrapped. You can look in the support directory. There's a functions file with all the things I do underwater to do that. It's very verbose in the console. Does a lot of background checks into the things you need, like what version to go and all this kind of stuff. Inside the support directory is well worth looking at. I've been doing these kind of workshops for a while, and one of the questions you always get is, well, I'm an architect. I just want to look at the shit. I don't want to build it, right? I don't want to do all the steps all the way across. So at the end of each one of these workshop versions and stuff, you'll find completely done files that are linked inside there. So each lab will start at a certain point and they'll say, hey, if you don't want to do this, just go here and do this command and you'll do just what I did. You'll fill up a dashboard with all the answers. So it's all done, you can just go browse it. So if you get really frustrated, you can look at all this stuff. Lab 5, 6, 7, that kind of stuff. And hopefully a new lab 8 with some Grafana migration stuff. I'm working on it, I'm working on it. All right? How's that sound? All right. Thank you. Thank you for coming.
Okay, thank you. And we will be at 4 p.m. with Marcus' talk about admission controllers. Thanks.
This guy right there.
Test, test. Okay. You do the.
No, I'm borrowing a laptop. Yeah. Joe's gonna get him, it's fine.
Okay. Okay, everyone. Let's head over for our next session. This time from Marcus, and he talks about from fragile to resilient, using admission policies to strengthen Kubernetes. Welcome, Marcus, and yeah, let's start.
Thank you. Hi, everybody. So, as Engin said, I'm Marcus Noble. For those of you that don't know me, I'm a platform engineer at Giant Swarm. I currently work on release engineering, CI/CD, and kind of core Kubernetes development stuff. So far, I've got, I think it's now about 7 years experience running Kubernetes in production environments. I started off my Kubernetes journey as an app developer. I was doing Node.js apps, and we were deploying it to Kubernetes clusters just within our team. So we had 3 clusters, dev, stage, and production. I then moved into a more DevOpsy role where I was managing those clusters for the team. Moved further into a more R&D role where I was building out tooling and best practices and things like that for an entire company, a global worldwide. And then more recently moved into more platform engineering and CI/CD and things like that all around Kubernetes. The reason I tell you this is because I've gone through a lot of the different pain points that a lot of users have with Kubernetes in different areas. So I've been on the app side of things. I've been on the ops side of things. I've had to deal with things going wrong and all this kind of stuff. So hopefully, what I say you'll take from that experience. If you want to get in touch with me anywhere, I'm on the Fediverse at marcus@k8.social. Or I'm on all the other social platforms. You can find all the links at marcusnoble.com. So let's crack on. Dynamic admission control. So validating admission webhooks and mutating admission webhooks. For those of you that may have seen me speak before, you may know that I've kind of got a bit of a love-hate relationship with webhooks within Kubernetes. Just so that we're all on the same page about what I'm talking about, these webhooks are generally used for 4 main areas that I see. So you'll often see them use a lot of defaulting logic. So this is where your mutating webhooks come into play. This is things like automatically injecting image pull secrets into all pods created within a particular namespace so that you don't need to give those credentials to your app developers, for example. You can handle that as a cluster admin. There's also policy enforcement. So this is where your validating admission policies, validating admission webhooks often come into play. So if you have a policy within your organization never to use mutable image tags, such as the latest tag, you always want to make sure that you're relying on a known tagged release. You can have a validating admission webhook that will prevent your teams from using that. You've then got best practices. So if you want to enforce the use of things like horizontal pod autoscalers or pod disruption budgets and things like that to make sure that your teams are deploying things in a way that's going to be resilient and not go down on Black Friday, for example, you could do that again with a combination of validating and mutating webhooks. And then my favorite area is this thing that I call problem mitigation. So who here remembers the Log4j issue from a while back that basically affected the entire internet, right? Everybody seemed to be panicking about this because it was such a widespread vulnerability that was in a lot of Java applications, the way to effectively turn off the code path that was vulnerable was setting an environment variable to a specific, I forget what it was exactly now, but you set a specific environment variable and it turns off that code path that was then exploitable. What we were able to do at Giant Swarm for all of our customers, all of the clusters that they were running, is use a mutating webhook that every time a new pod was created, it automatically injected that environment variable into all of the containers within that pod, which meant that without our customers doing any work, they were immediately safe from that vulnerability in all of the new pods that got created within all of their clusters. And all we had to do was deploy this one mutating webhook. Brilliant. And there's lots of examples of this that you can do. But while webhooks in Kubernetes are powerful things, there is some risk that comes with this power. Now, this is not that talk. I've actually given this talk last year at Rejekts in Chicago about all the ways that webhooks can go wrong and cause havoc, frustration, and pain for you as cluster admins in your clusters. If you want to see that, there's a link, there's a QR code for the link down at the bottom. You can find it on the Rejekts YouTube page. But what I actually want to talk about today, rather than these risks, is wouldn't it be great if we had a safer alternative? Yes, it would. And it turns out we do. So I'd like to introduce you to validating admission policies. Policies, not webhooks. So these were first introduced into Kubernetes in version 1.26 as an alpha. They went to beta in 1.28 and then became generally available and on by default in version 1.30. So if you're running an up-to-date version of Kubernetes, you can use these today, yesterday. They've been around for a little while now. What these are a declarative, in-process alternative to validating admission webhooks. And by that I mean declarative in that we define them as Kubernetes resources within our clusters. So there is a CRD that you create and define your logic. In process means that it runs within the API server itself. So you're not relying on deploying your own pods or external services. The API server handles all of this for you. So as long as the API server is running, your admission policies will work, which is not the case with webhooks. They use this thing called Common Expression Language, or CEL, which is what I'm going to be referring to as in this talk, and I'll come on to it shortly in more detail. And this is a policy language that allows you to write expressions for your policies to match against things. They consist of two main custom resources that you would use. There's a validating admission policy, which describes the actual logic of the policy itself. And then you've got a validating admission policy binding, which links that policy that you've created to the resources that you want to apply it to. So you need both of these for it to do anything, but it means that a single policy can have multiple bindings, and we'll come on to this very shortly. So before we get into that, I want to briefly go over what CEL is, because while it is now becoming more popular and including a lot more things, not everybody has come across it yet. It is an expression language. It's a very basic-ish programming language, let's say. And it's got a very similar syntax to a lot of C-based languages. So if you've done programming in any of the popular languages, you're probably quite familiar with the syntax. So here we've got like self.minReplicas is less than or equal to self.replicas, and self.replicas is less than or equal to self.maxReplicas. So that means that if our min is 1 and our max is 5, as long as replicas is within those two numbers, we're all good. That's what it's going to match on. CEL is designed to be run as an embedded language within other tooling, like within other applications, which makes it really good for this use case. And it's also going to focus on what I like to call one-liners. It's not to create like 100-line applications. It's really just simple expressions, and it gets very complicated very quickly if you are trying to do a lot. It does have a few small built-in functions, so it has things like split, has things like that. We'll see these a bit later on. But it also has the ability to have custom functions as well that you can define for your CEL implementation in your application. So Kubernetes does come with a few custom libraries. You can see these on the documentation. I'm not going to cover them in this talk. But there is a few like Kubernetes-specific ones that you can make use of. You may have already come across cell in other cloud-native tools. So Caverno, for example, uses it for some of its expressions. Tecton Triggers uses it to define some trigger filtering and expressions and stuff. And one of the things that I really like about it is it has this concept of a cost per operation, which actually can be calculated ahead of time before it even runs anything, which means that the API server, when running these cell expressions, knows whether it's going to affect the performance of your system or not. So it can prevent like lockups and infinite loops and things like that because it has this concept of a cost. There's a few references to more resources down on the left if you are interested and want to learn more. Right, let's crack on. So an example. In my example, I'm going to use one of the ones that I mentioned earlier about blocking the use of the latest tag. So we want to make sure that our developers are only ever using tagged versions of images. We never want them to use latest because, vulnerabilities can creep in that way. We want to avoid that as much as possible. We want to use V1s and all that kind of stuff. So here we've got a validating admission policy. This is the first of our resources. First, we need to give it a name. This is what we're going to reference in our binding later on. In this example, it is prevent latest image tag. I'm very imaginative with my names. Next, we've got a failure policy. There are two options you can have here. There is fail and ignore. Generally, you're only ever going to want this as fail, which is the default. Ignore is like if you want to then disable the policy temporarily, for example, where you're trying to debug what's going on or whatever. Excuse me. And then we've got some match constraints. So this is what the policy will actually apply against. In this example, we're using some resource rules that are going to say anything within the apps API group and is a resource of deployments, daemon sets, or stateful sets, if you can read that with the way that the screen is. Whenever the API call is a creation or an update, so a kubectl apply, a kubectl patch, whatever, against one of these resources, this policy will then apply. If it's not one of those, this policy gets ignored and is not relevant. We've then got a message. If we don't include, this is a human readable message. This will get shown to the user when they do a kubectl apply or whatever that fails the policy. This is optional, but I highly recommend that you put this, because if you don't put this, the error that the user gets is the cell expression, and it's not very human friendly, and it's just a big mess. And then we've got the actual expression. So this is what we're going to use to actually do our logic. Now, one thing that always catches me out, even though I've been doing this for a while now, is the expression is actually to match against what is allowed, not what you are trying to block. I always get it the wrong way around. So the expression has to match if it's a valid, allowed policy, not if it's the thing you're trying to block. So even though I've called this prevent latest image tag, what we're actually saying, what the policy actually is does not have image tag. You know what I mean? So let's have a look at what this is. So we've got this special property first called object. This is provided by the Kubernetes implementation of cell. An object here is will refer to whatever the resource is that we're applying the API against. So in our example, it's a deployment, a daemon set, or a stateful set, depending on what the API call the user made is. Now, one thing to keep in mind here is the spec of all of these, the deployments, daemon sets, and stateful sets, is pretty similar for the most part. Like they have a spec.template.spec.containers, and that's what we're going to work on. If these had very different schemas, this won't necessarily work because you won't be able to then easily write your cell expression that will match against both of them. You'll then want to have multiple policies. So in this example, we are doing spec.template.spec.containers, and then .all is one of these built-in functions that I mentioned earlier. So this then allows us to run an expression against all items within an array. So the containers property in the spec is an array of container objects, and then for each of the container objects, oh, I've gone too far. For each of the container objects, we're going to make sure that container.image, and again another function, ends with, it's kind of a bit cut off there, but latest, and it doesn't and that it does contain a colon. So what we're doing here is checking against whether the tag in the image is latest or whether it's not provided at all, which then implicitly infers to latest. And because we also then want to check on init containers, which are not a required field on the spec, we then have to use this has function, which checks first if init containers is defined on our spec. And then if it does, we run the same logic against the init containers as well. So if it's an optional field, make sure you have that guardrail in, otherwise your cell expression can fail for it not existing. Cool. So now we've wrote our policy, we've got to have our policy bindings. Without the binding, it does nothing. So again, I gave it a name. I matched the same thing. And then in my spec, I just need to reference the name of the actual policy that I defined earlier. Prevent latest image tag. And then we've got validation actions. Note here that this is an array of actions. The valid actions you can have here are deny, warn, or audit. The only reason this is an array is it's possible to supply both warn and audit at the same time. Supplying deny implicitly implies audit anyway. Deny is generally what you'll want here, but you may want to go for warn initially as you're transitioning to using the policy to see what the effect's going to be when you turn it on. Like if you put a policy in with warn and you get hundreds of things that are then going to get blocked, you may need to go and have a word with your app teams before you turn this on. And then match resources, this is where we will define what this binding will be applied against. So we can limit our policy against a specific namespace, for example. So in this, I only want to apply this policy against a namespace that has the label on it that is environment prod. So in this fictional cluster, we have namespaces for different environments. And in the prod environment is the only one that we really care about applying this policy. In the dev environments or whatever, they're fine to use latest. We'll allow that for now, but prod, we want to make sure it's safe. And that's what this will then apply to. All others will get ignored. So here's an example. On the left, I've got a deployment trying to deploy Nginx. Right down at the bottom, you can see I'm trying to use the latest tag. And when I try and apply this, I get this very nice human-readable error message that tells me the latest tag is not allowed, and it has blocked me applying that. And that's it. That was nice and easy. That was all done within the API server. Nothing can break in terms of a pod going down that would then prevent that. So let's look at some more advanced features. So that was pretty easy so far. We all up to speed? There's more context variables we can use. So we saw the object property in our example, which references the resource that the API call is against. We've also got the old object and request properties that we can use. So if your API call is an update of some kind, so a patch, a delete, whatever, old object will also be applied, so you can do a comparison between the two. So you can prevent certain changes happening that you don't want to allow. And then we've also got this request object. So this gives you more information about who and what is making the API call. So in this example I've got here, in my cluster, I trust the kubelet. And I want the kubelet to do whatever it wants. I trust it. So I've got an expression here that checks whether request.userinfo.groups contains system nodes. And this is what the kubelet gets in a standard setup. If that is true, do what it wants. Kubelet, I trust the kubelet. Next, we've got parameters. So as I said originally, we have two main CRDs, the policy and the binding. But it's also possible to use additional custom resources to define parameters. So if you want to create a policy that can be dynamically used in different ways, maybe in different namespaces, you can do that with parameters. So in this example, I'm defining here on the right in my policy a param kind, and I'm saying it's this rules.example API version, and the kind is replica limit. So this is a CRD that I've just made up. And the validation here is my object.spec.replica. So let's say this is a deployment, has to be less than or equal to my params.max replicas. So I am enforcing a minimum number of replicas that my deployments have to have. I've then got my policy binding, and as I said at the beginning, we can have multiple policy bindings per policy. So in this example, my policy binding is giving a reference to a parameter using this param_ref called my parameters in the default namespace, which you can see here on the right. And this just has max replicas .3. So when this policy binding is applied, params.max replicas would be 3. In a different namespace, for example, in my production namespace, I may want the minimum number of replicas to be 10. So I can have another params.yaml, another binding, using the same policy and have a different minimum that it then matches against. Now, I've also got variables, which are not to be confused with parameters. Variables are basically reusable cell expressions that can help simplify your validation expressions. As I said at the beginning, cell is really aimed at like one-liners. Once it gets long, it gets confusing. But you may want to reuse bits of cell a few times in your expression, perhaps. You can do that with variables. So a variable, you give it a name and you give it an expression. One thing to be aware of, the name has to be a cell-valid name, not a Kubernetes-valid name, which means you can't have hyphens in the name, but you can have camel case. Catches me out every time. So in this example, I am defining a variable called team label. And team label is an expression that will check check for the team key in object.spec.metadata.labels. And here we're using a ternary operator to check whether it exists first. And if it does, we'll grab the value of the team label. And if it doesn't exist, we're going to default to no team. And we can then use that in our validation to say, if variables.teamLabel, which equates to that, is equal to releng, that's when our policy will then apply against it. If it's a different team, doesn't apply. And then we can have like multiple of these however we need. You've also got audit annotations. So I mentioned earlier that one of the things you can have is to have it go into your audit. Here you can add basically extra metadata that shows up in your audit log when one of these fails. So you've got this audit annotation, and you give it a key and a value expression. So the key is just a name of whatever you want it to be, and then your value expression, again, is a cell expression that you can use, and that will then get applied into your audit event as an annotation. So here we've got, you see it actually gets prepended with the policy name, and then / the annotation, the key name that you gave it here, and it gives it the value of whatever that equates to. So in this example, deployment.spectral set to 128, which we don't want in this case. You can, again, multiple of those. Finally, message expressions. So we saw earlier, and I was pretty adamant that you should be using messages for your validation so that the people facing your error messages knows why it's gone wrong. Alternatively to message, you can use message expression, which allows you to then use a cell expression within that value to allow you to have more dynamic error messages shown back to the user. This is very useful if you're using parameters, for example, because it allows you to say, for example, object.spec.replicas must be no greater than whatever the value of params.max replicas is. So in our example earlier, that would be 3. In our hypothetical example, it could be 10, whatever. And that then at least gives your users the actionable information as to what they can fix to not get the error. Cool. How are we doing? So that's validation covered. What about mutating? So we got mutating webhooks are a big thing. We saw that fixes the log4j thing. Well, let me introduce you to KEP 3962, mutating emission policies. Fortunately, it's not merged in yet. It was aiming to go into Kubernetes a few versions ago, but there's been complications that have prevented it from getting in. It's still, at the moment, currently targeting 132 for alpha. Let's see whether that actually happens or not. I'm hoping, but there's been some issues because Cell's not really designed for this kind of thing. But it follows the idea at the moment is it follows the same idea as validating emission policies. Introduces 2 new resources, a mutating emission policy and a binding. And at least last I checked, supports 2 patch strategies, so apply configuration and JSON patch. Phase 1 of the planned release of this will only support adding and updating of values using this mutation. You will not be able to unset values in your resource. You can't remove a value that's applied. That may come in a later phase, but Cell doesn't have any capability of doing that in the language. And again, it's not yet finalized or available for testing unless you want to build from the branch that they're currently building this on. Let's have a look at a very quick example. It's very similar to what we've already seen. So again, we've got our match constraints. In this example, we're matching against the creation of new pods. And then we're going to define a mutation rather than a validation that we had earlier. The patch type is, as I said, one of these two. It's either apply configuration or JSON patch. Now, when we get to our mutation, this is where things go a little bit different. We've got this concept of a named type. So object here is a type. And in here, we've got, oops, sorry. In here, this is actually going to be pod, because that's what we're referring against. And we're going to say that we're going to apply on spec containers, object or spec containers, item. And for all of the environment variables, we're actually going to inject a new environment variable. So this example here, we want to automatically inject a HTTP proxy environment variable into all pods within our cluster because we're using a lockdown cluster or whatever that we don't want to have direct access to the internet, but we don't want to have all our app teams manually add this environment variable. Let's do it automatically on creation. And this will then inject that environment variable into every single container that gets created in every single pod. And again, we've then got a binding that actually makes it do something. There's no validation actions because it's not a validation, it's a mutation. And we've got no resource stakes. We want it to apply to everything within our cluster. Cool, so what is beyond that? Now, what's coming next is more hypothetical and my wish list for what's coming in the future. But what I would like to see is generative policy. So this is the ability to create new resources based on API actions. So for example, being able to create maybe a config map based on a certain CRD being created or something like that. The ability to do resource lookups for existing resources within your cluster. This is not currently possible with Cell, mainly because of the cost implication of doing another API call within the API server. You can end up with like a locking mechanism. A deadlock. Policy exceptions is not a thing yet. So there's no way for a particular application to have an exception to a particular policy for whatever reason, which is quite a common use case for a lot of the webhooks. And then more abstraction. So I know Kyverno are already working on implementing this, but I imagine more and more tooling, as this becomes more implemented, will also build on top of the validating emission policies rather than webhooks because they're safer in terms of what impact they have on a cluster. So in summary, it's time to start replacing those risky webhooks with in-process policies, if possible. Validating emission policies are available to use now, so I highly recommend you try them out. Keep an eye on that KEP that I mentioned about mutating admission policies. Again, I'm hoping 132. Let's see. I'm keeping an eye on it. And then hopefully in the future, we'll have like more abstractions, more generative, more fancy stuff. Thank you very much. If you have any feedback, please let me know. The link for these slides are there. And I believe I've got time for questions.
Yes, of course. Thank you, Marcus.
Cool. Thank you very much.
Any questions?
I can't see a thing. So.
Hello, how you doing, Marcus? Thank you very much for that session. Just a couple of questions I was jotting down as I went through. And full disclosure, I designed and worked on Gatekeeper, if you've ever used that. So, so a lot of that informed some of this work. Great. So does that mean I'm going to get hit?
we use Kyverno. I'll just preface it.
No, that's okay. We love Kyverno too. We work with them closely. So, rising tide lifts all ships. A couple of things on the parameters. Can you have? I noticed you had just a string. Can you have arrays and lists and other types? Let's say instead of latest, you wanted 1.32, 1.31, 1.30. Can you pass an array in for max replicas, or is it just one value?
I'd have to look it up.
Okay, that's okay.
I don't know off the top of my head.
No, that's okay. And this isn't a quiz because I don't know either. Because I think, what I usually see is with, latest, you'd actually have a fixed number of labels that you're okay with, or shars or something like that. I'll take a look at that too. The other thing is on the match conditions. I noticed you had workload APIs, deployment, stateful sets. Now, if you're applying a policy at that level, should you not apply it at pods as well? Because if a user goes to create pods, like, what's your best practices there?
Good question. So that's going back to
one of the very early slides.
For example, so In this example, I'm applying it to deployment statement sets and stateful sets. The reason my example has this is because they all have spec.template.spec.containers, whereas
It's
pod,
nested, only has spec dot.
exactly. So
Spec
that
dot
won't
containers.
work.
Won't work, yeah.
Pods, I'd have to have another policy.
So what do you typically do at that level? Do you block pod creation apart from controllers? Because you know how you were granting, the workload APIs. I've always wondered, how do you grant them, like the kubelet example you had, dedicated access to create these things, but not the person using kube control? Because presumably you have that system locked down.
So generally, try and avoid applying things to the kube system namespace, for example. That's, have RBAC and stuff apply security around that, and then let your actual users use everything else. So you can have that as kind of a special exception case. But this is where I'd like to see policy exceptions coming in the future to be able to do exactly what you're saying. So you could say, yes, this very trusted controller has to have these permissions. I want to also apply a policy exception that would allow that. I think that's going to come in the future, but we're not there yet. I think Gatekeeper's got exceptions, right? Yes, yeah. No, yeah, I think it's going to come. At the moment, you've just kind of got to work around it a little bit, yeah. Thank you very much. Good. Do you want to get set up?
I could just start setting up.
One more question.
Yeah, I'm listening. I'm just doing this.
Marcus, okay. So this is very Kubernetes-centric. What if you have non-Kubernetes workloads and workload environments, let's say like ECS? Can we adapt the model to those kinds of environments as well? Or can we extend to those environments? And I'm asking because I have a specific use case for this.
So the way this is implemented into API server, as in the code. You could theoretically have the same code in whatever you're using to do, you said ECS, right? To do whatever ECS, but somebody would have to build that and make it support these policies, I guess. But theoretically, it's totally possible, right? Because this all does run in process, gives you a lot of ability to do things. Yeah. Because it's not centric. You wouldn't have to build a control. Exactly, yeah. Cool.
Then, thank you, Marcus.
You're good. Is that working for you all right? Yeah, just do continue and then close out.
Continue. This is for this clicker here? Yeah. All right, here we go. And do I just click it?
I think just click back and I think it should just pick it up.
Yeah, hey, what's up, Marino? How are you?
Good, how are you?
Yeah, I don't know.
Just try it now.
There you go. Maybe if this is like this and I can get through stuff. All right. Awesome. Let's go. Sorry for the UK friends that I just flipped off. Yeah, thank you, Marino. Hey. All right. We're going to stay on schedule, I guess, so I'll make sure to get through things quite quickly since I'm starting a little behind. Lee Kapili. Yep.
I'll plug into that.
Yeah. This is the presenting device. And then have to put this on here. We'll keep this here. And here we are. Yeah, all right.
Thank you so much.
Am I going to mess up your recording if I unplug this and I unplug my phone in?
I just don't want it to be purple.
Okay.
Unless you don't care.
Yeah, no worries. Oh, I see what you're saying.
Let's try this other.
Yeah, you can flip it to a different dongle.
Actually, let's leave that one in. You got 2 ports. Let's see what happens.
Cool.
That way you still have a clicker if you want.
Oh, yeah.
Maybe. Let's see what happens. There we go.
Oh, yeah. That looks way better. Cool.
Yeah, feel free to.
All right. Am I live to go, my friend? I'm good to go. All right. Hi, friends. So I'm going to try a few things here. I'm expecting something to go wrong. You know how it goes, right? Yeah, so many friendly faces in the room. I'm so glad to be here at Rejekts in 2024. I think there's a camera somewhere here for all of the folks who watch the recording. My name's Lee. If I haven't met you before, I'd love to meet you. Last name Kapili. I used to work on a bunch of Kubernetes stuff and also continuous delivery with a project called Flux, which does continuous delivery with GitOps on Kubernetes. And I don't know how this happened, but now I work on something completely unrelated at a company, a startup, with 20 other brilliant people. The startup is called Flux with an O. Why did I do that? Yeah, we work on software environments and that kind of thing. The reason that I wanted to work with the folks at Flux is there were some things in this tech stack that were just really appealing to me as an engineer. And I think you can imagine, working in advocacy at VMware, it was kind of maybe harder for me to work on the product because maybe some of the code base is even a little bit private. And I'm like, wow, when I get on my next team, I want to make sure I can do what I did with Flux, which is actually advocate for the thing that I'm engineering on. And we write stuff in Rust, and we build a usability layer on top of Nix. So what is Nix about? Nix is about this problem in a lot of ways. Nix is a lot of things. It's a Linux distribution. It is an academic paper. It's a functional programming language. It is a Linux distribution, but it's also a Darwin macOS distribution. How does that happen? You can do Nix stuff on BSD or anything that's POSIX compliant. I mentioned that it's for functional programming nerds, and you can also use it to manage your home directory. So Nix is this thing that lets you do lots of stuff, and you can hold it whatever way you want. And my clicker is working. Software, when we want to build it, we build it on top of lots of stuff, right? So we have tools, libraries, frameworks, and configuration. Slides brought to you by the amazing Ross Turk, who's sitting up there in the top of the bleachers. And we have like fun little shapes and colors here. I love our brand. When you have multiple projects, right? So you've got the tools, libraries, frameworks, config. All of your projects have different mixtures of that kind of stuff. And this is maybe nothing that we really think about too much, but I think it's, even if you're a beginner engineer, right, you start to intuitively build up this knowledge of separating these different categories of code and configuration and the things that you are depending on. And sharing these environments is really a pain in the butt, right? I mean, like this problem of like trying to just have a little bit of playtime building something fun with your friend, which is pretty much the best case scenario for software development. I think a lot of times we find ourselves as software engineers in building something that we don't want to build because we need to make money. But in this scenario, we just are trying to have a good time, and making the squares and circles match up so that we can build our software together is already a hard problem. And then recreating the past is even harder, right? Because we do this thing with also the future, with the system package manager, where we put all of our configuration and our code and our libraries in the file system standard that has become popular on Linuxy, Unixy types of systems, right? We're gonna put binaries over here. We're gonna then like have the Unix system resources, which everyone just says it's user now, so there's the user bin. And then like we're gonna include some stuff and put some libraries in a place, and we're gonna then put these folders into a path lookup inside of an environment variable that then like a bunch of programming languages are going to write things to then look inside of the path, and it's going to be colon separated, and we're going to traverse the directories, and we're going to look for the thing that wins, and this is how stuff works now. So I mentioned Nix. Nix has a different philosophy about how to package all of the squares and circles. So with Nix, when we want to put source code into a place, we hash it, and then we get that special hash, and we put it into the file path. And that source code has a unique path in the Nix store. And then we're going to take the same thing, configuration, and we're going to take libraries, and then we are going to separate them into individual pieces. And then all of the things that you need to then run a library, they don't actually fit into this single path. They end up being built in a way where the library, if it also depends on other libraries and other configuration, it is built, we do a bunch of replacery and binary magic to take what is normal, right? We load libraries typically from this library path. We teach the binaries that we build inside of a Nix store instead to look for the things that they need exactly, the things that they were built against, that they depend on. And so when you have a Nix store, this thing can actually then be pointing to this thing, and this thing can be pointing to 5 other things. And you get a fully capable dependency graph right on the file system, because the binaries, they don't know how to behave any different. They were built specifically that way. And so Nix lets you weave your code together dynamically so that you can have all of these things in the Nix store, and then the code gets exactly the bits that they need. And that is magic. It's more than just a package manager. Nix is twice as old as Kubernetes, with a contributor base of about 7,500 people. There is the largest package ecosystem in the world. I'll just show you now, because we really don't have that much time to talk about the basics anymore. I'm going to just spend most of the time fumbling around on the keyboard. Are we cool with that? Can we do some demos? I'm good with it. All right. So I'm going to put this out of the way, and we're going to try, we'll just put it on the floor. We don't need that right now. Okay. So we'll swipe over one of these directions. How many times am I going to fight with my window manager today? That is work stuff. Here we go. Oh, the aspect ratio of everything has changed. Cool. So this is our website. You can go check us out if we want. We make a usable layer on top of Nix, which I'll do plenty of demos of today. But this is Nix packages. This is the most bonkers Git repository I've ever looked at. It's NixOS/Nix packages. Hopefully it's pretty legible for people. That's a graph of contributions since January 1st, 2004. And it is 2024, and there are people making lots of commits every week. And if you go over to the code, let's just ignore the fact that there's uncountable numbers of issues that are open and pull requests. That's 706,000 commits. This is where the 120,000 packages come from. And thank you to all of the Nix contributors who have done the magic of packaging everything. I'm going to jump into why we care. So the point of today's presentation is to contextualize why a cloud native person with the luxury of the container image and the container runtime would care about packaging software in a way where your software only knows how to find what it's supposed to get to. Because if we can build our software in a way where we got it to work and we got it to pass tests, and we can wrap it up into a little box and push it around into a registry, then why would I care, right? I can use some very imperative tools, and as long as I can get to a working artifact, then I'm just gonna store those bits forever, and we'll be able to run it on some functions as a service thing, in some Kubernetes cluster, and maybe even in Docker desktop, right? So all of my needs are met. Why would I need to package software in this way? Why do I need to change my habits? Well, for one, I happen to be using a MacBook. And MacBooks have really cool kernels that do have isolation features. The Darwin kernel in particular is the same kernel that's used on an iPhone. I don't have one of those, but a lot of people do. And the Darwin kernel has isolation features, but it cannot currently run OCI containers in the way that you want to. There's actually a Darwin containers project, really cool. I think that we could maybe use Darwin containers in the future to do some Floxy and Nixy things. But it's not really something that people do. So in order to use all of the software that we want to package as cloud native people, we end up using things like Docker or Podman or nerdctl or something, and we get access to a daemon that is actually running a Linux computer, right? Here's the thing about almost all of the software that's packaged in modern day Nix packages. Most of those 120,000 packages are actually cross-built on a public build farm and then cached in a binary cache that's hosted on like a 1.5 petabyte S3 instance. All of that software is available natively for my Mac, which I like, because then maybe I don't have to run a virtual machine as often. So I'm just going to show you a Flux environment. Can we read that? How much bigger? Like, how's this, Orlin? That's better? Yeah. Thank you. Good advice on the aspect ratio change there. So I have a Flux environment. This is basically just making it easy to list what software I'm using from the Nix packages ecosystem. So again, Flux is this open source project that we're building to just make it easy for me to demo how to use Nix. But I'll show you some pieces here. So I'm listing things in my home directory. These are the packages that I want to have installed on my system right now for this use case. And you'll see, I've got like ZSH pinned here, as well as like my favorite text editor for terminal stuff, and a version of Go and curl and core utils, and my favorite way to cat out stuff. And this got here because you can say we want to do like some more like infrastructure as code stuff generally. I don't normally install this to my home environment, but you could like do this. And we just install our packages to, I guess I have to pull a new version of Terraform right now. And I don't really know how long I want to wait around for this, because we're already at like 16 minutes into the time block. But what I'm doing right now is I'm installing to my computer the way that you would normally use a package manager. The way that we sort of want to think about changing our workflow though is, like, I use my computer as a workbench for building lots of different kinds of software. And eventually I get to a place where I want to start a project, and I want to then install some dependencies to that project. I'm just going to open another terminal here while this is doing that thing. So say that I also go into some project directory. I wonder how many times I'm going to need to increase that. Let's actually go, and I'm just going to increase the font size here really quick. Oh, wow, I'm already at 17. Let's try 24. Maybe that's better. Yeah, OK, we can read that, right? OK, perfect. So let's make a directory. We'll call it just like rejects 2. And by the way, I guess Terraform is actually failing to build right now. That's incredibly surprising to me. Cool. Sorry? Yeah, thank you. Let's just OK, cool. So I'm making a folder here. What if I like initialize a project, right? And then I can like install Go, and then maybe like a text editor, and then also like something to do some Kubernetes stuff, and then maybe I also want kubectl. Let's go ahead and just like install a couple packages here. And what we're doing here is I initialized a project. So instead of thinking about installing stuff to my computer, I do what normal software engineers do, but instead of with like packages inside of Go, I'm installing system stuff to a folder. And then if I go into that folder, you'll see a directory structure. Here I have a manifest and I have a lock file. Oh, lock file, right? Because it's like you installed things, and those things, they have versions, and I actually probably would never want these versions to change when I want to share the thing with my friend. So it's good to have a machine-readable lock file. Right? You can see that it's good for a bunch of different systems here. And then this derivation, which is the fancy Nix word for the thing that we built. At one time, it has either an input or a content addressable hash for this particular version of the Go programming language. This is how it was resolved and where I got it from and what time it was resolved and what thing was, did I actually ask for a pinned version or is it just pinned out of convenience and that sort of thing. And ultimately, what we want is to then look at, like, say, the runtime directory and everything in here, my configuration in Etsy, my and like my binaries, they all point, they're symlinked to things in my Nix store. So I actually started a lot of different projects inside of this Mac. And if I just like list my Nix store, you'll see that there's lots of different kinds of software that ends up in here. Who knows why I have docbook XML, but something I was working on needed that dependency at this specific hash in this version. You'll notice that everything here is 55 years old. That's because every package that was ever cached inside of the Hydra build system, it's a bunch of shared infrastructure for the public project, rebuilds the universe iteratively, and when we build those packages, we would like to make sure that the package gets all of its inputs from the network in a very isolated way, and that all of the builds actually happen in a mountain network namespace that has internet access disabled. And then we also pin the system clock so that the build, the output of the build is bit for bit reproducible. That means that when we decide that we want to build like Go from Nix packages, we can trust that the recipe will produce the same bits every time, which means that we can put it into a binary cache. It's starting to sound a lot like with the either like hashing the inputs or hashing the content, and then caching this individual node of the dependency graph. It sounds a lot like an OCI registry. Now, here's something that looks a little bit less like an OCI registry. I've maybe worked on, I don't know, let's just look at my like home env directory. This is usually where a junk like ends up for me. There's 44 directories in there. So I've like worked on 44 different kinds of things, and that's because I live in the fresh hell that is developer advocacy. I guess if I ask like Flox envs, this like outputs like every environment on my system. So I guess I could count those, and it's like roughly 72 or so. Only 72 different types of things. But if I list the Nix store and I count what's in there, it happens to be like 51,000 dependencies. Well, you're not going to end up with 51,000 container layers when you work on 74 Docker images, right? None of them will relate to each other because every time you change a file, every layer afterwards becomes invalidated, and that's because container layers are based off of file systems, which are trees. And anytime you invalidate a piece of a tree, everything afterwards that is overlaying on top of it depends on that particular layer. And so the difference here with the Nix store is we can be much, much more granular. Many of these derivations inside of the Nix store, out of these 51,000 things, are actually even just single files. Sometimes they're just shell scripts. And so they don't depend necessarily, or they don't invalidate anything that they're linked with. Right? If I want setup sh for a particular part of a dependency tree, I can get the 5 things that are related to that, and I can use them across a bunch of different things. And it gives me a much greater resolution dependency caching. So that's why you would maybe want to start rethinking about reshaping the container image. Now, I have a couple of other things that might be interesting here for you. So I'm going to start switching machines, right? Let's go ahead and just go back to that rejects to environment. I'm going to Colima SSH here. Colima is a virtual machine on Mac project. Thank you, Akihiro Suda-san. Prolific contributor in the containerd space. Colima does this thing where it read-write mounts your user directory from your Mac. And so I happen to now be on a Linux system still with that Phlox environment. And what'll be really fun is that you can just activate it. Right? So I've just gone from Mac to Linux, and using the power of the Nix daemon, resolving against Nix packages and stuff, I have the specific version of Go, the Co command line tool, kubectl, and micro, all at those versions using the lox file resolved, but now instead of getting Darwin binaries, using the same hash, the same package name, I am working on a Linux virtual machine. You say, well, Lee, if you're working on a Linux virtual machine, why wouldn't you just use a container? This is where like maybe something, I don't know, this might be kind of silly. Can I just like, it would be this one. And then like, maybe you could do this. And then I think it says I'm connected to an external display. And I wonder if the AV crew is like maybe despising me right now. But, so then maybe I will like try to find the camera. And then I will just be like, you know. I'm not going to bother with pulling up the same exact environment, but this is Nix on Droid. It is a single user mode Nix installation running inside of an APK-driven Android app. Android is a Linux kernel running containers essentially for every single one of the apps. You are completely unprivileged. The user ID is like 10,500. And I'm using Phlox and a single user mode Nix install, and you can access all of the same exact software. So Terraform, whatever. I'm going to just pop back up here and go into the Rejekts 1 environment. This has Go, Grafana, Prometheus node exporter. In order for me to actually use these things, I need to Phlox activate. I'm going to use this short flag. Sorry. Thank you. I was like, it's not presenting. I'm back on the Mac. Cool, that should probably, there we go, yeah. And there's a bunch of services here. So, you know, if I like go over here, then I guess node exporter is running, and then Prometheus and Grafana were unhappy for some reason, right? But you can like actually use the Prometheus binary natively here. I guess it probably is complaining that I need to like touch a Prometheus YAML, and then it'll probably start. Yeah, so you know, we're running Prometheus here. I'm just gonna exit that. The last thing I want to show you in the remaining 3 minutes here is I'm gonna pop open into a proof of concept environment where let's actually just look at the code. We're going to need to increase the font size significantly, but not that much. Let's get a bunch of these notifications out of the way. And in here, I have this thing called Nix Host Manager. It is a daemon set that runs on every node of your Kubernetes cluster. It runs this minimal, oh gosh, what did I just do? It runs a minimal container image that has Nix inside of it. We're just getting a couple things and then holding the container open so you can shell in and run Nix commands. And then we're doing a volume mount from host data / Nix directly from the host. And then the build runner in a different namespace uses this privileged container. We could probably use a capabilities list here. And then we mount some folders from some volumes at the bottom here, create an overlay empty vol as well as a Nix in container mount. We're going to basically make an overlay data dir here and then use a privileged mount manager container to get host data Nix and then overlay FS into the Nix in container mount. So that's what this little script does right here. And then in the user build container, you can then cache hit on the host Nix store, which is read-only, but then overlaid inside of the pod so that you have a little layer on top. And that will let you start to get the packages from whatever you want. You could then install Flux on there and then run Prometheus or your Go application or some vector database or whatever you like. There are two more things in the Kubernetes infrastructure world that I also want to point you to. Lin Yin Feng is a contributor who has written this ORAN-C. It's called OCI Registry as Nix Cache. So I mentioned earlier that we had that like 1.5 petabyte S3. Thank you to Amazon for the credits for hosting that for the community. You get to say thank you, Amazon. All right, how many times do you get to say that? OCI Registry as Nix Cache would allow us to basically use an OCI repository as a Nix store that is addressable by a daemon. And that's pretty cool because then now we have a place in our Kubernetes infrastructure to push binary builds to. If you want to build something with Nix or you want to just move some blobs around so that you can cross an air gap or that kind of thing, OCI Registry is perfect for that with like lots of authorization and signature use cases. Thank you, Engin. And then similarly, now that there's a Nix cache that's co-located with the network, your daemon set can just go and super efficiently substitute all of the stuff from the Nix store directly into the hosts. But here we're sort of really abusing the node abstraction, and we're using privilege to then create a bunch of dynamic overlay mounts. There's also like a variation of this. You can see there's this Kate's overlay directory where it's even more complicated. There's a specific feature in Nix that we can talk about later that makes it so that the read-only overlay store underneath all of the containers can be dynamically mutated even as like long builds are running on top of them. And that's because there's a SQLite database that gets overwritten on the file system that you have to manage. But beyond this, it's like if we ran OCI registries as a Nix cache, like with this project, which you can get started with. It's fully Nixified, and they also have binary builds and even like a public instance. PDT Partners, another great contributor in the Nix space, has written this thing called Nix Snapshotter. And this is a direct integration with Containerd's Snapshotter plugins ecosystem. It is called a remote snapshotter. It's similar in a way to what like Steve-O and Akihiro and some of the folks from Google wrote with eStarGZ, as well as Soki Snapshotter, the ability to stream container images. But instead of streaming container images from S3 or Google Cloud Buckets or something like that, what we do is we construct layers directly from a Nix store, such as an OCI registry or a local directory on a node file system that's managed by Nix Host Manager. And then instead of constructing the container with an overlay mount file system, you could also, for all of the store paths, because they never conflict, they will never step on top of each other because of the hashing. They all are supposed to live flat in the Nix store, just like images, or just like layers. Then we can actually just use bind mounts. And I don't know if you know this, but there is a limit to the number of container, the number of layers that you can use in a container, right? Like if I Kalima SSH, and then I like say go into, I don't know, a Go environment or something like that, and I Flux containerize this environment. This is gonna take a sec, and then how can we quicken this up? I can also Docker history the GHCR IO /Flux/Flux image. So this is a container that is built with Nix. You'll notice that there are a lot of layers here. There's about 100. I know that because we are stopping 20 layers short or so of the 128 layer limit. And then the very last layer, we just shove a bunch of different Nix store paths. But the goal here was to actually give every single one of the Nix store paths a unique layer, right? And that's because you cannot create an overlay 2 mount with more than 127 args or so. And that's where the layer limit comes from. But since the Nix store paths are guaranteed to not conflict with each other, if we could either update the OCI standard or use some non-standard extensions with containerd through something like Nix snapshotter, then instead of constructing an overlay2 file system to create the container, we can just bind mount a bunch of stuff in. And then you can actually then use another 128 layers to construct an overlay file system to live next to your Nix store. And that, it could be, it's already something that functions. I mean, if you use Nix snapshotter, you can create OCI manifests that it will understand, and you can use Nix natively. But I see a future here where we could build some incredibly comprehensive standards that make the build graph so much cleaner, so much more granular, which such a greater cache hit ratio. Like the implications on the infrastructure are massive. Now, in order for that future to exist, we have to make Nix a little bit more usable than, here's our flake for actually building flocks. Lovely functional programming stuff. Don't you want to learn how to do this? It's great. The stack traces are even better. But we can make Nix as usable as brew, as usable as Git. And that is the function of our open source project. It's what we're working on. I'm happy to chat more into it. There's so many ways that Nix can touch all of the things that we are working on, whether you're in a WSL2 environment, on a corporate Windows laptop, on your MacBook, trying to enjoy an Apple Silicon chip with a shared memory architecture, or if you're just on your phone and want to play with Nix inside of an Android container. We can get to a story where the developer experience on the left factors our dependencies cleanly and automatically from the beginning, such that we can move them into production with a low layer diff and have a better time, just not pretending that our CVE scanners are actually lying to us. So, not trying to throw shade. We could do better. So, thanks everyone. This is Cloud Native Nix in the context of why you should care as a containers person. And my name's Lee. Feel free to find me and chat about it. So.
Do we have a question? I think one question we can take. Anybody? A question? Otherwise, yeah. Thanks again, Lee. And. Okay. Okay, you give the call. Okay, everybody, next talk. I'm really interested into this talk because tomorrow I'm talking at WasmConf also about WebAssembly and SpinCube. So Danilo and Joe going to talk about virtual machine container and WebAssembly in some kind of face-off. So I'm really interested in this. So welcome.
Hey, everyone.
That was a little bit more enthusiastic.
Woo! Very nice. Testing the mic. Is the mic working? Yes. All right. Good afternoon, everyone. Before we begin, quick poll. Who remembers the first time you tried explaining Kubernetes to someone outside of tech? Yes. And maybe you got isn't this just the shipping container thing? Well, today we are going deeper into the magic world, virtualization, that powers Kubernetes to run virtual machines, containers, and even WebAssembly. Virtualization has come a long way from the days when we thought running multiple operating systems in one physical machine was magic. Today, we are going to explore this evolution from virtual machines to containers, all the way to WebAssembly, the new kid on the block. We'll see how this technology stack up in terms of resource utilization, portability, speed, and security. By the end, you will not only get to know how each one works, but have some ideas on where they shine. And we'll have a cool demo about Hyperlight, which is a library to create micro virtual machines really fast. No, ultra fast. And who knows, you might even pick up a few pointers for those next family explanations. My name's Joe, and I'm a software engineer at Microsoft Azure, and I am a proud maintainer of the CNCF Containerd Run WASI project. I'm also a maintainer of SpinCube and a recognized contributor to the Bytecode Alliance. And I co-organized the Systems and Programming Language Virtual Meetup, or SPLUM. And much of the content I will be presenting today is what I learned from attending this meetup. And you can reach out to all the socials I posted here. And here I have my co-presenter, Dan.
Yeah, hey everyone. I work in the same team with Joe at Microsoft Azure, working on open source. In particular, I'm a core maintainer of Hyperlight, the project that Joe just introduced about creating those micro VMs ultra fast. I'm also the author of Manning's server-side WebAssembly, a book that's currently in early preview. More on that later. And I'm also a big Star Trek fan, so if you have any Trekkies in the audience and you want to talk about non-tech later on, hit me up. And you can hit me up also in any of those socials there. And we have those at the end, too, if you want to take pictures.
All right. To understand where we are today, let's go back to where it all began. Virtualization is a technique to simulate physical hardware. And in the 1970s, virtualization advanced with the development of the so-called first-generation hypervisor, or virtual machine monitor, by IBM. So essentially, hypervisor has total control over the hardware it runs on, enabling it to manage and share hardware resources across multiple OSs. In 1973, Jared Popek and Robert Goldberg formally proposed 3 core principles for a hypervisor, and those are fidelity, safety, and performance. Fidelity says that any application runs on the hypervisor should behave like they are running on the physical machine. Safety says that the hypervisor should have the total control of the hardware instead of virtual machines. And the performance states that hypervisor should have a minimum overhead. They encapsulate these requirements with a famous criterion. For any conventional third-generation computer, a virtual machine monitor or hypervisor may be constructed if the set of sensitive instructions is a subset of the set of privileged instructions. And there we have many terms. So sensitive instructions basically refer to those instructions that modify the hardware. And privileged instruction refers to the instruction that will trap from the user mode into the kernel mode. So how is hypervisor being implemented? The answer lies in a technique called trap and emulate. In this approach, the hypervisor manages different types of instructions from the operating system. For non-privileged instructions, it basically allowed them to execute natively, naturally, introducing almost no overhead. For privileged instructions, however, the hypervisor will step in and trap them. And when these instructions are executed, the hypervisor emulates their execution, providing an illusion to the operating system that it's control of the physical hardware. So doing so, this ensures that even though multiple operating systems are running across the same hardware, but each believes it has exclusive access. Moving forward, in the 1990s, the personal computing dominates the market, and so the x86 ISA, or instruction set architecture, become dominant. x86 introduced the concept of protection ring, and basically ring 0 is the most privileged, and ring 3 is the least privileged. So application run on ring 3, while kernel runs on ring 0. However, virtualizing x86 is not easy, and it poses some challenges. And part of the reason is because some of the sensitive instructions are not privileged. Take the instruction popf as an example. It behaves differently in user mode versus in kernel mode. In kernel mode, it actually pops up the top of the stack and saves into the register. So it actually modified the hardware. But in the user mode, it doesn't. So in the user mode, it doesn't trap. And that's a problem, because if the hypervisor runs on ring 0 and virtual machine runs on ring 1, application runs on ring 3, that means this sensitive instruction that does modify the hardware does not trap to the hypervisor. And that means the hypervisor does not emulate this instruction. So this will cause security issues. And the first commercial company that tries to solve this problem is VMware. They introduced a groundbreaking technique called binary translation. Binary translation basically converts from one ISA to another. And in this case, it converts x86 and all of those sensitive instructions to a different set of instructions that does trap into the hypervisor. And so their commercial product called VMware Workstation fully virtualized x86, and that's why they have a huge market success. Around 2000, early 2000, like 2005, 2006, hardware companies like Intel and AMD introduced their own extensions to fully virtualize x86. And those are called VTX and AMDV. These extensions transform x86 virtualization by providing dedicated hardware support. And here's how it works. The CPU introduced new privilege level, and sometimes it's called VMX root. And in VMX root, the hypervisor runs in ring 0, and host application runs on ring 3. And there is a VMX non-root mode where the virtual machine and application run ring 0 and ring 3. So by extending the rings, and we also call it ring -1, we can run hypervisor in a more privileged mode so that it can trap those sensitive instructions, so that we can implement trap and emulate. Now I want to shift the focus to a totally different virtualization technique called containers. In the 2010s, container emerged as a totally different technology that fundamentally changed how applications are developed, deployed, and managed. In this era was driven by the popularity of the public cloud. The cloud demands have evolved with a focus on more consolidation, more density, and ease of software deployment and portability. And they think virtual machines are too heavyweight for their application usages. Recognizing the cloud demand for lighter, more portable, and resource-efficient solutions, they looked into 3 kernel features from Linux: namespaces, C groups, and capabilities. And they basically combined these 3 features into a new name called Linux Container. So it was in 2008. So namespaces provide a view for each container or process to have its own view of the entire hardware. It has PIDs, file systems, and network. Control groups allow the host to define resource boundary for each container. And for additional security, Linux capability restrict the power of the root user within containers. So those privileged containers do not have full root access to the host systems. Later, tools like Docker built on this technology to create a container ecosystem that powers today's cloud-native infrastructure. And Docker really revolutionized to try to solve this problem of when you have 10 services on one side and 10 platforms on the other side, and how am I going to manage those combinations of services and platforms? And Docker came in and said, we have a standardized package format and a standardized operations. So with Linux container providing a lightweight, efficient solution, the cloud now has two main options for virtualization: virtual machines and containers. While both technology offer isolation and resource sharing, they do so in very different ways. Virtual machines require full operating systems, while container only share the operating system kernels. And virtual machines offer strong isolation, but containers, because they share the same kernels, they share the kernel vulnerabilities, so they have a bigger attack surface. And now, with that said, I want to shift to a totally different virtualization technique called WebAssembly, and then I will hand it off to Dan.
All right, so understanding where we came from with VMs and containers, let's tackle the new kid on the block, WebAssembly. And I think a fair first question here, what is WebAssembly? And I always like to correlate it back to what we do know, like x86, 64, architectures that we're familiar with, R64, because in the same way that you can compile your code to these architectures, like x86, 64, you can compile your code to WebAssembly. So maybe that's our answer. WebAssembly is a compiler target. Awesome. But we can drive that comparison a little bit further. So say for x86, 64, R64, you can walk into a store and be like, hey, I want a computer running on this chip, on the x86, 64 architecture. But if you try to do that for Wasm, be like, hey, I want a Wasm computer, you're probably going to get weird looks. So you cannot do that. And that is because WebAssembly abstracts over this hardware. So x86, 64, R64, whatever. So it is, aside from a compiler target, a hardware abstraction layer, or HAL. And it is a HAL built with a couple core principles in mind. First one is for it to be fast. And by fast here, we mean sort of predictable, near-native performance. We want it to be safe, meaning it was designed to run within a sandbox environment. Initially, when WebAssembly came out, it was designed sort of for the browser. So in that scenario, we wanted to run within the V8 engine securely. But right now, running it on the server side, that can be just a standalone Wasm engine. Some people might be familiar with, like Wasm Time, say Wasm Edge, whatever. Also wanted to be hardware independent. I mean, that's a given one, right? A hardware abstraction layer. And this is sort of building in the sort of giants like Java, Java bytecode, the write once, run anywhere idea. Although, differently from Java, we wanted WebAssembly to be language independent. And so Java bytecode, you compile Java or sort of similar languages like Kotlin and so on. Meanwhile, WebAssembly, right now, I think we have 40 plus languages that compile to it. So sort of a bigger scale there. But that's not all. That's sort of WebAssembly in 2017. WebAssembly today is quite a bit more. And that's due to the introduction of something called WebAssembly components. So perhaps a better question is, what is WebAssembly today, right? What are these WebAssembly components? So to clarify, this back in 2017, WebAssembly was introduced with 4 basic types. And these were 2 integer types and 2 float types. And if you wanted anything higher level, you had to build atop of these types, also leveraging the linear memory. Meanwhile, WebAssembly today with Wasm components, out of the box, you have access to higher level types. And that's through a canonical API that establishes how to lift and lower from those types through code generation. And what that gives you is that it gives you true language independence and agnosticity. So say in this example, we have a machine learning library written in Python, say your app written in JavaScript. you can build those two into WebAssembly binaries and then compose those together into a single WebAssembly binary. So you can have those two interact seamlessly, like different languages with different memory managements through, say, function calls. So now we understand VMs, we understand containers, we understand WebAssembly. When do we use each one of these technologies? How do they differ? And this is the real meat and potatoes of this talk. This we'll be comparing them in a couple categories. And by the way, huge credit to Alex Crichton here. A bunch of these slides were based on content that he has put out, one of the core maintainers of Wasm time. So yeah, just wanted to shout that out. Thank you, Alex, if you're watching. And anyway, so back to it. The categories that we will be comparing are 1, security, 2, speed, 3, resources required, 4, cold start. So that's another facet of security, or not security, speed, portability, and cross-guest communication. If all of those are unclear, I'll clarify them in a little bit. Okay, so starting off with security. On one side of the ring, we have VMs and containers, battle tested for years and years, and you can trust the isolation that they provide. On the other side, you have WebAssembly, which is a formally proven sound language, and we even have some sandboxes that are mathematically verified to be safe. So at least from our standpoint, we think that those two compare quite a bit. It just depends, WebAssembly being the new kid on the block, you're sort of right to be skeptical, but we'll call it a draw. And that is until you introduce humans, sort of like human error. Because, WebAssembly engines, even though there are some that are mathematically proven to be safe, in reality, production engines, they're not going to be bug-free, right? So you can still have errors that could lead to exploits in the same way that with VMs and containers, even though they're hardened by all the years that they have, you can still have exploits due to the complexity of hypervisors that Joe introduced. And by the way, I just want to give a shameless plug to my talk from WasmCon of last year called Sandboxing Your Sandbox, Leveraging Hypervisors for WebAssembly Security. In there, I talk about sort of security and layers to account for that human error that we have on how you can use sort of all of these technologies together. Okay, next up, speed. Speed is where sort of VMs and containers have a huge leg up. And that's because you have a full OS and you're running at sort of unrestricted access there with multiple processes, and you're running at native speed. Meanwhile, WebAssembly, that was never a goal. You want to run at near native speed, which usually means about 20% overhead. Next up, resources required. So we had a draw, we had a win, but resources required is one where WebAssembly really shines. And that's because, again, VMs, containers, they're big, right? So you have a full OS, and you are in the scale of gigabytes. So say you have a service with like 10 VMs, you could probably replace that if you, say, transition to WebAssembly with 10,000 instances of WebAssembly, which of course is a little bit of an unfair comparison because with VMs you have, like, again, a full OS, while WebAssembly you're dealing more at like the level of an executable. But still, if that's a trade-off that you can consider, that's something to keep in mind. Now, cold start. Again, sort of like speed. However, in this one, WebAssembly comes out on top. And that, again, another reason, maybe you call it a feature of VMs, because they are so big, there's a lot to set up. There's a lot to spin up, processes and so forth. Meanwhile, with WebAssembly, it was designed for the browser, and it was designed with streaming compilation in mind. And what that means is that, so say a scenario, you're visiting a web page, that web page pulls in a Wasm module. We wanted, or design and spec, design in WebAssembly, for it to be able to be downloaded or compiled quicker than it is downloaded. So as soon as you finish downloading, you're able to hit the ground running and have it executing. Next up, portability. This WebAssembly comes out on top, and that's because it is architecture independent, while VMs and containers, they're per architecture. So with containers, you might be stuck having to create multi-arch images, while with WebAssembly, that's just a non-issue. Next up, cross-guest communication. So what I'm talking about here, to clarify, is how does container A talk to container B? And with containers and VMs, that's usually, you rely on things like Kubernetes, sidecars, serializing protobufs. While with WebAssembly, with the introduction of WebAssembly components, we have a great story here. And that's because if you remember that example that I had in the beginning with the Python and JavaScript, you compile those two, you get them in a single executable, and then communication between those two sort of like microservices almost, they behave like inter-process communication. So those are essentially function calls at the end. So, and compare that to, say, VMs and containers where you have like a network stack, right, two microservices interacting. You don't have that overhead of serialization, like JSON or anything network related with WebAssembly. Okay, time for our Hyperlight demo. And here we want to sort of try and bring it all together, using the best of VMs and containers and WebAssembly all together. And I'll stop, I guess, speaking in a little while, but just a quick 101 on Hyperlight. Again, it is a library that lets you leverage hypervisors to create these OS-less, so no OS, micro VMs very quickly. And we're talking very quickly, sort of spans of like 1 to 2 milliseconds to run untrusted code safely. Very quick intro, but if you're interested to learn more, this is a blog post that we put out literally 3 days ago on Hyperlight, as was our announcement coming open source. So if you want to learn more, see some examples, that's a great place to look at. Okay, so in this demo, we'll be looking at two main applications. The first one is demo guest, and hopefully you can read it. But the first one, that's a demo guest, and that's an x86 64 unknown none native Hyperlight guest. So that's essentially the malicious code that we're trying to execute, sort of simulate it, right? And that will be running inside of demo main. That is an HTTP server that's leveraging Hyperlight's SDK, so to create those micro VMs. Oh, and by the way, the demo guest, this is running a native binary, but we can also run WebAssembly. I won't be displaying that here in this demo, but if you want to learn more about it, feel free to reach out to me after this talk, and I'll tell you more about it. Okay, so demo guest, I told you Hyperlight executes arbitrary code safely, quickly. And we do that by spinning up a micro VM that has no OS that executes functions. So we're at that function granular level. So demo guest in particular exports two functions, or we call them guest functions. And the functions are print output, which as you can probably guess, print to standard output, and dereference raw no pointer. And this is to sort of simulate something that someone might be trying to do that's malicious to sort of crash your process. Oh, something else I want to point out here is that print output, we're running in OS-less VMs, so you don't have syscalls. And to do something like printing to standard output, you escape the VM to do something that we call a host function call, so those sort of similar to syscalls. So you exit the VM, make that host function call, you return then to the VM, and then yield. And then demo main looks somewhat like this. We have two parent routes. One is Hyperlight. The other one is no VM. In the Hyperlight and the no VM, we have two mirrored routes. That's the hello world. In Hyperlight, the hello world route will be calling that print output guest function. And the no VM one, it will just be doing essentially the same thing that the host function in the Hyperlight example would do. So essentially a print line statement. For the Hyperlight one, we have two options. We have a warm endpoint and we have a cold endpoint. Cold will spin up a new micro VM on every request, and warm will pull from a pool of pre-instantiated sandboxes. And then safety, deref raw no pointer, that's just an endpoint to call that other guest function. And VM count is another endpoint to check the number of live VMs that we have. And I wanted to add that in particularly because the deref raw no pointer will execute in a warm Hyperlight VM. So say if it did crash and something went wrong, malicious, right? That VM will no longer be alive, but we can check if it's alive with the VM count. Okay, demo time. Right here, I'll try and mirror my display. All right, perfect. So on the side there, you can see that we have demo main running, and I have a couple of pre-instantiated sandboxes. And you can see that we're listening at that port 3030. And then here, I have a couple of requests that we'll make to see it in action. So we'll start off with sort of like a tame one, just a no VM route, just a hello world. And all this does is it makes a print line, hello world, I'm not executing inside of a VM on the server side. And in here, we get just an output saying function called outside Hyperlight VM. Not too exciting, but now we can have it in Hyperlight. And this is the cold example, by the way. So we get guest function called inside a cold Hyperlight VM. And on the server side, or our demo main side, we have now a green message with a smiley face saying that we're executing inside of a VM. For completion, I can show you the warm example as well. And I mean, visually, they're indistinguishable, but we'll look at some benchmarks later so we can compare the two. I showed you that we had a couple of sandboxes pre-instantiated. So we can check the VM count. And you see we had 10 VMs pre-instantiated. That's what that warm one is pulling from. Now that we saw the VM count, let's check out that deref raw null pointer call. You see we get some error logs. And in here we see unexpected VM exit, unexpected KVM shutdown. Probably improve the error message a little bit for this example. But the idea there is that now if we call that VM count again, we're still at 10 VMs. And this is because in between each of those guest function calls, we're resetting memory. And so they're isolated. And it all works fine still, even with something that could potentially crash the process. Now, let's try running some benchmarks. And here, hopefully you can see, but I'm running Hey. This will just do some benchmarking. We'll run like 200 requests, and it will monitor the time that it takes for the response time there. So running that, and I'm running the cold one first. See a bunch of print lines. And here, we see that we got an average response time of around 100 microseconds. So what is this, right? What we're doing there is we're calling the cold endpoint. We're creating a new sandbox. After creating the new sandbox, we're calling print output. Print output will then call into the host. So we'll do a VM exit. Then we'll do the print line. We'll then, after the print line, we'll yield back to the guest. The guest will then just return, yield back to the host, and that's the completed operation, and that took 100 milliseconds. Now let's try the warm one. Let's see how that looks like in comparison. Now I ran the warm one, and we can see the histogram looks a little bit weird, and we got about 55 milliseconds response time. But let's just check out our VM count. If we do that, we see that we're at 48 VMs. So not all of those requests were really warm, because you had to create a couple of VMs, so we have no resource contention. Let's try running warm again. Now we see we get more of a normal distribution, and we're running at an average 12 millisecond response time to do all that. Cool, now let's hit our program with some real payload, 1,000 requests with a concurrency of 5, and we're running that cold endpoint. Now with a bigger sample size, we'll see we're running the cold endpoint, so creating all those VMs and executing that function call with multiple VM exits in 13 milliseconds, which now you can guess warm will look even better. And if you run warm, we called into a VM in 1.4 milliseconds. Now just for fun, we can compare it to our original hello world that has no VM, just a normal function call. And what that looks like is 1.9 milliseconds. So we managed to call into a VM and do that all quicker than we did with a normal function call. Obviously, there's some variability here, but pretty cool. OK, so we're at 5-minute mark. I want to transition back in here to show you the key takeaways. Joe mentioned those family dinners, people asking, what do you work with? So if you want to talk to them about this talk, you can give them these key takeaways. And the key takeaways that we want to highlight is 1, WebAssembly, born as a compiler target that is a hardware abstraction layer. Wasm today, with the WebAssembly components that I introduced, standardizes the communication between components in a way that resembles that inter-process communication, right? Those function calls without a network stack or serialization. And now if you want to decide, maybe your project, do I use VMs, containers, do I use WebAssembly? That's the bullet point that you want to look at, the third bullet point. VMs and containers are awesome when you want something that has been sort of battle tested, for years, and you want to be confident and maybe tell your boss like, hey, this is good, and that provides you native speeds. Meanwhile, WebAssembly is awesome when you don't want cold starts, you want that fast cross-guest communication, again, those function calls, great portability, and resource efficiency. A couple of applications there that you can think of, maybe serverless, edge, IoT. Those are places where WebAssembly really shines. And then finally, we finish off with the Hyperlight demo. And I showed you how you sort of can create those micro VMs in 1 to 2 milliseconds to run your untrusted code safely. Now, I want to just do a final shameless plug. and that is to my book, Server-Side WebAssembly. We're currently in early preview, and I was given, Manning gave me a QR code to give out in this talk with 45% off with that code. So if anyone is interested and wants to take a picture and check out the book, maybe you like my introduction to WebAssembly, this is the time to do so.
I mean, you could bring it for everybody for free.
I mean, it is still currently an ebook, and there's 4 chapters out, so I can't give it out. But I will get 25 copies free potentially next year. So, you know, maybe next Native Rejekts, I'll be here with a couple of book copies. Okay, so now finally, to finish off, I want to ask if we have any questions, and if you want to check out on our socials, those are the links back again. Thank you.
Any questions? Okay. I go first up.
So just so in a Kubernetes world, how does this really look like? Do you just build your application? You put in a registry? How does all that work as well?
So what specifically are you referring to? Hyperlight? How does it work in the Kubernetes world? WebAssembly?
Yeah, well, all of it, really.
Okay, so WebAssembly, do you want to take the WebAssembly one? You're more involved with CI work?
Yeah, so you specifically ask her about like registry. And tomorrow, WasmCon, there is a talk about like how do you package Wasm as an OCI package. So the short answer to that is now Wasm components can be packaged as OCI artifact. And you can use the similar way how you deploy your containers, upload them to registry, the same way you do to the Wasm components as OCI artifacts. And with projects like Run WASI, you can directly pull from the OCI registry and get a component down, unpack them to your local file system, and orchestrate with Kubernetes. So everything here will work with the existing systems.
And as for Hyperlight, you can use it as a normal library, so you can embed it into your application and just sort of deploy like you would with a normal container to run those micro VMs. And I have a couple of other demos that will probably be displaying around the weekend in KubeCon, so if you want to catch me, I have it like running Flatcar and those things. Maybe we can spin up some orchestration there.
I'm also shameless plugging now. Tomorrow at WasmCon, I have also a talk about SpinCube, and this gives you also the glue for Wasm and Kubernetes. Very interesting. Okay, pass to you.
Actually, what's interesting, though, the way you describe deploying or using Wasm to deploy on Kubernetes, it's essentially replacing containers. I don't think many people say that. Actually, the question I wanted to ask was, do you agree with that? I wanted to see if you agreed. And the second question I wanted to ask was, when you're running Azure now, it's already, for serverless, it's already using Wasm a lot. You don't care really as a user. That's my take. So can you describe, is that true? I mean, to what extent now is Azure using WebAssembly underneath the hood, so to speak?
Yeah, so to your first question, do I agree Wasm is going to replace containers? Well, there are people saying, Wasm is becoming the third wave of compute. The first wave being virtual machines, the second wave being containers, and the third wave being Wasm. And I think the implication here is Wasm is going to be an extension to even greater areas, like applications like Azure, edge computes, IoT devices. Those are the use cases where Wasm really shines. And in traditional long process workloads, virtual machines and containers shine over there. So they have trade-offs. But I do think Wasm is becoming an alternative to containers, just like containers are being alternative to virtual machines. But they are not going to replace the prior technology. And to your second question, is Azure running Wasm right now? Well, Dan can talk about his work on the Hyperlight, but there is an Azure AKS WASI node pool and cluster, and you can install that extension, and that will give you a cluster with built-in, the spin sham, and that will execute Wasm workloads in AKS.
Yeah, on the Hyperlight side of things, I think last year's Microsoft Ignite presentation, Mark Rusinovich gave a talk introducing Hyperlight and mentioned how, Microsoft as a public cloud, we cannot just run Wasm raw. And one alternative to that is running it within the hypervisor isolation that Hyperlight gives you. So, running Wasm within Hyperlight, and we definitely have a couple of, I guess, services that are going to be based on that. Yeah.
Can you just help me understand the positioning of Hyperlight in relation to something like Kata containers and gvisor and that sort of thing?
Yeah, so it's a little bit different. A lot of people often compare it with Firecracker, but they're different really in the sense that Hyperlight is meant to be used as something embeddable. So say you have your application, you wanna say write a plugin, right, to run untrusted code. You can then leverage Hyperlight within your own application to spin up that OS-less micro VM. So that's one side of thing. The other aspect is really, I guess, the application of it as is right now, because we are OS-less. And so whatever syscalls you want to have, whatever higher functionality you want to have, you most probably will have to define those as host function calls. So you're a little bit more restricted on what you can do for the exchange of that performance and that we saw.
Cool, thanks.
Yeah.
Okay, then thanks again, and yeah, last talk for today.
Yeah, thanks for having us.
Good job.
Good stuff, Jeff.
Okay, folks, the last talk for today, and it's an interesting one. So it's platform engineering loves security. Shift down your platform and not shift left. I keep talking about shift left with everybody, so that's interesting. I also want to learn now about shift down. And I welcome Maxime and Mathieu.
And thank you to be here for this last talk of the day. Today we will talk together about platform engineering loves security, shift down to your platform, not left to your developer. I'm very proud to be here, and I'm here also with my friend and co-speaker Mathieu.
Hi everyone, I'm Mathieu Benoit working for Humanitech, and I'm also a Cloud Native ambassador. I'm very glad to be here today.
Cool. A quick disclaimer before to start this talk, any view or opinion expressed in this talk are only my opinion and not necessarily the opinion of my employer, its ownership, management, or employee. Okay, cool. Now let's deep dive in the agenda for today. We will have three main topics. The first one, we will talk together about the real security complexity in the cloud-native world. In addition of that, Mathieu will talk with you about what's platform engineering and all the aspects related to that. And finally, we will conclude this presentation with a series of actionable best practice to shift down and not to shift left. If you have any question, do not hesitate to interrupt us and ask your question. Security in the cloud-native world. Currently, it's a big topic, but let me start from the beginning. I think it's important to start from the beginning and understand a security governance framework. You know, when a large company or large enterprise want to release a new cloud pattern, as security guys, we need to follow a series of steps. In this case, we have 6 main pillars. The first one, we will start with a security review. What is a security review? A security review, it's a technical document where we will highlight all the different security capability of one cloud services. For example, if we have an Azure storage account, maybe we want to enforce encryption, and we will enforce encryption with a CM key. That is a type of security configuration we will highlight in the document. In addition of that, we will also highlight all the different threats and all the different security control we need to create to be sure our services is secure and compliant. And when that is done, we will do that for all the different cloud services of the pattern we want to release. We will move to the threat model. What is a threat model? In reality, in this case, it's a combination of of the mapping of the different link between the different cloud services, and we will try to identify which threat we have. And at the end, what we want to be sure is we want to be sure if we have the right security control in place to protect us. And after that, when the pattern is deployed in non-production, we will do a security assessment to be sure all the security controls are in place, and we are good with that. Fourth step, we will do a pen test, because sometimes it's great to have an external opinion, and sometimes that helps to find misconfiguration. And after that, we will do a scorecard. If you are not familiar with a scorecard, what is it? In this case, it's a risk assessment document that will help us to have a good idea about the security posture of our pattern. And the scorecard is fed by the different output from the security review, the threat model, and the cloud control validation. And at the end, the scorecard will create a risk score, and this risk score will be shared with the cloud governance board. In large organizations, the cloud governance board, sometimes you have the chief architect, you have the chief security officer, and you have also the different business teams. And the risk score will be shared, and in function of the risk appetite of the organization, they will take the action to move this application in production or not. That was to explain you what is a security governance framework to release a cloud pattern. As you have already seen, that is complex, that is also painful and very long if you don't have any automation. But now let me jump on the CNCF landscape for security and compliance. What I would like to also highlight with this slide with you is the number of different products to resolve a security problem. Sometimes it's also very challenging to find which product I need to choose, because sometimes we have some overlap of security capabilities, and that is a real challenge for the security team. But now let me deep dive. In this case, we are lucky because the CNCF releases a 4C security model. That is a model in four pillars, from code to cloud. That will help you to split your architecture and try to identify which security control and which threat you need to mitigate in four different layers. Just to highlight you the complexity, because today we are talking about Kubernetes. That is an extract of the OWASP top 10 with the different Kubernetes security challenge. As you can see on my screen here, we have a lot of challenge, and a lot of challenge are related to identity management, because that is not something easy to do in Kubernetes. We have also some challenge related to misconfiguration and how we can fix that. To give you another idea about the different threats we have, we are lucky because Microsoft helped us and release a MITRE attack framework in this case, and that is only to give you an idea about the different threat for a Kubernetes platform. Now, I believe you understand the complexity, you understand the different security issue we can have, specifically if we don't have any automation in place. That's the reason why my coworker Matthew will help you to understand what is platform engineering and how the platform engineering can help you to resolve a security challenge.
Thank you, Max. So what we want to define is what's platform engineering, right? And platform engineering is not a new thing. It's very taking advantage and learnings from the past, right? So if you remember the sysadmin world where maybe we got the wall between the app developer and maybe the sysadmin deploying the package, we got this wall between the two persona, if we could say. DevOps came and said, no, we need to break and tear down the walls and make sure there is like maybe a seamless collaboration. DevOps came, and that's where developers were kind of doing the app development perspective, but as well was doing some infrastructure, maybe Kubernetes things, and maybe security things, right? So that's where we got this misunderstanding, misconception, if I could say, about the culture of DevOps. And that's where platform engineering is coming by saying, yeah, cool. Let's take the best of the two worlds and make sure now we have best practice seamless collaboration and automation around what we want at the end of the day, a better developer experience. How my developers in my company could ship code in production with quality, being compliant and secure, without dealing with all what Max was explaining, right? So platform engineering is very shifting down to the platform instead of shifting left too much on the cognitive load for the developer. And here it's coming from different perspectives. Yeah, as a developer, I want to ship faster. How I could drive automation if I'm more on the ops perspective in my company. Architects, I want more standardization, automation. For the CIO perspective, I want to accelerate the time to market, right? Deliver faster and better product for the end user to make more money at the end of the day. CISO, how I could be compliant, how I could enforce all what was discussed earlier. And why not having some cost saving, et cetera, et cetera. So let's focus on two main personas, the developer and the platform engineer. And again, the developer is here to develop product application without dealing with complexity of infrastructure. And let's say Kubernetes, maybe in our case. On the other hand, platform engineering is here to abstract and standardize as much as possible. But they are not alone, right? They are getting the help. They are now becoming the glue and the bridge between all the other very important key stakeholders, right? SRE, ops, cloud engineer, and security engineer as well. So at the end of the day, what we want is on the left side, as a developer, I want to focus on my inner loop. I want to focus on my code locally, maybe debugging my application. I want to code, right? And I want to commit in my Git repo and having some trigger of CI/CD, doing some continuous integration, and maybe deployment in ephemeral environment or graduating into a deployment pipeline. Then we will have this platform engineer layer, if I could say, where we could have layers to abstract, right, all of that, and not having developer doing Kubernetes and Terraform, for example. Why? Because this layer in the middle is what will be able to abstract, standardize, and automate all these best practice in the cloud provider, in Terraform, management of database, et cetera, observability, injecting, right? So that's the end goal of platform engineering. Cool. Now let's talk about 6 actionable best practice to shift down and not shift left.
Yes, exactly, because a lot of people think in this case compliance can kill innovation, and security team can be, you know, a blocker for the business and a blocker for the different platform team. But now we will focus on 3 persona, you know, from the security engineer to the platform engineer to the developer. You know, that is an architecture extracted from the platform engineering CNCF document, and we will use that as reference. Okay, now if we start with the security engineer, I believe in this case it's important to understand the goal and the responsibility of the security engineer in a platform engineering world. The first thing is a standardized configuration, because as security people, what we don't want to have is drift. We want to prevent drift. And for that, we need to enforce standardization and configuration, specifically if we have regulation and if we need to be compliant with regulation like PCI DSS, for example, if you manage credit card, or IPA if you are in the healthcare industry. And after that, the second pillar will be scaling security best practice. Because yes, it's great to enforce security measure when you have 10 clusters, but at the end, when you have 1,000, 5,000, or 10,000 clusters, it's another story. Reducing the attack surface. Yes, that is because also you want to limit your external surface, and you want to protect your infrastructure. Versatility and preventing privileged grip. The last one is not the least, because from what we can see from the market, a lot of attacks are coming from identity when the identity are compromised, and that is very important to understand that. My first tip and my first recommendation, maybe you are already aware, maybe you are doing that, is scan everywhere, is scan everything. Start from the infrastructure as code, and after that, start to scan your code source. You can leverage tools like Checkov, Kix. Lot of open source tools can help you, and you will be surprised about the different misconfiguration you will find. That could be some network security group misconfigure, or maybe you have some hard-coded token or secret in your code source. I'm sure you have that, and you don't want to say that. After that, another important topic is to scan your container image, because as we have already said before, we want to reduce the attack surface in this case, and to reduce the attack surface, we need to have a small container and also updated container. And after that, compliance control. Compliance control is something I will recommend you to start from day one, because it's very, very important to, specifically if you need to follow regulation, to be onboarded with the compliance at your architecture design level. And for that, you can enforce open policy agent, Kyverno policy. That is only a few examples. And runtime security monitoring, because it's great to have hardened Kubernetes cluster, but in reality, if you don't monitor the different behavior of your pod, of what happened inside your cluster, you will have a big lack of visibility. And if your cluster is compromised, maybe you don't know that. My second tip is related to shift down preventing misconfiguration with security control for regulated organization. This one is because lot of organizations when they start to enforce security control, they start with detective control, and after that they start to enforce preventive control. When they start to enforce preventive control, they will have more friction and more friction by the different team. And at the end, they put auto remediation, because when a control fail, when you have a misconfiguration detected, you want to have a logic to automatically patch that. But that will not resolve the issue for the developer, because when the developer will create this code and will try to push the code, it will be blocked at the first gate. In this case, what we want to do is we want to give early feedback to the developer, and for that, it's possible, for example, if you are leveraging OPA policy, to run the OPA policy locally, and to have check also directly in your commit, and provide an early feedback to the developer. And that will reduce the friction, and that also will help your developer to deliver secure code faster.
Now let's move to the platform engineer role, right? It was more on the security engineer role. Here it's a zoom on this architecture diagram from the CNCF platform white paper. And here they are talking, I love that, about platform capabilities. As platform engineer, how I could expose interfaces and capabilities of my platform, right, to my developer. So I really love this approach because it's very here where you will think about designing and developing stuff on top of Kubernetes, but how you will simplify the life of the developer, right? Which feature do you want to provide, and how you will provide. So The tip number 3 is about CI/CD. There is a huge opportunity for a platform engineer to just take best practices and try to automate, standardize CI/CD pipeline, right? Here we are taking an extract of another white paper from CNCF, the security white paper, where they focus on distribution, right? How I could do continuous integration. And if you look at all the layers, are we asking the developer to do that? Maybe, but at the end of the day, you shouldn't, right? Because after that, there is this CI and now the CD part, how I distribute, how I deploy, right? So what I want to cover here is at each layer, as platform engineer, you could ask you how I could, again, shift down to maybe template of my CI/CD pipeline or to the platform I'm using, and not asking my developer to have that and coding that, right? So for example, a lot of talks were about security today. I'm very glad about that. And for example, how I could decrease the CVE fatigue, having some distro-less container base, right, with chain guard. How I could also simplify the writing of Docker files. I don't know if some of you are using build packs, but that could be a good opportunity to not having a Docker files, because writing a Docker files could be complex, right? There is some security hardening already here. Are we asking a backend and front-end developer to write a Docker file? Maybe you will have template. Maybe you will have some documentation, and maybe some automation. Another part could be what Max mentioned, is about failing fast as soon as possible. Again, you could use Docker Compose, for example, or you could use Minikube or Kind, and instead of waiting hours or days to deploy actually the brand new application or version of the container, you could run that in CI pipeline, right? Why not just failing fast? Hey, your container is not running. Fail fast, fix, and we will move forward after that, right? So all these checkpoints are very important and are very easy to automate. Are we asking the developer to do that? Maybe not, right? Scanning the container and the packages, Trivi and from Aqua and other tools out there. What I love is what Max mentioned. I don't know if you're familiar with Gator, a CLI for OPA Gatekeeper, or Kyverno CLI. You are not, it's not mandatory to wait for the admission controller in Kubernetes to say that, let's say, the Kubernetes manifest are not compliant. You could run that in your CI pipeline, right? If you have the render manifest, you could use the CLI to see the enforcement with the policies that you want in your cluster. But you are not waiting the admission controller to tell you. You could fix that and actually enforce this kind of policy earlier. Another one could be signing. If you know Notary, if you know Sigstore, you could sign the provenance of your container, packages as well. And then you will move to the stack and having more automation around CD, continuous deployment. One of the, there is multiple tools out there, GitHub Action, GitLab, Jenkins, and other. You could also use some GitOps tool out there, Argo CD, Flux CD, in order to deploy your container and your manifest. Here you will have how I guarantee the provenance of my container, and why not my artifact here, again, with Sigstore and Notary. On the other hand, I will have also the enforcement of the policies actually in my Kubernetes cluster. And here, for example, I could use also mutating webhook to inject, for example, the label of PSS, Pod Security Standard, enforcement in my namespace, having a restricted security context, right? And why not injecting network policy with Cilium network policy or Calico, and having some injection of MTLS communication between workloads and authorization, right? All of that shouldn't be something your developer should deal with, right? That's why the platform engineer could inject at any layers complexity and a very important security feature. Tip number 4 is about another opportunity you have as a platform engineer. I don't know if you have seen this talk from Daniel Bryant, taking this Gartner diagram where there is 3 layers. At the top, application choreography. At the bottom, infrastructure. In the middle, that's the missing pieces on top of Kubernetes. If you look at Joe, Kelsey, and others in the industry, they said that Kubernetes is the platform to build platforms, right? And that's the opportunity here. What about using some orchestrator on top of that to facilitate the coordination, the deployment between application and infrastructure. If you know Crossplane, you could deal with composition and the provider. If you know Cratix, the promises and the workflow. If you know Radius, you could use recipes to bind all of that. And on a more commercial aspect, Humanitech, resource definition, and driver, all of them will be able to orchestrate both application and infrastructure. On a developer standpoint, I will go faster here. We want to abstract as much as possible. So as an end user, developer of my platform, here I'm using score file in order to describe how I want to and what I want to deploy for my container to be running in a platform, right? Here I'm using, I'm just describing how to do that. I know that I will have a DNS to expose my, my workload, and I want a Redis Dapper state store. I don't know if you're familiar with Dapper, but here you have an opportunity to have your developer not writing Kubernetes manifest. If you leverage Dapper, they don't know the infrastructure. They could use an interface to abstract the infrastructure. And let's say you don't want to write Docker files. You have an opportunity also to abstract this part. On a abstraction layer, a portal is very important. That's the interface and the front end of your platform, where you will be able to centralize documentation, scaffolding, onboarding template, as well as a centralized way to manage where are my workload and project running, what are the status of them, et cetera, et cetera. So that's pretty much the wrap. We went through the different layers from the CNCF security white paper here. Very complex, but we have seen also that the goal is to have a more velocity for the developer, more stability on the platform engineering and the other stakeholder associated to that with the platform. But also you need to remind that you need to have a product mindset in order to have this contract and interfaces between your developer and the platform. Again, the developer are very focused on innovation and creativity instead of dealing with all what we presented, right? There is this maturity model from the CNCF platform working group, which is showing you where you could be at and how you could improve, maybe, and some tips how to improve and becoming more mature with your platform. Again, what we really enjoy is having Kubernetes upstream, showing such security shifting down to Kubernetes, where you could see now validating admission policy built in Kubernetes. You have also the gateway API, where you have a segmentation, let's say, a collaboration between all the stakeholders we mentioned, security, platform. And we could see that network policy are coming upstream more and more to collaborate more between admin and security and platform engineer. So that's very a shift down from Kubernetes itself, which is good. We have a lot of references here. You could scan this QR code. That's the link of this PDF version. Yeah. Thank you for being here in this last talk of the day. Thank you for being here.
Any question?
Any questions?
Yes, yes.
Thanks. This was great. Just, you know, a lot of great ideas here. I work at an organization where we have a Kubernetes platform. Our tenants range from I just have an app and I want to deploy it to I'm bringing my own CI/CD pipeline, I'm bringing my own container templates, I'm bringing my own stuff. I just want a bare API, get out of the way. And we find ourselves often in the middle of, you know, how opinionated should we be in order to save developers from themselves while still giving them the flexibility to be able to innovate and produce products. Out of all these ideas, what do you think, you know, what's your kind of top idea of like, this really should be part of the platform. This shouldn't be left up to the developers. This really should be something that is, you know, is decided on from a security perspective just to save us from ourselves, basically.
Yeah. I think it could be a long answer. I could take
exactly.
It could be a long answer, but I mean, we provided some very quick win, and pod security standard is one of the most easiest tips you could have. You just enable restricted on the namespace, any container non-compliant, privilege mode, running as root, and having write access on system file could be a good deal with, hey, it's broken, fix it, right? So you will learn a lot, and all of that, it's not day zero. You need to be like very agile, right? And you should take one security control and making sure, okay, now what we do with that, right? Distroless container image to just decrease the fatigue of security threat and managing the CVE update. So at the end of the day, it's each organization, you will see where you spend the more money, the more time, and how you could have quick win to improve the security posture, right?
And to do that, if I can add, because sometimes I can understand it's very challenging if we need to invest a lot of money and time to do runtime detection, for example, or security control or stuff like that. But to take this decision, that should come from the output of the threat model. You know, when you will do the threat model of your pattern, in the output of that will be, okay, we have this list of threats, we have this list of threat actor, because that will depend about the size of the organization, what you are currently doing. You will not have the same threat actors. That could be an insider, that could be also another foreign country. We can try to attack you. And the output of that should feed your strategic plan to say, okay, now I will start to put maybe a strong emphasis on runtime detection, because we believe maybe for this critical app, maybe we have some insider and we want to have alert about that, and we will onboard the SOC team. That is my recommendation. You know, it's very challenging to take a decision, say, okay, now I invest on distroless. Okay, it's great, but maybe in reality, maybe you have some other priority. And the security priority in this case should not be driven by tech trip, if I can say that, but should drive from the business need. What the business need to deliver, and in function of that should fill your security roadmap.
Great, thank you very much.
You're welcome.
And I think to add on that, that's a key role here. It's very important. Why? Because they are doing the bridge, right? And it's not a silo. It's, okay, let's have a product roadmap. What's your roadmap here? What's the problem? Oh, you want to enforce to those guys? There are thousands of developers, and you want to inject in their Helm chart security context and the distroless base image in all their container. They will do that. They need to deliver to the business. They don't care. So how this guy could automate and understand the reality? We need to do that. But how? And those guys are here paid. That's a brand new team now, right? Yeah. And they have the bandwidth, the innovation, the budget to, okay, let's figure it out, right? So I think, to your point, those guys will have priority in the backlog in order to make sure it's compliant, but those guys are not like going down in the velocity, right? And innovation.
Yeah.
And does that make sense?
Yeah.
Any more questions?
Hi, so that was a great talk on platform engineering, but you kind of talked about shifting all that cognitive load down onto the platform team instead of left to the developers. What about a platform as a product type approach, and thinking about a co-collaboration model for actually creating some of these products, capabilities, rather than pushing it all onto the platform engineers? What's your thoughts there?
Yeah, good if you want.
And just to make sure, sorry, I didn't hear correctly. Is it more on the platform as a project?
So you didn't mention platform as a product at all.
Yeah.
You just talked about platform engineering. So what are your thoughts? Because you started to go into it there at the end, but you didn't mention it at all.
Yes, and you're right. And the talk is very mostly on security. And look at the presentation from Max. He's a security expert. There is a lot, right? So I think the point, and that's a good point, this guy should very be focused on as a product for this guy, right? And here we didn't cover that. But what we cover is if you have this platform as a product mindset, how you can abstract, right? And have the interface with this guy, because they need to understand the reality. What's your CI/CD tool? What's your application? Oh, okay, you are Java, and you need to talk to MySQL and things like this. Oh, okay, so we will supporting this golden path or use cases. And you see, so you're right, we didn't mention that, but those guys should expose the well-supported golden path and use cases, and after that, mapping that in the security control and automation we discussed. So we didn't cover that exactly, but that's the intent here, right?
And if you have an application with regulation, sometimes from what we can see from the market, it's a real disconnect from the product team to the security team. And because in this case, all the security need should come from the regulation you should to follow, and that is why in my presentation I said it's important to include that from day one. When you are starting to designing your application, try to be sure you will support all the need from the regulator, and that is something very important, because at the end, if not, you will hit some blocker from the security team, which say, okay, yeah, now for example we have I can give you a real example. For example, in PCI DSS, you have some requirement to have minimum TLS 1.2 communication in place for all the different components. But in your case, maybe in your application, you have some unencrypted communication between pods on the same namespace. But the security team will say to you, hey, in this case, you will fail. You will fail. You need to modify your design to put this TLS encryption in place. That is just a quick and simple example, but that demonstrates one challenge, and that was the conclusion also of this talk is collaboration. If you have a strong collaboration from day one with from the different actors, you will be able to deliver. To deliver at the end a better experience to your customer.
When I just add something, 2 days ago I had a talk with a large German company, and they're also going to shift. Everything is clear. Worked with the people who are already technical. They come up with some stuff and so on. But what I found out when we talked with them, first, it's not easy to get this mindset in, and second, they just missed a role of a product owner. They didn't realize now they become a product team and they have to treat infrastructure or their service as a product. And then you sit with people who are very good technically, come already up with some POCs of crossplane. And then you're like, where is your product owner? You know what I mean? To who I need to talk now on a non-technical level to find out how to talk with the other ones. So yeah, it's not that easy sometimes from a slide to the real life because,
not easy, but very important.
Yeah.
Thank you. Nice presentation, insightful. Okay, earlier we had Linux system administrators. Forget about Linux, system administrators. Now the equivalent of them, I'm seeing platform engineer and a SRE and a cloud engineer. So now is there a place where I can find out like what is the clear-cut definitions of what are these roles and what are the differences, like which is not overlapping? Can you elaborate a little bit, or at least point me to somewhere where I can know what is their roles and responsibilities and their separation?
Yeah, exactly. Cool. Thank you for the question. Platform engineering is not new. And DevOps is not dead, right? Why? Because at the end of the day, you have already all of that in your company, pretty much sure, kind of, right? You have cloud engineer, security engineer, and some people maybe SRE, observability, right? All of them are existing. The issue we have today is those people don't have the bandwidth, the time, the energy, and name it, to actually talk to those people here, thousands of developers, doing shadow IT, doing Helm, customize, Java, Docker, whatever, right? And here they are like, okay, we cannot deal with that, and we are blocking now, right? So platform engineering is saying, okay, we need a new team, a new role, doing the bridge between both of them. Those people are often coming from two worlds. You will create this team based on their developer background, so you will have some developer here, and you will have some people from here in there. Those people know the reality for both worlds. And the goal, to his point over there, is this guy will have the product, so the platform as a product mindset. How we could simplify this life and make sure we guarantee that those guys are satisfied by them, right? So it's a layer of abstraction. So it's a brand new role combined with very existing experience, right? And they know the reality. Now they have time, they have budget to actually I don't know, create a tool, create a wiki page, create whatever to answer the most pain point in order to iterate in their product and say, okay, point 2 now, let's resolve how we could do that, right? So this team is very kind of brand new, but just having the experience and the time and the money to actually resolve issue, to innovate while being compliant. So I don't know if it helps. Does it clarify a little bit, or?
Yeah. I mean, it helps me, thanks. But then, just to understand, is the cloud engineer only looks at the cloud infrastructure and SRE looks at from the application point of view?
So that's a good point. But here, you will have a lot of platforms, right? Because the reality, do you have everyone running in cloud and in Kubernetes? No. So here you will have VM, on-prem, you name it, right? You have all the stakeholders. And this guy will be, again, the interface with this guy and say, okay, we understand how to deploy there, how to leverage your tool. Please give me the recipe, and I will automate that. So those guys are very like collaborating with both sides in order to put standardization and automation, right? They are not replacing. They are just applying recipes from them.
And for a security team, it's very important to have that, because when we work with the platform engineering team, when they will, for example, create, I don't know, a sample, a POC or a sample of deployment to an application team, they will be sure, in my case, all my security control will be compliant from day one, and I will not have the effort to work with the application team to do all the remediation, all the follow-up, all this painful process, when the security team are not coming from day one. But in this case, with that, I can have an hardened template compliant at 100% from day one, and that is very great for us. Yeah. You're welcome.
Hey, thanks for this presentation. And following up on what he said, just giving like an actual example. So let's say the developer is coming up with a container image, okay? And then there's a whole bunch of libraries or whatever they're using, and one of it is the most latest and greatest version of, say, Terraform or something, and it's got a vulnerability. And on this side, you have this cloud where you can't afford to run that kind of image in the cloud because that vulnerability might just take down the service. So you're saying, like, let's say the platform engineer here is kind of like the bridge between the developer and the cloud, saying that we need to put some processes so that, hey, you cannot use this latest Terraform feature, but you gotta, downgrade because these guys cannot. Is that a good example?
That's a good example. And the guy over there asked, hey, I have people who would like to be very abstracted. They just want to ship code. And I have another kind of developer who would like to do Kubernetes and Terraform still. Yes, you will have both. But let's take the dream, where I'm a developer. I'm just focusing on my code. I don't even touch Dockerfile, right? This guy will allow in CI/CD pipeline to inject the Docker file, whatever, build pack or whatever, build the container. So all of them will provide a template. They don't know that. And here they will run Docker Compose. Oh, it's not running. Fix your application. Oh, it's running. Let's continue. Deploy on a Kine cluster locally, right? Oh, and after that, I could scan. Oh, it's not working. Fail fast. And you see, all of that is template that this guy will do. Now, oh, you have an application, and you are in this POC project. Cool, let's do this. We will go in Azure, boom. Or you are this highly standard, regulated project. We will decide to route you here, whatever. You see? So that's an abstraction. The dream is to have the abstraction of this guy writing automation and decision based on the context. Yeah. And just abstracting all of that. Because after that, you deploy, let's say, do you know Helm? Helm chart? So at the end of the day, you could ask your developer to create the Helm chart, maintain the Helm chart, or you could say, no, we have an Helm chart over there, just fill out the values. The end goal is to have a minimum values. The Helm chart is abstracted, And here, this guy is talking to the security.
Yeah.
Oh, I need to inject this security context, unprivileged, non-root, add the label, add Istio MTLS, add whatever. This guy will automate all of that. They don't know. They shouldn't know.
Yeah.
So you see the layers of injection.
Yeah. And also from the cloud side, it's impossible to keep patching every single thing with so many people with different versions.
Yeah, exactly.
So I think it's a real pain over here. So
yeah. And here you could add, are you familiar with workload identity? On Kubernetes, if you have a workload talking to a cloud SQL database, wherever it is, you want security networking, right? So you have the recipe, but this guy will help you to inject that.
Yeah,
based on the
that will
Terraform
save
script. That's
time.
not this guy doing that.
Yeah.
And when I presented the security engineer, you know, in the goal and responsibility, one pillar was standardization, you know. And if you, for example, to make a link with your example, if you provide hardened base image, hardened container base image directly to your developer, in this case, they will not come with a funny other container image pull from you don't know where, and that will introduce vulnerability. Now, if we step back and currently it's easy to provide image to your developer, you know, hardened image. The challenge you will have when you will work with third-party solution. For example, if you have in your Kubernetes cluster a telemetry solution deploy or any other third-party solution, because the vendor, in this case, they don't want to use your base image, and you need to take the time to create exclusion about that, to be sure you have a runtime security monitoring in place specifically for this image, because you don't manage this image, and this image was not built from your rules. And that is also in terms of threat, that is also very important. You know, we are seeing a lot of cluster compromission, not with third-party solution. And I will encourage you to do that. And another best practice in this case, and what a lot of companies are doing is, you know, if you can isolate all the third-party solution to another cluster directly, that is also something of very great to do. To have like a utility cluster, you know.
Thanks.
Any question? I just want to give a remark on Mathieu did not mention this, and I'm not a kingmaker, but I really like Score, so I highly recommend everybody to have a look into Score. If it helps you, it's a really nice approach, but I'm not a kingmaker, so I just mentioned it.
And tomorrow, Mathieu will do a demo of Score.
Okay,
you know,
that's then join this talk because it's interesting. You wanted to?
At the time, I will ask one more question.
Yeah, sure.
Okay, this is my point of view, just correct me if it is right. So platform engineer abstract everything for the developer, and the cloud engineer is abstracting everything in the cloud. And SRE's job is to ensure the users are happy, the applications from the user's point of view are good. Have I summarized correctly?
Yes.
Yes. But this guy have recipes. They have recipes in place. But the point, so you're right, but the point is between the intent I want to deploy to actually deploy, in the middle, someone or automation tool need to inject these recipes. So the point is to say, okay, you will help them to inject at the right time, at the right moment, at the right tool, our recipes. You will help us. You see, you're right, but it's on top of that, right?
Okay, thank you.
Because what I love, so I will add something because it's very important what you said. We always say developer experience with platform engineer, right? And platform as a product. But look at that. The developer is here, the customer is here, the product is kind of here. But guess what? Here, you have other customer. They are partner. They are your key internal stakeholder. But at the end of the day, they are also your customer. So always we talk about this developer experience, but what about this guy? Yeah. Right? Because if you are not helping the SRE with injecting the right tool, at the right moment, if you don't understand their reality, how they will debug in production. Oh yeah, but we simplified the life of the developer. But yeah, but you added a mess for us, right? So you see, and that's not easy, but that's very important. So you see the point here?
Yes, thank you. But then both of you spoke about large organizations where thousands of developers are there. So maybe they can afford to have a dozen platform engineer, a dozen cloud engineer, and a dozen SRE. But how about small and medium enterprise where maybe there's one or two DevOps engineer in the whole company? That one person is the cloud engineer, is the or maybe 3 people is a cloud engineer and platform engineer, and every operations job they have to do, right?
Yeah. So it doesn't work for small business. If you are a startup with one developer, to exaggerate, one unicorn DevOps developer full stack doing front end to Terraform, it doesn't work. You have one person. It's at scale. We are talking about hundreds, thousands of developers, right? So you need a certain maturity with a real pain point that you want to address with this kind of model. So that's a really good point. Yeah.
We need to wrap up now, Max and Mathieu. That was really great. You see, I
thank you very much for the question.
Thank you.
There's drinks and all the stuff for everybody. So yeah. Thanks.
Thank you. Thank you so much. Good job.
Thank you for moderating and